everyone and welcome to the AWS Data Engineering full course, your complete guide to building modern and scalable data pipelines using Amazon Web Services. In this course, you will explore the core concepts of data engineering and gain hands-on experience with essential AWS services like S3, Redshift, Glue, EMR, Kinesis, and Lambda, and learn how to process, transform, and manage big data efficiently in the cloud. This course bridges foundational knowledge with real-world projects to prepare you for industry-ready data engineering roles on AWS. So before we begin, please like, share, and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's AWS Certified Data Engineer Associate Training. It is thoughtfully designed to help you prepare for the DEA CO1 certification exam. This course covers the complete data engineering lifecycle on AWS, including data ingestion, transformation, storage, and security using key services like Amazon S3, AWS Glue, Redshift, and much more. This course is fully aligned with the AWS Certified Data Engineer Associate exam and gives you practical and hands-on learning with real-world AWS scenarios. So check out the course link given in the description box below. Now, let's get started with our first topic, that is, what is data engineering?
Hey, have I told you about the incredible data engineering journey of a multinational e-commerce company? No, I don't think so. What happened, Alex? Well, let me share this story with you, Bob. This company had lots of valuable data but struggled with scattered systems and outdated databases. Oh, that's a tough situation. What did they do about it, Alex? They embarked on a data engineering initiative, Bob. It was quite a journey. I can imagine. So what changes did they make, Alex? They integrated their data into a centralized system and automated data cleaning and transformation. It made a huge difference, Bob. That sounds so promising. Did it impact their operations, Alex? Definitely, Bob. They gained faster access to accurate data and generated real-time analytical reports. Impressive. Did they address data governance as well, Alex? Yes, they implemented data governance practices for data quality, privacy, and compliance. That's commendable. It's a great example of how data engineering can transform a business. What an inspiring story, Alex. Yeah, I thought you would find it fascinating, Bob. Data engineering truly has the power to drive success and innovation together. Yeah, thanks for sharing the story, Alex. It reinforces the importance of data engineering in today's data-driven world. Hello everyone, this is Sanya from Edureka, and in this video, we will be diving into the fascinating world of data engineering. So data engineering is all about harnessing the power of data to drive meaningful insights. In today's rapidly evolving digital landscape, organizations are grappling with massive amounts of data, and that's where data engineering comes into play. Now, let's take a quick look at the agenda for this video. We will start by the introduction of what data engineering is and why it is important for so many businesses outside. Then, we will delve into the key components of data engineering such as data ingestion, data integration, data transformation, and data storage. Next, we will discuss some of the responsibilities of data engineers and the comparison between data engineer, data analyst, and data scientist. After that, we will delve into the installation process of popular tools and technologies which is used in data engineering. Finally, we will wrap up with a glimpse of what data pipelines are. So, let's understand what is data engineering first. Data engineering involves the design, development, and maintenance of system and infrastructure to handle large volumes of data effectively. It focuses on the extraction, transformation, loading, and storage of data which ensure its quality and scalability of analysis. Now, let's understand what are the key components of data engineering. Data engineering helps to collect data from the disparate sources and integrate into a unified format, which allows organizations to have a comprehensive view of their data. It also involves processing and transforming data into a suitable format, which ensures data quality, consistency, and applications. It includes the development of data pipelines and processing systems that enable the efficient processing and analysis of data. This includes batch processing for large-scale data transformation and real-time processing for immediate insights and actions. Data engineering plays a crucial role in enabling data-driven world. By providing clean, integrated, and accessible data, data engineering empowers organizations to make an informed decision based on accurate insights and analysis. Overall, it is used to handle the complexity of data processing, storage, and integration, which ensures that the organization can leverage the full potential of their data assets for strategic operations and innovations. Now, after the thorough understanding of what data engineering is and its key features also, we will delve into the importance of data engineering. So, here are some of the key reasons why data engineering should be important or why data engineering is important. So, our first reason is it focuses on building scalable and efficient data processing systems. By optimizing data pipelines, leveraging distributed computing technologies, and employing performance tuning techniques, data engineers ensure that the organization can handle large volumes of data and achieve faster processing times. It provides the foundation for advanced analytics and machine learning initiatives. By structuring and preparing data in a suitable format, data engineers enable data scientists and analysts to extract valuable insights, build predictive models, and develop machine learning algorithms. Data engineering enables organizations to process and analyze data as it arrives. This is crucial in scenarios such as fraud detection, recommendation systems, IoT applications, and monitoring systems that require immediate insights and actions. As we already know the importance of data engineering, we will cover the real-world applications based on this. So our first application is e-commerce sites. So data engineering is used to collect and process large volumes of customer data, transaction data, and product data. This enables e-commerce companies to predict recommendations, optimize pricing strategies, and improve inventory management. Our second example is social media sites. Like data engineering plays a crucial role in collecting, processing, and analyzing social media data, which allows companies to monitor brand sentiment, track user interactions, and derive insights for targeted marketing campaigns. So our third example is in finance and banking sector. Data engineering is used to handle financial data, including transaction records, customer information, and market data. It enables fraud detection, risk assessment, algorithmic trading, and personalized financial services also. Okay, so now the fourth application is in the healthcare sector. Data engineering is employed to manage and analyze patient records, medical imaging data, and clinical trial data. It enables healthcare providers and researchers to gain insights, improve patient outcomes, and develop predictive models. So these examples highlight the diverse application and the importance of data engineering in various industries, demonstrating how it enables organizations to leverage the power of data for operation and innovation. Now, the data engineering process involves several key steps, including data ingestion, transformation, storage, processing, and integration. Let's discuss each step in more detail. So our first step is data ingestion. Data ingestion refers to the process of collecting and importing data from various sources into a data system or data pipeline. This can involve extracting data from databases, files, APIs, streaming platforms, or the other resources. The goal is to gather relevant data and make it available for the further processing and analysis. Second step would be the data transformation. Once the data is ingested, it often needs to be transformed into a suitable format for analysis or storage. This data transformation involves cleaning, validating, and restructuring the data to ensure consistency and usability. This step may include tasks such as data filtering, aggregation, normalization, data type conversion, or the application of business rules. So our third step would be data storage. So after the data is transformed, it needs to be stored in a structured manner, right? So this typically involves using databases or data storage systems that provide efficient storage and retrieval capabilities. Popular choices for data storage include relational databases, data warehouses, data lakes, or distributed file systems. The selection depends on the specific requirements of the project, such as data volume, SS patterns, and the analytical records. So our next step would be data processing. Data processing involves performing computations and analysis on the stored data. This step can include tasks such as data aggregation, data improvement, data summarization, statistical calculation, or machine learning algorithms. Data processing can be done through various tools such as the SQL queries, data processing engines, or the custom scripts. Next step would be the data integration. So, in this step, data integration involves combining data from multiple sources to create a unified and comprehensive view. This step is crucial when dealing with heterogeneous data sources or when different style produced data that needs to be consolidated. Data integration can be achieved through data consolidation or by using extract, transform, load process to combine and merge data from various sources. Next, our last step would be the data governance. So data governance is nothing but a framework and a set of processes which ensures the effective management and utilization of data assets within an organization. It involves establishing policies, procedures, and guidelines for data management, data quality, and data usage. All the steps in data engineering process are typically iterative and may require continuous monitoring, optimization, and maintenance to ensure data quality, reliability, and performance. Data engineers play a crucial role in designing and implementing efficient and scalable data pipelines to support data-driven applications and analytics. Now we move ahead with the key responsibilities of data engineers, which typically includes designing and developing scalable and efficient data pipelines which extract, transform, and load data from various sources to our targeted systems. Next would be the managing and optimizing data storage infrastructure for performance, scalability, and reliability. Selecting and configuring appropriate data storage technologies such as relational databases, data warehouses, or NoSQL databases to meet data storage and retrieval requirements. Data engineers are also responsible for applying data transformation techniques to clean, filter, aggregate, and structure data for analysis or consumption by downstream systems. They are also responsible for implementing data processing tasks using programming languages or data processing frameworks to manipulate and transform data efficiently. Now, after analyzing the key responsibilities of data engineering, we will proceed with our next topic and understand the key differences between these three roles, that is data engineer, data analyst, and data scientist. These three are the distinct roles within the field of data science, each with its own set of responsibilities and skill requirements. So, our first profile is of data engineer. So, data engineers are responsible for designing, building, and maintaining the infrastructure and system that enable data storage, processing, and retrieval. As we all know, they focus on creating and managing the data pipelines and architecture necessary for efficient data collection, transformation, and storage. Data engineers also work closely with software engineers and database administrators to ensure data is accessible, reliable, and scalable. They typically work with tools like Hadoop, Spark, SQL, ETL frameworks, and cloud-based platforms for data processing and storage. Then our next profile would be the data analyst. So data analysts are focused on analyzing and interpreting data to derive meaningful insights. They work with structured and unstructured data to identify patterns, trends, and correlations. Data analysts are proficient in statistical analysis, data visualization tools, and data querying techniques as well. They often use tools like SQL, Excel, Tableau, or Power BI to analyze data and create reports and dashboards. After that, our next profile would be the data scientist. Data scientists possess a blend of skills from mathematics, statistics, programming, and domain knowledge. They leverage their expertise to develop and implement complex algorithms and models to integrate data patterns or extract insights from large data sets. Data scientists employ techniques like machine learning, predictive modeling, and statistical analysis to build predictive models, uncover patterns, and make predictions also. They also collaborate with stakeholders to define business problems and design experiments to gather their data. So, to summarize this, data engineers focus on the infrastructure and data pipelines. Data analysts work on analyzing and reporting data, while data scientists concentrate on advanced modeling and extracting insights. So, to make all this happen, data engineers rely on powerful tools and technologies. Platforms like Apache Spark, Apache Kafka, SQL, and NoSQL databases, and cloud services such as AWS and GCP provides the building blocks for efficient data engineering. These tools help process vast amounts of data, facilitate real-time data streaming, and ensure secure and scalable data storage. Now, let's understand what are the data pipelines are. So here is the glimpse of what data pipelines are and why we use data pipelines. So data pipelines are the series of steps that extract, transform, and load data from source to destination itself. Okay. So they enable the efficient and automated flow of data through different stages, ensuring data quality, consistency, and availability. Let's understand each step one by one. So the first step is extraction. The extraction phase of ETL involves retrieving data from various sources such as databases, files, APIs, or streaming platforms. The goal is to extract the relevant data needed for further processing and analysis. This process typically includes establishing connection to the data sources, performing data queries, or using data extraction tools to pull the required data into the data pipeline. Next step would be the transformation. The transformation phase of ETL focuses on cleaning, validating, and reshaping the extracted data to ensure its quality and consistency. This step involves applying various operations and rules to the data, such as data filtering, data type conversions, data aggregation, data enrichment, or data normalization. The transformation process aims to make the data suitable for analysis, storage, or integration into the destination system. Next step would be the loading. The loading phase of ETL involves storing the transformed data into the targeted systems such as databases, data warehouses, or data lakes. Then the data is loaded in a structured format that aligns with the schema or format of the destination system. This phase may include tasks such as data mapping, schema matching, data partitioning, or indexing to optimize data storage and retrieval. After that, our next step would be or maybe we call it our last step would be the monitoring and handling. Monitoring and handling refer to the ongoing monitoring, management, and the maintenance of data pipelines only. Okay, so now let's discuss about batch processing and real-time streaming pipelines. So in a batch processing pipeline, there is a delay between time data is collected and when it is processed. This delay can range from minutes to hours or even days depending on the scheduled intervals. On the other hand, real-time streaming pipeline aim to process data as it arrives, which results in a minimal latency. Data is processed, analyzed in near real time or within a very low delay. The second point is batch processing pipelines are designed to handle large volumes of data efficiently. They can process and analyze massive amounts of historical data in a batch mode. On the other hand, real-time streaming pipelines focus on processing data as it arrives, making them more suitable for handling data streams with continuous high-velocity data updates. Now, the third point is batch processing pipelines typically utilize batch processing frameworks like Apache Spark or Hadoop MapReduce. These frameworks process data in chunks or batches, which allows for parallel processing and optimized resource utilizations also. While real-time streaming pipelines often use streaming frameworks like Apache Kafka, Apache Flink, or Apache Storm. These frameworks enable continuous processing of data streams, supporting low latency operations and real-time analytics. Now, the fourth point is batch processing pipelines are commonly used for tasks that involve historical analysis, generating periodic reports, or data preparation for machine learning models. They are well suited for scenarios where processing time is not critical but analyzing large volumes of data is essential. On the other hand, real-time streaming pipelines are ideal for applications that require real-time monitoring, immediate response, or instant insights based on live data. Use cases include like fraud detection, real-time recommendation systems, network monitoring, or IoT sensor data analysis. So our last point is batch processing pipelines often require significant computing resources during the processing phase as they process large volumes of data in a batch mode. Whereas real-time streaming pipelines also requires computing resources but are more focused on low latency processing and continuous data streams, requiring efficient resources allocation and management. So it's important to note that there can be the overlap between batch processing and real-time streaming pipelines, and hybrid architectures combining both approaches are common. So that wraps up our deep dive into the world of data engineering. We have covered the essential aspects of data pipelines, governance, and security, giving you a comprehensive understanding of how data is ingested, transformed, stored, and processed.
Now, how to become a data engineer? The roadmap to become a data engineer can go like from being proficient in programming languages to learning automation and scripting, then understanding your databases and mastering data processing techniques, to studying cloud computing and internalizing infrastructure. Now we'll see how to get started with becoming a data engineer. To get started with the learning process, you can look into our Edureka YouTube channel to start with. Even with no prior knowledge of data engineering, one can just go through the videos and get an understanding of the whole subject. We even have Edureka blogs to help you with detailed information on the topics and can give you a clearer picture. Apart from these, we even have premium courses which can help you understand the topic at ease with a personal trainer and 24 hours access to lifetime content. You can learn here at your own pace with a live trainer who's extremely efficient and knowledgeable and experienced in the particular field. These courses can even get you certificates which you can add in your CV for better opportunity in your job market. So that's it for today. I hope this video helped you and will help you decide how to become a data engineer.
Now I feel, Saurabh, it's the best time to tell the story about how data evolved and how big data came.
Fine, Reshma. So we'll move forward.
So Saurabh, what can you notice here?
Reshma, I see how technology has evolved. Earlier we had landline phones, but now we have smartphones. We have Android, we have iOS that are making our lives smarter as well as our phones smarter. Apart from that, we were also using bulky desktops for processing MBs of data. Now if you can remember, we were using floppies and you know how much data it can store, right? Then came hard disks for storing TBs of data, and now we can store data on cloud as well.
And similarly nowadays, even self-driving cars have come up. I know you must be thinking, why are we telling that? Now, if you notice, due to this enhancement of technology, we're generating a lot of data. So let's take the example of your phones. Have you ever noticed how much data is generated due to your fancy smartphones? Your every action, even one video that is sent through WhatsApp or any other messenger app, that generates data. Now this is just an example. You have no idea how much data you're generating because of every action you do. Now the deal is, this data is not in a format that our relational database can handle. And apart from that, even the volume of data has also increased exponentially. Now, I was talking about self-driving cars. So basically, these cars have sensors that records every minute details like the size of the obstacle, the distance from the obstacle, and many more. And then it decides how to react. Now, you can imagine how much data is generated for each kilometer that you drive on that car.
I completely agree with you, Reshma. So let's move forward and focus on various other factors behind the evolution of data. I think you guys must have heard about IoT. If you can recall in the previous slide, we were discussing about self-driving cars. It is nothing but an example of IoT. Let me tell you what exactly it is. IoT connects your physical device with internet and makes the device smarter. So nowadays, if you have noticed, we have smart ACs, TVs, etc. So we'll take the example of smart air conditioners. So this device actually monitors your body temperature and the outside temperature and accordingly decides what should be the temperature of the room. Now, in order to do this, it has to first accumulate data. From where? It can accumulate data from internet, through sensors that are monitoring your body temperature and the surroundings. So basically from various sources that you might not even know about, it is actually fetching that data and accordingly it decides what should be the temperature of your room. Now we can actually see that because of IoT we are generating a huge amount of data. Now there is one stat also that is there in front of your screen. So if you notice, by 2020 we'll have 50 billion IoT devices. So I don't think so I need to explain much that how IoT is generating huge amount of data. So we'll move forward and focus on one more factor, that is social media. Now when we talk about social media, I think Reshma can explain this better, right Reshma?
Yeah, Saurabh, but I'm pretty sure that even you use it. So let me tell you that social media is actually one of the most important factor in the evolution of big data. So nowadays everyone is using Facebook, Instagram, YouTube, and a lot of other social media websites. So these social media sites have so much data. For example, it will have your personal details like your name, age, and apart from that, even each picture that you like or react to also generates data. And even the Facebook pages that you go around liking, that is also generating data. And nowadays you can see that most people are sharing videos on Facebook. So that is also generating a huge amount of data. And the most challenging part here is that the data is not present in a structured manner. And at the same time, it is huge in size. Isn't that right, Saurabh?
Can't agree more. The point you made about the form of data is actually one of the biggest factor for the evolution of big data. So due to all these reasons that we have discussed, have not only increased the amount of data, but it has also shown us that data is actually getting generated in various formats. For example, data is generated with videos that is actually unstructured. Same goes for images as well. So there are numerous, or you could say millions of ways in which data is getting generated nowadays.
Absolutely. And these are just few examples that we have given you. There are many other driving factors for the evolution of data.
So these are few more examples because of which data is evolving and converting to big data. We'll discuss about the retail part. I'm pretty sure that all of you must have visited websites like Amazon, Flipkart, etc. And Reshma, I know you visited a lot of times.
Yeah, I do.
And suppose Reshma wants to buy shoes. So she won't just directly go buy shoes. She'll search for a lot of shoes. So somewhere her search history will be stored. And I know for sure that this won't be the first time that she's buying something. So there will be her purchase history as well, along with her personal details. And there are numerous ways in which she might not even know that she's generating data. And obviously Amazon was not present earlier. So at that time, there is no way that such huge amount of data was generated. Similarly, the data has evolved due to other reasons as well, like banking and finance, media and entertainment, etc., etc. So now the deal is, what exactly is big data? How do we consider a data as big data? So let's move forward and understand what exactly it is.
Okay, now let us look at the proper definition of big data, even though we've put forward our own definitions already. So Saurabh, why don't you take us through it?
Yes, Reshma, sure. So big data is a term for collection of data sets so large and complex that it becomes difficult to process using on-hand database system tools or traditional data processing applications.
Okay, so what I understand from this is that our traditional systems are a problem because they're too old-fashioned to process this data or something?
No, Reshma. The real problem is there is too much data to process. When the traditional systems were invented in the beginning, we never anticipated that we would have to deal with such enormous amount of the data. It's like a disease infected on you. You don't change your body orientation when you get infected with a disease, right, Reshma? You cure it with medicines.
Couldn't agree more, Saurabh.
Now the question is, how do we consider some data as big data? How do we classify some data as big data? How do we know which kind of data is going to be hard for us to process?
Well, Saurabh, we have the 5 V's to tell us that. So let's take a closer look at what are those. So starting with the first V, it's the volume of data. It's tremendously large. So if you look at the stats here, you can see the volume of data is rising exponentially. So now we're dealing with just 4.4 zettabytes of data, and by 2020, just in 3 years, it is expected that the data will rise up to 44 zettabytes, which is like equal to 44 trillion gigabytes. So that's really, really huge.
It is because all this humongous data is coming from multiple sources, and that is the second V, which is nothing but variety. We deal with so many different kinds of files at all once. There are MP3 files, videos, JSON, CSV, TSV, and many more. Now these are all structured, unstructured, and semi-structured all together. Now let me explain you this with the diagram that is there on your screen. So over here we have audio, we have video files, we have PNG files, we have JSON, log files, emails, various formats of data. Now this data is classified into 3 forms. One is structured format. Now in structured format you have a proper schema for your data. So you know what all columns will be there, and basically you know the schema about your data. So it is structured, it is in a structured format, or you can say in a tabular format. Now when we talk about semi-structured files, these are nothing but JSON, XML and CSV files where schema is not defined properly. Now when I go to unstructured format, we have log files here, audio files, videos and images. So these are all considered as unstructured files.
And Saurabh, it is also because of the speed of accumulation of all this variety of data altogether, which brings us to our third V, which is velocity. So if you look here, earlier we were using mainframe systems, huge computers but less data, because there were less people working with computers at that time. But as computers evolved and we came to the client-server model, the time came for the web applications and the internet boomed. And as it grew among the masses, the web applications got increased over the internet. And everyone started using all these applications, and not only from their computers and also from mobile devices. So more users, more appliances, more apps, and hence a lot of data.
And when you talk about people generating data over internet, Reshma, the one kind of application that strikes first in my mind is social media. So you tell me how much data you generate alone with your Instagram posts and stories.
It will be quite a boast if I only talk about myself here. So let's talk including every social media user. So if you see the stats in front of your screen, you can see that for every 60 seconds, there are 100,000 tweets, actually more than 100,000 tweets generated in Twitter every minute. Similarly, there are 695,000 status updates on Facebook. When you talk about messaging, there are 11 million messages generated every minute. And similarly, there are 698,445 Google searches, 168 million emails, and that equals to almost 1,820 terabytes of data. And obviously, the number of mobile users are also increasing every minute. And there are 217 plus new mobile users every 60 seconds.
Geez, that's a lot of data. I don't even want to go ahead and calculate the total. It would actually scare me.
Yeah, that's a lot. Now, the bigger problem is how to extract the useful data from here.
And that's when we come to our next tweet, that is value. So over here, what happens? First, you need to mine the useful content from your data. Basically, you need to make sure that you have only useful fields in your data set. After that, you perform certain analytics, or you say you perform certain analysis on that data that you have cleaned. And you need to make sure that whatever analysis you have done, it is of some value. That is, it will help you in your business to grow. It can basically find out certain insights which were not possible earlier. So you need to make sure that whatever big data that has been generated or whatever data that has been generated, it makes sense. It will actually help your business to grow and it has some value to it. Now, getting the value out of this data is one big challenge. Let me tell you why. And that brings us to our next V, which is veracity. Now, this big data has a lot of inconsistencies. Obviously, when you're dumping such huge amount of data, some data packets are bound to lose in the process. Now what we need to do, we need to fill up these missing data and then start mining again and then process it and then come up with a good insight if possible. So if you can notice, there's a diagram in front of your screen. So over here we have this field which is not defined, similarly this field, and if you can notice here, when we talk about this minimum value, you see the other minimum values, and when you talk about this, it is way more than the other fields present in this particular column. Similarly goes for this particular element as well.
Okay, so obviously processing data like this is one problematic thing, and now I get it why big data is a problem statement.
Well, we have only 5 V's now, but maybe later on we'll have more. So there are good chances that big data might be even more big.
Okay, so there are a lot of problems in dealing with big data, but there are always different ways to look at something. So let us get some positivity in the environment now, and let us understand how can we use big data as an opportunity.
Yes, Reshma, and I would say the situation is similar to the proverb, when life throws you lemons, make lemonade.
Yeah, so let us go through the fields where we can use big data as a boon. And there are certain unknown problems solved only because we started dealing with big data.
And the boon that you're talking about, Reshma, is big data analytics. First thing with big data, we figured out how to store our data cost effectively. We were spending too much money on storage before. Until big data came into the picture, we never thought of using commodity hardware to store and manage our data, which is both reliable and feasible as compared to the costly servers. Now let me give you a few examples in order to show you how important big data analytics is nowadays. So when you go to a website like Amazon or YouTube or Pandora, Netflix, any other website, so they'll actually provide you certain fields in which they'll recommend some products or some videos or some movies or some songs for you, right? So how do you think they do that? So basically whatever data that you are generating on these kind of websites, they make sure that they analyze it properly. And let me tell you guys, that data is not small. It is actually big data. Now they analyze that big data and they make sure that whatever you like or whatever your preferences are, accordingly they'll generate recommendations for you. And when I go to YouTube, I don't know if you guys must have noticed it, but I'm pretty sure you must have done that. So when I go to YouTube, YouTube knows what song or what video that I want to watch next. Similarly, Netflix knows what kind of movies I like. And when I go to Amazon, it actually shows me what all products that I would prefer to buy, right? So how do you think it happens? It happens only because of big data analytics.
Okay, so there is one more example that just popped into my mind I'll share with you guys. So there was this time when the Hurricane Sandy was about to hit on New Jersey in the United States. So what happened then? The Walmart used big data analytics to profit from it. Now I'll tell you how they did it. So what Walmart did is that they studied the purchase patterns of different customers when a hurricane is about to strike or any kind of natural calamity is about to strike on a particular area. And when they made an analysis of it, so they found out that people tend to buy emergency stuff like flashlight, life jackets, and a little bit of other stuff. And interestingly, people also buy a lot of strawberry Pop-Tart.
Strawberry Pop-Tarts? Are you serious?
Yeah. Now, I didn't do that analysis, so Walmart did that, and apparently it is true. So what they did is they stuffed all their stores with a lot of strawberry Pop-Tarts and emergency stuff, and obviously it was sold out and they earned a lot of money during that time.
But my question here, Reshma, is people want to die eating strawberry Pop-Tarts? Like, what was the idea behind strawberry Pop-Tarts? I'm pretty unsure about it. But yeah, since you have given us a very interesting example and Walmart did that analysis, we didn't do it. So yeah, so it is a very good example in order to understand how big data analytics can help your business to grow and find better insights from the data that you have.
Yeah, and also if you want to know why strawberry Pop-Tarts, maybe later on we can start making an analysis by gathering some more data also.
Yeah, that can be possible.
Okay, so now let's move ahead and take a look at a case study by IBM, how they have used big data analytics to profit their company.
So if you have noticed that earlier the data that was collected from the meters that you have in your home that measures the electricity consumed, it is actually sending data after 1 month. But nowadays what IBM did, they came up with this thing called smart meter, and that smart meter used to collect data after every 15 minutes. So whatever energy that you have consumed after every 15 minutes, it will send that data. And because of it, big data was generated. So we have some stats here which says that we have 96 million reads per day for every million meters, which is pretty huge. This data, the amount of data that is generated is pretty huge. Now IBM actually realized the data that they're generating, it is very important for them to gain something from that data. So for that what they need to do, they need to make sure that they analyze this data. So they realize that big data analytics can solve a lot of problems and they can get better business insight through that. So let us move forward and see what type of analysis they did on that data. So before analyzing that data, they came to know that energy utilization and billing was only increasing. Now after analyzing big data, they came to know that during peak load, the users require more energy, and during off-peak times, the users require less energy. So what advantage they must have got from this analysis? One thing that I can think of right now is they can tell the industries to use their machinery only during the off-peak times, so that the load will be pretty much balanced. And you can even say that time of use pricing encourages cost-savvy retail like industrial heavy machines to be used off-peak time. So yeah, they can save money as well because off-peak times pricing will be less than the peak time prices, right? So this is just one analysis. Now let us move forward and see the IBM suite that they developed. So over here, what happens? You first dump all your data that you get in this data warehouse. After that, it is very important to make sure that your user data is secure. Then what happens? You need to clean that data. As I've told you earlier as well, there might be many fields that you don't require. So you need to make sure that you have only useful material or useful data in your data set. And then you perform certain analysis.
And in order to use this suite that IBM offered you efficiently, you have to take care of a few things. The first thing is that you have to be able to manage the smart meter data. Now there is a lot of data coming from all this million smart meters. So you have to be able to manage that large volume of data and also be able to retain it because maybe later on you might need it for some kind of regulatory requirements or something. And the next thing you should keep in mind is to monitor the distribution grid so that you can improve and optimize the overall grid reliability so that you can identify the abnormal conditions which are causing any kind of problem. And then you also have to take care of optimizing the unit commitment. So by optimizing the unit commitment, the companies can satisfy their customers even more. They can reduce the power outages so that their customers don't get angry more, identify problems, and then reduce it, obviously. And then you have also to optimize the energy trading. So it means that you can advise your customers when they should use their appliances in order to maintain that balance in the power load. And then you also have to forecast and schedule loads. So companies must be able to predict when they can profitably sell the excess power and when they need to hedge the supply. And continuing from this, now let's talk about how Encore have made use of the IBM solution. So Encore is an electric delivery company, and it is the largest electrical distribution and transmission company in Texas. And it is one of the 6 largest in the United States. They have more than 3 million customers, and their service area covers almost 117,000 square miles. And they began the advanced meter program in 2008, and they have deployed almost 3.25 million meters serving customers of North and Central Texas. So when they were implementing it, they kept 3 things in mind. The first thing was that it should be instrumented. So this solution utilizes the smart electricity meters so that they can accurately measure the electricity usage of a household in every 15 minutes, because like we discussed that the smart meters were sending out data every 15 minutes, and it provided data inputs that is essential for consumption insights. Next thing is that it should be interconnected. So now the customers have access to the detailed information about the electricity they are consuming, and it creates a very enterprise-wide view of all the meter assets, and it helps them to improve the service delivery. The next thing is to make your customers intelligent. Now, since it is getting monitored already about how each of the household or each customer is consuming the power, so now they're able to advise the customers about maybe to tell them to wash their clothes at night because they're using a lot of appliances during the daytime, so maybe they could divide it up so that they can use some appliances at off-peak hours so that they can even save more money. And this is beneficial for both of them, for both the customers and the company as well. And they have gained a lot of benefits by using the IBM solution. So what are the benefits they got is that it enabled Encore to identify and fix outages before the customers get inconvenienced. It means they were able to identify the problem before it even occurred. And it also improved the emergency response on events of severe weather events and views of outages. And it also provides the customers the data needed to become an active participant in the power consumption management. And it enabled every individual household to reduce their electrical consumption by almost 5 to 10%. And this is how Encore used the IBM solution and made huge benefits out of it just by using big data analytics that IBM performed.
But let me just interrupt right now. So since Reshma told us in the beginning as well that there are no free lunches in life, right? So this is an opportunity, but there are many problems to encase this opportunity, right? So let us focus on those problems one by one. So the first problem is storing colossal amount of data. So let's discuss few stats that are there in front of your screen. So data generated in past 2 years is more than the previous history in total. So guys, what are we doing? Stop generating so much amount of data. And it is said that by 2020, total digital data will grow to 44 zettabytes approximately. And there's one more stat that amazes me is about 1.7 MB of new information will be created every second for every person by 2020. So storing this huge data in traditional system is not possible. The reason is obvious. The storage will be limited for one system. For example, you have a server with a storage limit of 10 terabytes. But your company is growing really fast and data is exponentially increasing. Now what you'll do? Now at one point you'll exhaust all the storage. So investing in huge servers is definitely not a cost-effective solution. So Reshma, what do you think? What can be the solution to this problem?
According to me, a distributed file system will be a better way to store this huge data. Because with this we'll be saving a lot of money. Let me tell you how. Because due to this distributed system, you can actually store your data in commodity hardware instead of spending money on high-end servers. Don't you agree, Saurabh?
Completely. Now we know storing is a problem, but let me tell you guys, it is just one part of the problem. Let's see a few more.
Okay, so since we saw that the data is not only huge, but it is present in various formats as well, like unstructured, semi-structured, and structured. So you not only need to store this huge data, but you also need to make sure that a system is present to store this varieties of data generated from various sources. And now let's focus on the next problem.
Now let's focus on the diagram. So over here you can notice that the hard disk capacity is increasing, but the disk transfer performance or speed is not increasing at that rate. Let me explain you this with an example. If you have only 100 Mbps input output channel and you are processing say 1 terabytes of data. Now how much time will it take? Maybe calculate, it'll be somewhere around 2.91 hours, right? So it'll be somewhere around 2.91 hours. And I've taken an example of 1 terabytes. What if you're processing some zettabytes of data? So you can imagine how much time will it take. Now what if you have 4 input output channels for the same amount of data? Then it'll take approximately 0.72 hours, or converted to minutes, so it'll be around 43 minutes approximately, right? And now imagine instead of 1 TB you have zettabytes of data. For me, more than storage, accessing and processing speed for huge data is a bigger problem. Okay, so Reshma has a very good example to discuss.
Yeah, so since you were talking about accessing the data and you told us already about how Amazon, different websites and YouTube, they make those recommendations. So if there was no solution for it, if it would take so much time to access the data, the recommendation system wouldn't work at all. And they make a lot of money just by recommendation system because a lot of people go there and click over there and buy that product, right? So let's consider that it is taking like hours or maybe years of time in order to process that big amount of data. So let's say that at one time I purchased an iPhone 5S from Amazon, and after 2 years, I'm again browsing onto Amazon, and since it took so much time to access the data and I've already switched over to a new iPhone and they are recommending me the old iPhone case for 5S. So obviously that won't work. I won't go there and click it because I've already changed my phone, right? So that will be a huge problem for Amazon. The recommendation system won't work anymore.
And I know that Reshma changes her phone every year. So if she has bought a phone and people are recommending, if she has bought a phone now and someone's recommending the case for that phone after 2 years, doesn't make sense to me at all.
Yeah, only it'll work if I have both the two phones at the same time. But yeah, I don't want to waste money on purchasing new iPhone case for my older phone.
So basically, it won't be fair if we don't discuss the solution to these problems. Reshma, we can't leave our viewers with just the problems, right? It won't be fair. What is the solution? Hadoop. Hadoop is a solution. So let's introduce Hadoop now.
Okay, so now what is Hadoop? So Hadoop is a framework that allows you to first store big data in a distributed environment so that you can process it parallelly.
There are basically two parts. One is HDFS, that is Hadoop Distributed File System for storage. It allows you to store data of various formats across a cluster. And the second part is MapReduce. Now it is nothing but a processing unit of Hadoop. It allows parallel processing of data that is stored across the HDFS. Now let us dig deep in HDFS and understand it better.
Yeah, so HDFS creates an abstraction of resources. Let me simplify it for you. So similar to virtualization, you can see HDFS logically as a single unit for storing big data. But actually you're storing your data across multiple systems, or you can say in a distributed fashion. So here you have a master-slave architecture in which the name node is a master node and the data nodes are slaves. And the name node contains the metadata about the data that is stored in the data nodes, like which data block is stored in which data node, where are the replications of the data block kept, and etc., etc. So the actual data is stored in the data nodes. And I also want to add that we actually replicate the data blocks that is present in the data nodes. And by default, the replication factor is 3. So it means that there are 3 copies of each file. So Saurav, can you tell us why do we need that replication?
Sure, Reshma. Since we are using commodity hardwares, right, and we know failure rate of these hardwares are pretty high. So if one of the data nodes fail, I won't have that data block. And that's the reason we need to replicate the data block. Now this replication factor depends on your requirements, right? Now let us understand how actually Hadoop provided the solution to the big data problems that we have discussed. So Reshma, can you remember what was the first problem?
Yeah, it was storing the big data. So how HDFS solved it, let's discuss it. So HDFS provides a distributed way to store big data. We've already told you that. So your data is stored in blocks, in data nodes, and you then specify the size of each block. So basically, if you have a 512 MB of data and you have configured HDFS such that it will create 128 megabytes of data block. So HDFS will divide the data in 4 blocks because 512 divided by 128 is 4. And it will store it across different data nodes, and it will also replicate the data blocks on the different data nodes. So now we are using commodity hardware and storing is not a challenge. So what are your thoughts on it, Saurabh?
I will also add one thing, Reshma. It also solves the scaling problem. It focuses on horizontal scaling instead of vertical. Now you can always add some extra data nodes to your HDFS cluster as and when required instead of scaling the resources of your data nodes. So you're not actually increasing the resources of your data nodes, you're just adding few more data nodes when you require. Let me summarize it for you. So basically for storing 1 TB of data, I don't need a 1 TB system. I can instead do it on multiple 128 GB systems or even less. Now Reshma, what was the second challenge with big data?
So the next problem was storing variety of data. And that problem was also addressed by HDFS. So with HDFS, you can store all kinds of data, whether it's structured, semi-structured, or unstructured. It is because in HDFS, there is no pre-dumping schema validation. So you can just dump all the kinds of data that you have in one place. And it also follows a write once and read many model. And due to this, you can just write the data once and you can read it multiple times for finding out insights. And if you can recall, the third challenge was accessing the data faster. And this is one of the major challenges with big data. And in order to solve it, we're moving processing to data and not data to processing. So what it means, Saurabh, just go ahead and explain it.
Yes, Reshma, I will. So over here, let me explain you what you mean by actually moving process to data. So consider this as our master and these are our slaves. So the data is stored in these slaves. So what happens, one way of processing this data is, what I can do is I can send this data to my master node and I can process it over here. But what will happen if all of my slaves will send the data to my master node? It will cause network congestion plus input-output channel congestion, and at the same time, my master node will take a lot of time in order to process this huge amount of data. So what I can do, I can send this process to data. That means I can send the logic to all these slaves which actually contain the data and perform processing in the slaves itself. So after that, what will happen, the small chunks of the result that will come out will be sent to our name node. So in that way, there won't be any network congestion or input-output congestion, and it will take comparatively very less time. So this is what actually means sending process to data.
So who's a big data engineer? Now, every data-driven business needs to have a framework in place for the data science and data analytics pipeline. And a data engineer is the one who's responsible for building and maintaining this framework. Now, these engineers must ensure that there is an uninterrupted flow of data between servers and applications. So in simple words, a data engineer builds, tests, maintains data structures and architectures for data ingestion, processing and deployment of large-scale data-intensive applications. Now, data engineers work in tandem with data architects, data analysts and data scientists. So they must all share these insights to other stakeholders in the company through data visualization and storytelling. But what does a big data engineer do exactly? Now, the most crucial part of a big data engineer is to design, develop, construct, install, test, and maintain the complete data management and processing systems. They are basically the ones who handle the complete end-to-end infrastructure for data management and processing. They build a pipeline for data collection and storage and funnel the data to data analysts and scientists. So basically what they do is they create the framework to make data consumable for data scientists and analysts so they can use the data to derive insights from it. Note that the data engineers are the builders of data systems and not those who mine for insights. So the data engineer works more behind the scenes and must be comfortable with other members of the team producing business solutions from this data. Now, all their responsibilities revolve around this. They need to take care of a lot of things while performing these activities. Hence, one of the most sought after skills in data engineering is the ability to design and build data warehouses. This is where all the raw data is collected, stored, and retrieved from. Without data warehouses, all the tasks that a data scientist does will become obsolete. It is either going to get too expensive or very, very large to scale. Now, data engineers should always keep in mind that the system which he or she builds needs to be scalable, robust, and fault tolerant so that the system can be scaled up without increasing the number of data sources and can handle a huge amount of heterogeneous data without any failure. Now imagine a situation wherein the source of data is doubled or tripled, but the system cannot scale up. Will it not cost a lot more time and resources to build the same system again, which is suitable for this kind of intake? Exactly. This is why the big data engineers have a role here. Next, he or she is the one that handles the extract, transform, and load process, which is basically the blueprint for how the collected raw data is processed and transformed into data ready for analysis. Now you're going to acquire a lot of data from different sources. How do you bring them together to one platform? ETL is your answer. Apart from all this, a data engineer should always aim at deriving insights by acquiring data from new sources. Some of the responsibilities of a data engineer also include improving data foundational procedures, integrating new data management technologies and the software into existing systems, and building data collection pipelines. And finally, one of the major roles of a data engineer is to include performance tuning and make the whole system way more efficient, which is pretty self-explanatory if you ask me. Now, most of us have some idea about who a big data engineer is, but there's still some confusion about their responsibilities. Now, this ambiguity further increases when we gain more information about the role. Now, let me help you debunk all your queries about it. So let's talk about some big data engineer responsibilities. First up, we have data ingestion. Now, this is associated with the task of getting data out of the source systems and ingesting it into a data lake. Now, a data engineer would need to know how to efficiently extract the data from a source, including multiple approaches for both batch and real-time extraction, as well as needing to know about the incremental data loading, fitting within small source windows, and parallelization of data loading as well. Now, another small subtask of data ingestion is data synchronization. But because it's such a big issue in the big data world, we are going to talk about it. Now, since Hadoop and other big data platforms don't support incremental loading of data, a data engineer would need to know how to deal with detecting changes in the data source, merge and sync changed data from sources into the big data environment. Next, we have data transformation. This is basically the T in the extract, transform, and load that we had discussed earlier. It is basically focused on integration and transformation of data for a specific use case. Now, a major skill set here is the knowledge of SQL. As it turns out, not much has changed in terms of the type of data transformations that people are doing now compared to purely relational environments. Now, imagine all this data that you've acquired from various sources. What would you have to do to make them all palatable in the same platform? You need to transform that data, and this is what a data engineer does here. And finally, we have performance optimization, which is one of the tougher areas because anyone can build a slow-performing system. The challenge is to build data pipelines that are both scalable and efficient. So the ability and understanding of how to optimize the performance of an individual data pipeline and the overall systems are a higher level of data engineering skill. Now, for example, big data platforms continue to be challenging with regard to query performance and have added complexity to a data engineer's job. In order to optimize performance of queries and creation of reports, the data engineer needs to know how to denormalize, partition, and index data models. He also needs to understand tools and concepts regarding in-memory models and OLAP cubes. Now let's quickly move ahead and look at the required skills to fulfill these responsibilities. Now we'll be going through these skills in a clockwise order, so starting with big data frameworks. Now, with the rise of big data in the early 21st century, a new framework was born, and that is Hadoop. All thanks to Doug Cutting for introducing this framework. It not only stores big data in a distributed manner, but also processes the data parallelly. There are several tools in the Hadoop ecosystem which cater differently for different purposes and professionals. For a big data engineer, mastering big data tools is a must. Some of the tools which you will need to master, first of all, you have HDFS, which is the storage part of Hadoop. Being the foundation of Hadoop, knowledge of HDFS is a must to start working with Hadoop framework. Next, we have Yarn, which performs resource management by allocating resources to different applications and scheduling jobs. Now, MapReduce is a parallel processing paradigm which allows data to be processed parallelly on top of the HDFS. Next, we have Pig and Hive. Now, Hive is a data warehousing tool on top of HDFS which caters to professionals from an SQL background to perform analytics on top of HDFS, whereas Apache Pig is a high-level platform which is used for data transformation on top of Hadoop. Now, Hive is generally used by data analysts for creating reports, whereas Pig is used by researchers for programming. Both are pretty easy to learn if you're already familiar with SQL. Next, we have Flume and Sqoop. Flume is a tool which is used to import unstructured data to HDFS, and Sqoop is used to import and export structured data from RDBMS. Now next we have Zookeeper, which acts as a coordinator among the distributed services running in a Hadoop environment. It basically helps to configure management and synchronize services. And finally, we have Oozie, which is basically a scheduler which binds multiple logical jobs together and helps in accomplishing a complete task. Next up, we have real-time processing frameworks. Now, real-time processing with quick actions is the need of hour. Either it is a credit card fraud detection system or a recommendation system. Now, imagine if you wanted a red dress today and Amazon decides to suggest it to you a month later. Now, wouldn't that be completely useless for you? In this case, you need real-time processing. It is very important for a data engineer to have knowledge of real-time processing frameworks. Now, Apache Spark is one of the distributed real-time processing frameworks which is used in the industry rigorously. It can be easily integrated with Hadoop leveraging HDFS as well. Next, we have DBMS. Now, a database management system stores, organizes, and manages a large amount of information within a single software application. Now, data engineers need to understand the database management system to manage data efficiently and allow users to perform multiple tasks with ease. This will help data engineers in improved data sharing, data security, data access, and better data integration with minimized data inconsistencies. These are the fundamentals that data engineers should know prior to building a scalable, robust, and fault-tolerant system. Next, we have SQL-based technologies. Now, there are various relational databases that are used in the industry, such as Oracle DB, Microsoft SQL Server, etc. Now, data engineers must have at least the knowledge of one such database. Now, knowing SQL is also a must. This structured query language, as SQL is also known as, is used to structure, manipulate, and manage data stored in relational databases. As data engineers work closely with RDBMSs, they need to have a strong command on SQL. Now next, we have NoSQL technologies. As the requirements of organizations have grown beyond structured data, NoSQL databases have been introduced into this environment. It can store large volumes of structured, semi-structured, or unstructured data with quick iteration and agile structure as per application requirements. Some of the most prominently used databases are HBase, Cassandra, and MongoDB. Now, HBase is a column-oriented NoSQL database on top of HDFS, which is great for scalable and distributed big data stores. It is also great for applications with optimized read and range-based scan, and it provides consistency and partitioning out of CAP. Now, Cassandra is a highly scalable database with incremental scalability, and the best part about Cassandra is the minimal administration and no single point of failure. It's good for applications with fast and random read and writes. It provides available and partitioning out of CAP. And finally, we have MongoDB, which is basically a document-oriented NoSQL database, which is a schema-free database. It gives full index support for high performance and replication for fault tolerance. It has a master-slave sort of architecture and provides CP out of CAP. It is rigorously used by web applications and semi-structured data handling. Next, we are going to discuss programming and scripting languages. So various programming languages can serve for the same purpose. So knowledge of one programming language is enough. I'm saying this because the flavor of language may change, but the logic remains the same. If you're a beginner, you can go ahead with Python as it is an easy language to learn due to its syntax and good community support. Whereas R has a steep learning curve which is developed by statisticians and it is mostly used by analysts and data scientists. The next skill we're going to discuss is an important one. It is ETL or data warehousing. Now, data warehousing is very important when it comes to managing a huge amount of data coming in from heterogeneous sources where you need to apply extract, transform, and load. Now, data warehousing is used for analytics and reporting and is a very, very crucial part of every business intelligence solution because this is the part which is going to take you most time. Now, it is very important for a big data engineer to master one data warehousing or ETL tool. After mastering one, it becomes pretty easy to learn new tools and as the fundamentals remain the same. Now, Informatica, ClickView, and Talend are very well-known tools used in the industry. Informatica and Talend Open Studio are data integration tools with ETL architecture. The major benefit of Talend is its support from the big data frameworks. If you're new to data warehousing and ETL tools, I would definitely recommend you start with Talend because after learning this, any data warehousing tools will become a piece of cake. And finally, we have our operating systems. Now, intimate knowledge of Unix, Linux, and Solaris is very helpful as many mathematical tools are going to be based off of these systems due to their unique demands for root access to hardware and operating system functionality above and beyond that of Microsoft's Windows or Mac OS. Now, some level of understanding of how to act upon this data is also very valuable for data engineers. For this reason, some knowledge of statistical analysis and the basics of data modeling are also hugely valuable. Knowledge of machine learning in cloud also will serve as a big plus. While machine learning is technically something relegated to a data scientist, knowledge in this area is helpful to construct solutions usable by your cohorts. Now, this knowledge has the added benefit of making you extremely marketable in this space as being able to put on both hats, in which case makes you a really formidable tool.
What is actually a Hadoop ecosystem? Okay, the very first thing is Hadoop ecosystem is not one tool. It's not a programming language or it's not a single framework. It is a group of tools that are there which are used together by various companies in various domains for different tasks. Okay, Hadoop alone cannot provide all the facilities or services that are required to process the big data. Okay, so like for example, Hadoop can store big data, Hadoop can process big data up to a certain limit. However, there are much more other requirements that are there. For example, we would like to create recommendation engines over big data. We would like to run clustering algorithms over big data. We would like to get the real-time insights using big data itself because Hadoop is a batch processing framework, right? So if I want a real-time insight, I would need another tool that can run over HDFS, that can utilize and leverage HDFS, right? The basic thing that you need to understand here is one single tool like Hadoop is not going to solve all your problems. You'll have to use various other tools over Hadoop or along with Hadoop to get rid or get the solution of every problem that you have. Okay. But before that, before doing so, it is important that you know what are the different tools that are there which can work with Hadoop. And in today's session, we'll exactly do that. We'll try and find out what are the various tools that are there which can be used with Hadoop and what functions they can perform in their own domains. We'll now move on to the next slide. Okay, the very first tool that we'll understand is HDFS. Now, as you know, HDFS is nothing but Hadoop Distributed File System. It is the storage unit of Hadoop. HDFS is entirely the Hadoop cluster which is formed by data nodes. Data nodes are nothing but commodity hardwares which are cheap hardwares which can be clustered together using the Hadoop framework, and then an entire file system that gets created on which you can store big data is called Hadoop Distributed File System. Using HDFS, you can store any kind of data, be it structured, be it unstructured, or be it semi-structured. Okay. Now, once you store the data in HDFS, you can view the entire data as a single unit as well. HDFS stores data across various nodes. These nodes are nothing but the data nodes, and it also maintains the log files of what data is stored at which position. So basically, HDFS has got two components. One is the name node and other is the data node. Name node is the one which manages the entire cluster, which manages the entire set of data nodes and keeps the information, keeps the metadata of the data that is stored in these data nodes. Data nodes, on the other hand, are the slave machines, the commodity hardwares which actually stores the data. So HDFS is the one which solves the primary problem of storing big data. So it's time we move on and explore the next tool in Hadoop ecosystem, which is Yarn. Now we'll explore Yarn. Now, as the name suggests, it is nothing but a resource negotiator. Okay. The main purpose of Yarn is to allocate resources to run particular tasks over the Hadoop cluster. So Yarn has basically two components. One is the resource manager and the other one is the node manager. As soon as the client submits a job, these resources are nothing but the containers in which the jobs can be executed. Okay. Node manager is the one which finally executes the job within these containers and manages the entire thing on the data nodes. Okay, so the resource manager is the master daemon and the node manager is the slave daemon. Apart from that, I would like to tell you one important thing about Yarn. Yarn was introduced in Hadoop 2.0, which enabled various ecosystem tools to connect with Hadoop distributed file system and leverage big data. Okay, so we'll understand this better when we come to the MapReduce slide. Okay, we'll move on to the next slide. So we now come to MapReduce, which is the processing unit of Hadoop. So once the data is stored on Hadoop distributed file system, the next task is to process that data. For doing so, one can use Apache MapReduce. In Hadoop 1.x, MapReduce was the only framework that can be used to process the distributed data that is present on HDFS. However, so Yarn was the next layer over HDFS, and MapReduce now connected with Yarn to allocate resources for executing the MapReduce task. Similarly, many other ecosystem tools or databases now can connect with Yarn and leverage HDFS. Okay, so it happened after Yarn. So essentially it has got two functions. One is the map and the reduce. Map function is used for filtering, grouping and sorting kind of functions, and the result of the map function is then aggregated in the reduce phase, and the entire summarized result is dumped on the HDFS itself. So this is how Hadoop MapReduce works. Now it's time we move on to the next slide and we'll explore what is Apache Pig. Apache Pig was a tool that was developed at Yahoo. So it is nothing but a data processing tool that runs over Hadoop, or you can say that it sits on top of the Hadoop. Apache Pig has its own language that is called Pig Latin, which is nothing but a data flow language, or you can call it as an instructional language. For example, if you want to load a data, you have a command like load this data from path, and then you can dump that data or perform various functions like filter or group. Okay. So using Pig Latin, the life of the developers became very easy. They need not write the entire full MapReduce job for executing some processing over the big data. For people who cannot write a MapReduce program or were not comfortable with MapReduce, for them Pig Latin came as a blessing. Or for them, Pig came as a blessing. By using Pig, the task for them became very easy and they were able to leverage big data. It is said that approximately one line of Pig Latin is equals to 100 lines of MapReduce. So just think how much time are you saving there. Okay. You can perform all the ETL operations that you would like to execute over big data using Pig. So I hope this gives you a clear picture how Apache Pig came into picture. What is the importance of Apache Pig? Okay then, we'll move on and explore the next tool in the chain, that is Apache Hive. Apache Hive is one of the most important tools that is there in the Hadoop ecosystem. Apache Hive was developed at Facebook. Now the idea behind Apache Hive was the time when it was developed, the relational databases were flourishing. These were the databases that were used by most of the organizations, most of the companies. Nobody knew about NoSQL or a file system like Hadoop. Even Facebook had its website on MySQL. So the workforce there mostly was working on MySQL or SQL-like queries or PL/SQL. So for Facebook, it was a problem because their workforce was skilled in SQL. However, for writing a MapReduce program, you had to know some other programming language. So what Facebook did is, Facebook came up with a tool that is called Hive, using which you can write SQL-like queries, that is called Hive query language, and execute the same task over the Hadoop cluster and leverage big data. Just like Pig, using Hive, you can write simple SQL-like queries, and the task that you were executing using MapReduce now can be executing using Hive without getting into the complexities of MapReduce. Okay. Even using Hive, you can connect from client applications like Java as well if you have that requirement. Okay, so Hive is one important tool that is used by a lot of people out there who do not want to get into writing the MapReduce program. So let's move on to the next tool, that is Mahout and Spark MLib. Mahout is a machine learning library written in Java. It can be used for creating recommendation engines or clusters of data, or classify your data into various groups. Okay, so all those algorithms that are there in machine learning can be implemented over big data using Mahout. Okay, so it provides you a command line interface to achieve the same task. You would have heard about an analysis that is called market basket analysis, which can be easily executed using Mahout over big data. The various other things like recommendation engine, as I mentioned, which you would have seen in many e-commerce websites like Amazon, Flipkart, or many more. Okay, so all those things can be done using Mahout. Now we come on to Spark, which is a leading tool in the Hadoop ecosystem. MapReduce and Hadoop together can only be used for batch processing. That means you're not getting the results in real time. But out there is a requirement for real-time analytics as well, which cannot be done using Hadoop MapReduce, right? In that case, Sparks come into the picture, which can run standalone as well as it can run over the Hadoop cluster and leverage the same big data to provide you real-time insights, right? As well as Apache Spark is almost 100 times faster than Apache MapReduce. Okay, so I hope this excites you, right? So we'll move on to the next slide and explore Apache HBase. So what is Apache HBase? Apache HBase is a NoSQL database that runs over Hadoop. Apache HBase can be used for storing any kind of data that is there. Okay, it could be any structured or unstructured data, and Apache HBase has been modeled after Google Bigtable and can be utilized to store any big data that is there in Hadoop file system. With Apache HBase, you have an advantage, that is you can use HBase as a backend for a website or a web application to query in real time, which cannot be done with tools like Pig, Hive, or MapReduce, or even HDFS. And hence it is a very important addition to Hadoop ecosystem. Okay, so guys, are you clear with this? You can also write a Java application and connect with HBase using the REST APIs, Thrift APIs, or Avro APIs. Okay, now we'll go through another tool that is called Apache Drill. Apache Drill is again an open source application which works well with any distributed environment that is out there. It can work with any NoSQL database or a flat file system. Okay, the advantage with Apache Drill is that it can connect with various NoSQL databases or a flat file system or a simple file itself at the same time. So if you have data stored in various sources, like let's say you have a data stored in Hadoop distributed file system, you have a data stored in HBase, you have a data stored in MongoDB. Every one of them has their own syntax to execute queries on them to retrieve the same set of records. However, using Apache Drill, you can connect to all these databases at a single time, execute one query, and extract the results from all the three databases and use it for your application. Okay, Apache Drill is able to do that because it follows the ANSI SQL, which enables you to write a query that can execute or that can be understood by all the three databases. We'll move on to the next slide, and now we'll explore 𝐄𝐶. Apache 𝐄𝐶 is nothing but a scheduler in the Hadoop ecosystem. Now what does it mean? Let's say you have a MapReduce task that needs to be executed every hour. Now in that case, instead of manually triggering it, what you can do is you can define a workflow in 𝐄𝐶 and schedule your task to be executed after every 1 hour. Okay, when you see, you're doing two things. One is you're defining a workflow that could be one task or it could be a combination of tasks that are executed by various tools like MapReduce, Hive, Pig, etc. in a sequence, as well as you're defining the frequency in which the workflow needs to be executed. Okay, so your life becomes very easy. You need not go and execute or trigger your job every time that it needs to be done. 𝐄𝐶 can do it for you. Along with that, 𝐄𝐶 coordinator is another component that is present in 𝐄𝐶, which ensures that the job or the workflow is only executed when the data is available. So at times, if the data is coming from an external source, automatically it will ensure that as soon as the data is in the system, then only the workflow or the job is executed. So it is an event-based execution that can be triggered using 𝐄𝐶. Okay, let's move on, and we come to Flume. Flume is again one of the most widely used tools which is used for data ingestion into HDFS. Okay, so using Flume you can ingest any kind of data. It could be structured, it could be semi-structured into the Hadoop distributed file system and perform various processing after that. Flume gives you the capability of extracting data out of social media like Twitter, Facebook, or you can also extract data from servers where logs are getting generated on a regular interval. So Flume can be utilized to extract data from there and move into the HDFS. Okay. Similarly, there could be many other use cases like getting email messages or network traffic, etc. The next tool in the order is Sqoop. Sqoop is again used for data ingestion. However, Sqoop is used between relational database and the HDFS. So using Sqoop, you can move your data from your relational database into HDFS and vice versa. That means you can also move data out of HDFS into an RDBMS. So it mostly deals with structured data. Okay. So if you compare Flume with Sqoop, Flume is mostly used for moving data into the HDFS and deals with streaming data most of the time. However, Sqoop works with structured data and it can move data in and out of HDFS, unlike Flume. So let's move on, and we come to the next tool, that is Solar and Lucene. Okay, so Solar and Lucene is again an Apache project which has been developed in Java. Lucene in itself is a Java library which is for developing search engine and indexers. Okay, Apache Solar is an application that is built using Apache Lucene. So if you want to develop a search engine or you want to implement search onto your website which works very fast using indexing, you can always use Apache Solar to do that. Okay, so this is the main purpose of Apache Solar, which is an application which is developed using Apache Lucene. We come to Zookeeper. As the name suggests, the job of Zookeeper is to ensure coordination between various tools that are there in the Hadoop ecosystem. Okay, so the main purpose of Zookeeper is to ensure that each and every tool is able to communicate with each other without any interruption, so that the entire ecosystem works together in achieving a particular task. Okay, it performs synchronization, it performs configuration management, grouping and naming of all these things. Okay, it also manages all the services that are running in the Hadoop cluster. Okay, so Zookeeper is very important component of Hadoop cluster. If Zookeeper is not there, your services, your daemons, your tools will not be able to interact with each other or communicate with each other, and hence you will get a broken system if Zookeeper fails. Now we come on to the final tool, that is Apache Ambari in the Hadoop ecosystem that we are going to discuss today. So Apache Ambari is a cluster manager. Okay, what does a cluster manager mean, or what does a cluster manager do? Cluster manager manages the Hadoop cluster. Okay, using Apache Ambari you can provision, manage and monitor the Apache Hadoop clusters. Okay, It makes very easy for you to set up a Hadoop cluster and then configure all the services that needs to run over the Hadoop cluster. It could be Apache Spark service, it could be a Hive service, it could be any other service that you need over the cluster, and it can be done very easily using Apache Ambari. So this was basically developed by Hortonworks. A similar tool is developed by Cloudera as well, which is called Cloudera Manager. Okay. However, Cloudera Manager is not an open source tool like Apache Ambari. So Apache Ambari was developed by Hortonworks. However, it was given to Apache later on. A similar tool, which is a proprietary tool developed by Cloudera, named as Cloudera Manager, using which you can deploy the Cloudera clusters. However, it is a paid service. Okay. Using Apache Ambari, you can also monitor health and status of your Hadoop cluster. Okay. Now you know the importance of Apache Ambari and how it can be used to make your life easy.
Now, let's dive into the deployment and management services that streamline the process of deploying and managing applications in the cloud. So let's begin with the application services, which provide essential tools for building and scaling applications effectively. So first on the list, we have Amazon SQS, which stands for Simple Queue Service. Amazon SQS is a fully managed message queuing service that enables decoupling and scaling of microservices, distributed system, and serverless applications. It allows you to transmit any volume of data without losing messages and without requiring other services to be always available. Next, we have Amazon Elastic Transcoder. Amazon Elastic Transcoder is a media transcoding service in the cloud. It is designed to be highly scalable, easy to use, and cost-effective way for developers and businesses to convert media files from their source format into versions that will play back on devices like smartphones, tablets, and PCs. And then we have Amazon SES, which stands for Simple Email Service. Amazon SES is a cloud-based email sending service designed to help digital marketers and application developers send marketing notification and transactional emails. Next, Amazon AppStream. Amazon AppStream 2.0 is a fully managed application streaming service that allows you to centrally manage your desktop applications and securely deliver them to any computer. And then we have Amazon Cloud Search. Amazon Cloud Search is a managed service that makes it simple and cost-effective to set up, manage, and scale a search solution for your website or applications. Next, we have mobile services designed to enhance mobile application development and user engagement. So first on the list is Amazon Cognito. Amazon Cognito provides authentication, authorization, and user management for web and mobile apps. Your users can sign in directly with a username and password or through a third party like Facebook, Amazon, or Google. Next, we have Amazon Mobile Analytics. Amazon Mobile Analytics helps you to collect, visualize, and understand app usage data at scale. It provides insights into how users engage with your app, enabling data-driven decisions. And then we have Amazon SNS, which stands for Simple Notification Service. So Amazon SNS is a fully managed messaging service for both application to application, which is A to A, and application to person, which is A to P communication. Moving forward, we have enterprise applications. Enterprise applications offer robust solutions for business productivity and collaboration. So first on the list, we have Amazon WorkDocs. Amazon WorkDocs is a secure and fully managed cloud-based content creation, storage, and collaboration service. It allows users to create, edit, and also share content seamlessly. And then we have Amazon Workspaces. Amazon Workspaces is a managed, secure desktop as a service solution. It allows you to provide virtual, cloud-based Microsoft Windows or Amazon Linux desktops for your users. Next, Amazon Workmail. Amazon Workmail is a secure, managed business email and calendar service with support for existing desktop and mobile email clients. Earlier, we touched on application services as part of deployment and management, which were services that support the operational side of running applications like messaging, transcoding, and email delivery. Now in this section, when we say application services, we are shifting our focus on the tools and platforms used for actually building, running, and scaling modern applications. So these are the core components developers and architects use directly in application development. Now, let's dive into administration and security services that ensure our AWS environment remains secure and well managed. So first on the list, we have AWS Directory Service. AWS Directory Service provides multiple ways to use Microsoft Active Directory, that is AD, with other AWS services. It enables your directory-aware workloads and AWS resources to use managed Active Directory in the AWS cloud. Next is AWS IAM, which is Identity and Access Management. AWS IAM enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. Next, AWS Trusted Advisor. AWS Trusted Advisor is an online resource to help you reduce cost, increase performance, and improve security by optimizing your AWS environment. Next, we have AWS Config. AWS Config provides a detailed view of the configuration of AWS resources in your AWS account. It enables you to assess, audit, and evaluate the configuration of your resources. Next is AWS Cloud Trial. AWS Cloud Trial records AWS API calls for your account and delivers log files to you. It provides visibility into your activity by recording actions taken on your account. Then we have Amazon CloudWatch. Amazon CloudWatch is a monitoring and observability service built for DevOps engineers, developers, site reliability engineers, and IT managers. Following that, deployment and management services streamline the process of deploying and managing applications in the cloud. So first on the list, we have Amazon CloudFormation. Amazon CloudFormation gives developers and system administrators an easy way to create and manage a collection of related AWS resources, provisioning and updating them in an orderly and predictable fashion. Then we have AWS OpsWorks. AWS OpsWorks is a configuration management service that manages instances of Chief and Puppet. It helps you automate how servers are configured, deployed, and managed across your Amazon EC2 instances or on-premises compute environments. Next, AWS Code Deploy. AWS Code Deploy is a service that automates code deployment to any instance, including Amazon EC2 instances and instances running on-premises. Analytics services are up next. It enables us to process and analyze vast amount of data for insightful decision making. So first here on the list, we have Amazon Kinesis. Amazon Kinesis makes it easy to collect, process, and analyze real-time streaming data so you can get timely insights and react quickly to new information. Next, AWS Data Pipeline. AWS Data Pipeline is a web service that helps you reliably process and move data between different AWS compute and storage services. Next, Amazon EMR, which is Elastic MapReduce. Amazon EMR is a cloud big data platform for processing massive amounts of data using open source tools such as Apache Spark, Hadoop, and Presto. Finally, let's explore the foundation services that form the backbone of AWS, supporting various computing, storage, databases, and networking needs. So let's explore compute services that provide the backbone for running applications and processing workloads. So first we have Amazon EC2, which is Elastic Compute Cloud. Amazon EC2 provides scalable computing capacity in the AWS cloud. It allows you to run virtual servers and manage them as needed. Next, AWS Lambda. So AWS Lambda lets you run code without provisioning or managing servers. So you pay only for the compute time you consume. Next services are storage and content delivery. Storage and content delivery services are crucial for storing data securely and delivering content swiftly to users. So first on the list, we have Amazon CloudFront. Amazon CloudFront is a fast content delivery network service that securely delivers data, videos, applications, and APIs to customers globally with low latency. Next, Amazon Glacier. Amazon Glacier is a secure, durable, and low-cost cloud storage service for data archiving and long-term backup. Next, AWS Storage Gateway. AWS Storage Gateway is a hybrid cloud storage service that gives you on-premises access to virtually unlimited cloud storage. Next, Amazon Content Delivery. Amazon Content Delivery services enable efficient distribution of content to end user, ensuring high availability and performance. Next is database. Database services offer scalable and reliable solutions for storing and retrieving structured and unstructured data. So on the list we have Amazon DynamoDB. Amazon DynamoDB is a key value and document database that delivers single-digit millisecond performance at any scale. Next, Amazon RDS, which is Relational Database Service. Amazon RDS makes it easy to set up, operate, and scale a relational database in the cloud. Next is Amazon Redshift. Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost-effective to analyze all your data. Next, we have Amazon Elastic Cache. Amazon Elastic Cache adds caching layers on top of your databases to help improve the read times of your applications. Finally, networking services connect all the components, ensuring seamless communication and data transfer across the AWS ecosystem. So first we have Amazon Route 53. Amazon Route 53 is a scalable and highly available domain name system web service. Next, Amazon VPC, which is Virtual Private Cloud. Amazon VPC lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network. Next, AWS Direct Connect. AWS Direct Connect allows you to establish a dedicated network connection from your premises to AWS. Now that we have explored the various AWS services integral to data engineering, so let's examine how leading companies leverage these tools to drive innovation and efficiency. So AWS data engineering tools are integral to the operations of leading organizations across various industries. These services enable companies to process vast amount of data efficiently, derive actionable insights, and maintain a competitive edge. BMW Group processes over 10 terabytes of data daily from its global vehicle fleet using AWS services like Amazon Kinesis, AWS Glue, and Amazon SageMaker. This infrastructure supports real-time analytics and powers features such as voice-activated in-car assistance. Next, Capital One utilizes AWS to transform data into insights through machine learning, allowing for rapid innovation and enhanced customer experiences. Then, iFood leverages AWS to accelerate development, reduce cost, and enhance its chat experience by building a virtual assistant using generative AI technologies. Next, Fujitsu selected AWS CloudFormation for its data orchestration needs, emphasizing data security and efficient access control in their data utilization platform. So these examples shows the versatility and robustness of AWS data engineering services in addressing complex real-time data challenges across various sectors. So there you have it, a complete walkthrough of a key AWS services used in data engineering, from data ingestions to security. In real-world projects, you might ingest data using Kinesis, store it in S3, clean and transform it with Glue or EMR, and visualize it through 𝐄𝐼𝐶, all orchestrated via step functions. At the same time, IAM and CloudWatch keep it secure and visible. That's the power of AWS in data engineering.
So EC2 is a service that provides scalable virtual servers in the cloud, and these virtual servers in the AWS environment are referred to as instances, and they can be made up of different instance types and sizes. So by instance type and sizes, I mean that it describes the hardware component that an EC2 instance would run on. So this would include your number of processes, amount of memory, network performance, and so on. And within EC2, the service is highly scalable, and you can opt in for pay-as-you-go model. So in the later part of the session, we'll talk about various purchasing options that are available within EC2. So the most commonly used one is pay-as-you-go, And there are other options available wherein you get significant discounts if you put in a commitment for a time duration and you're willing to pay some upfront cost. The full form of EC2 is Elastic Compute Cloud. So coming back to various instance types, so as I said, we specify the various hardware components that your instance would run on, and that would include your processors, memory, network performance. So as a solution architect, it's very important to use the proper instance type to handle your application's workload. There's a predefined collection of instance types that are grouped into families and types that you can choose from. And very shortly, we'll see that in the demo. So a couple of benefits of EC2. I'd been performing demos wherein I was able to spin up a virtual instance in under 2 minutes. So it's pretty easy, flexible, it is scalable. So in isolation, the scalability is not achieved. So I believe in the next session, when I talk about auto scaling, that is part of the EC2 services, you can achieve the scalability aspect wherein you can automate the entire process. Let's say you have defined a threshold that if the traffic exceeds X percentage or CPU utilization exceeds X percentage, you can spin up more number of resources. Service is fully reliable in the sense, if you do it right, if you configure it right, you will see known downtime. So recall, we have this first session, we had said that your workloads should be distributed across multiple availability zones. So define health checks. Even if an instance goes down, a new instance can come up on the fly and you can set it up in the operational state. With respect to security, there are tools and methods available in form of security groups so that you can filter both incoming and outgoing traffic. And it is inexpensive, so you go by an hourly rate. So that way, if you want to do a test for a couple of days, just pin up the instances for a couple of days, and that's about it, and you only end up paying for that period. So in the context of EC2, the first term that we need to be aware of is AMIs. AMIs stand for Amazon Machine Images. So Amazon Machine Image is actually a template that is required to launch a EC2 instance. And the template includes the information such as operating system, any application software packages on top of that particular operating system. So that's the prerequisite. The first step of provisioning your instance is to either pick up an AMI that is available with Amazon, or you can create your own AMIs. So I've logged into the AWS console and we'll go to the EC2 dashboard. So EC2, first of all, is a region specific service. So make sure you are in the right region in which you want to provision your virtual servers. And as I said, you can pick up AMIs either from Amazon. So there are multiple options out here. So during the launch process, as a first part of the process, you'll have to select an AMI. So there's a quick start section, which includes the most commonly used AMIs. So you'll have Amazon Linux distribution, and it would give you the details, what are the application packages on top of this operating system. So for most part of it, we'll be using Amazon Linux AMI. And in this case, it has Python, Ruby, Perl, and Java already pre-baked into this template. So likewise, there are a set of AMIs that are available, and please note that only pick up the AMIs that are eligible for free tier. Then you have My AMI section. So these are the custom AMIs that you can build. So either you can build your own AMIs, pick it up from the quick start section. And additionally, there are a lot of options available in the AWS marketplace. So it is very similar to your Play Store and App Store, wherein you get a lot of options available. So for example, you are looking for an endpoint protection software. So you already have a pre-baked AMI for it. So over and above the cost of the EC2 instance, usage of this AMI would cost you like 1 cent per host per hour. So there are a good number of options available. So let's say you want to find Tableau, which is a BI tool. So you have most of the options available out here. So in a rare case, you don't find a software appliance in the quick start or in the marketplace. So what you can do is you can purchase the license on your own and use that license on top of your EC2 instance. So using this template in one go, you can actually launch as many number of instances that you may want to launch. So every account comes with a soft limit wherein Amazon would simply not allow you to launch 100 instances at a given point of time. That's simply because to prevent accidental misuse. So there are soft limits on your account, and I'll come to soft limits again once we get into the demo part. With respect to security, we have security groups that operate at the compute layer or at your instance level. So security groups, they act as a virtual firewall that control what traffic, both incoming and outgoing traffic. So in this case, all what you need to do is you need to specify within the security group that for which protocol, which port number, what is the source and what is the destination that you want allow the traffic to be allowed. So in security groups, you can only specify allow only rules. And instances within the same security group, it depends on the configuration whether you want them to communicate or not. So it's up to us. And these security groups internally, they are applied to the network interface of your compute resources, because your network interfaces form both entry and exit point for your compute resource. So the process to create a security group is very straightforward. So let's see that in action. So I can create a security group during the instance launch process, or I can create it beforehand. So the option is purely with us. So let's say I want to create a security group for my instances in the web tier. So I'll give it an appropriate name, WebSG. I'll have to specify the rules. So I'll have to specify the type. So in this case, let's say I want to allow SSH access to my instance. So SSH works on port 22. I have to specify the source address from which I want to allow this SSH connection. So you have custom anywhere my IP. So for demo purposes, I'm saying anywhere, but in real-time scenarios, you make sure that you make it custom. And the second rule that I'm adding, since the security group would be applied to your instances in the web tier, so I'll be allowing HTTP traffic as well. So the rules that I just set up in this security group, these are inbound rules, and by default, all the outbound traffic is allowed. So we can change that, but this is the default behavior. So in this context, outbound would mean any traffic generated from within the instance to outside that instance. So now it could be to another instance, it would be to an internet resource. So it is a resource outside that instance. So the illustration that what we have out here, this is you see a firewall out here wherein that controls the traffic. So a good example, I can give you a better architectural representation with respect to security groups. So this is a 3-tier architectural representation. You have web, app, and database tier. And this tier is associated with one security group. This tier is associated with another security group. And my database is again associated with third security group. So in this security group, I'm controlling the traffic that is coming from outside. Likewise, for app server, I can control the incoming traffic only from the web servers. And likewise with the database servers, I can control the traffic only generated from app servers. So one of best practices is include security at every layer of your application. So at the compute layer, you should be using security groups to control both inbound and outbound traffic. And lastly, security groups are stateful. So stateful in this context means that any traffic that is allowed in the inbound rule, the return traffic would be allowed by default. So regardless of whatever the outbound rule says. So we'll see that in action very shortly. So there are other representations as well. This could be considered as a web or rather web tier, and they are spread across multiple availability zones and they are part of the same security group. At the network layer, again, you can have access control lists that would further filter the traffic to your compute resources. So in the illustration that what we see on the screen, again, we have a 3-tier architecture. So web tier, this could mean X number of my virtual servers or instances, and application tier again can have X number of instances, and likewise for database. So we are opening for web tier, we have opened 80 and 443 if you have configured SSL. For application tier, again, you'll open up connections from web tier And additionally, you might want to open SSH connection for you to access the instance directly. The next term that we should be familiar with is key pairs. So EC2 key pairs, they are cryptographic secure keys that are used by AWS to authenticate a client when logging into a EC2 instance. So it's a combination of public and private key, and collectively they are referred to as a key pair. AWS stores the public key on the instance, and the end user gets to download the private key. So to log on to an instance, let's say if you are using Linux instances, so by default, they have no password. You only use the key pair to log into Linux instance. And for Windows distribution, you use a key pair to obtain admin password and then log into the Windows instance using RDP. So during the creation of EC2 instance or otherwise as well, you are required to create a new key pair or use an existing key pair that can be tied to the instance. So the idea here is to provide a secure mechanism to connect to your instance. So let's go back to the EC2 dashboard, and just below security groups, you have key pairs. So you can import a key pair or you can create a key pair on the console directly. So I'll create a key pair, and so now AWS would generate a public key and a private key. In fact, it has already started downloading the private key pair. When we provision our instance, we'll have to associate a key pair with the instance, and AWS would associate the public key with that instance, and I'll be using this private key SSH into that instance. So I've got this key, so I'll just save this key. So now we'll proceed with the demo on provisioning our instance. So this time we'll take it slow, understand various attributes associated during the provisioning of the instance. So make sure you are in the right region. Go to launch instances. The first step is to select the right AMI that you want to provision. And for the first part of the demo, I'll be using Amazon Linux AMI, and it is marked as free tier eligible. Next, you need to choose an instance type. So instance type, as I mentioned earlier, it is refers to the hardware specification in terms of number of CPUs, memory, storage, and network performance. So there are multiple families available. You have general purpose, then you have compute optimized. So general purpose offers you a right blend of compute and memory. Compute optimized, as the name suggests, would give you more compute power as compared to memory. Then you have memory optimized, GPU for if you have media workloads to operate with, memory optimized. Then you have storage optimized as well. So you have good number of instance types available, and you can always, let's say you picked up a wrong instance type and you want to either scale up or scale down, meaning you want a better configuration or probably a lower configuration. So doing that is always a couple of clicks away. So you don't need to remember these configurations per se, but have a generic idea that what are the various families available. So as the name suggests, for compute optimized, it would offer you better compute power as compared to other parameters. General gives you the right blend. So if you really don't, you're stuck, what should I choose? Go ahead and start with general. So make sure you select the one which is marked as free tier eligible, because that should serve the purpose for us. The next step is to configure instance details. So this is where you set up all the configuration parameters. So the first part is number of instances. So I can specify, let's say 10 instances out here. So it will use the same configuration to provision 10 resources for 10 instances or virtual servers for us in one go. Recall a while back I said that there are software limits on your account that are imposed by AWS. So that's simply because to prevent accidental misuse. So as a solution architect, let's say you're planning to do a rollout. So make sure that you check on these soft limits that are applicable to your account. So as it stands today, the limit on my account is 20. So when I had signed up, initial limit was probably 1 or 2. So since this is a soft limit, all what you have to do is just create a ticket with Amazon, specify why do you need additional resources, and they kind of do it on the fly. So you can put in a ticket, right? You have a link request limit increase. So EBS falls under EC2. So this is where you would see EBS network limits as well. So the maximum number in my case that I can put here is 20, but we'll start off with one instance, the network parameter, and the subnet parameter I'll be talking in detail in the network section, wherein the network service allows us to build our own private virtual cloud. So at this point of time, we are using default network, which again is dedicated to my account. So earlier what used to happen was when you sign up for the account, it was up to the customer whether you want to create a VPC or not. But for security reasons, over last several years, Amazon by default would create network environment for you, and that is like your private space in AWS. So it is up to us whether we want to use the private network built by Amazon or whether we want to build our own. So 9 times out of 10, if you talk to your network teams, you will be building your own environment. And likewise for subnets. So subnets in this context refers to the availability zone that you want to use to provision your instance. You have a option here, assign public IP address. So by default, it is enabled. So for me to connect to this instance that would be provisioned, so how do I connect to it? So this machine needs to be associated with a public IP address. So I leave it as default. So I'll come back to these options in the second part of the demo, rest part of the. Next part is to add storage to this instance. This is elastic block storage, commonly referred to as EBS storage, that we are attaching to this instance, and this is a network storage. So this volume type is being referred to as a root volume. So root volumes are the ones on which you install your operating system and other application packages. So to start off with, we are attaching 8 gigs of volume to the instance that we are provisioning. Next, tags. Tags play a very important role, so help you identify resources. So you can add multiple tags. So let's say project ABC, you can add cost center, so whatever code. You could filter out the information based on tags, so to capture a lot of information. So let's say I want to capture what are resources being consumed by project ABC, I can do that. What is the total cost being incurred by resources in this project? So you can do that. So tagging plays a very important role. Next step is to configure security groups. So you could have created the security group at this point of time. The process is the same, or you can select an existing security group. So we had created a security group a while back. I'm adding the rules again. I'm creating a new one right now. And it gives you a warning message that you're allowing sources, so anybody can connect. The last step, review your configuration, what we have said in previous screens, and launch. So when we launch our instance, it would prompt us to choose an existing key pair, create a new key pair, or proceed without a key pair. So depending upon the level of automation that you have implemented, I've seen some organizations, they actually don't allow SSH access to instances at all. So they don't create a key pair. So both the options are available. In our case, we'll choose the key pair that we just created. That's about it. So the current state is pending. All the attributes that you see in the description tab, these are essentially configuration parameters that we supplied during the process. So it has picked up availability zone 2B. So we let Amazon pick up the availability zone for us. It has assigned a public IP address. So I'll be using this to connect to this particular instance. Lastly, the internal private IP address that has been assigned is the one that we see on the screen. Next, in terms of connecting to this instance, so if you have a SSH client or using a Mac terminal, you can directly do a SSH with the key that we downloaded from Amazon. Else, if you are using a Windows terminal that does not come with a default SSH client, I'm using PuTTY to connect. However, PuTTY does not recognize the file format that we downloaded. So we'll have to change the file format. So this is an optional step only for Windows users. So you download PuTTY, and there's another tool called PuTTYGen that you can use to convert the format. So I'm using PuTTYGen to convert the format. So please note this is an optional step only for Windows user trying to connect to your instance using PuTTY. So I use the tool to convert the format, and now we are good to go. So I'll be using PuTTY. So I'll just grab the public IP address of this instance. I'll have to pass the path of the private key file for authentication. So for Linux distributions, you don't need to supply a password, and the default username that we use to log into the instance is EC2-user. So I've been able to log into this instance, and I'll just upgrade my privileges. So what I'll do now is install web services. So now these commands are operating system specific. So depending upon your comfort level with any operating system, you can try this out. And if I try to access at this point of time, so since the web services are not running, I don't get anything. So this is the default page. So let's go ahead and change this default page as well. So we are good here. So we have seen how easy it is and the flexibility that the service gives us to provision instance within a couple of minutes. So now in this case, I actually had to log into my instance to perform certain steps, but there are ways to automate to get your instance into the desired state. So in the next part of the demo, we'll again launch a EC2 instance and we'll try to automate the process. So before we get there, let's check other options available at the instance that we just spin up. You have status checks. So two types of status checks. One is system status and instance status. So make sure that these two checks have passed before you actually start using the instance. Then with respect to this instance, you will see metrics like CPU utilization, discrete networking, all the metrics that are associated with this particular instance. So the details that are available under the monitoring tab, they are actually coming in from the monitoring service, which is CloudWatch. And lastly, you have tags. So the tags that what we see here is what we set up. So I can add additional tags anytime. So I'm provisioning a second instance. I selected the AMI, and again, the family is general purpose. So in the third part of the step, so let's take a look at other options that are available. You have shutdown behavior. So an instance can actually be in multiple states. It could be in running. That means it's operational. You could stop it. So that means you are releasing the hardware capacity back to Amazon. So in that case, you will not be charged for the compute resource. But please keep in mind that you will still be charged for the storage component. So recall in the previous demo, we had attached 8 gigs of storage. So I'll not be charged for my compute resource, but I'll still be charged for the storage component. So a lot of organizations actually what they do is during their working hours, they'll start the instances, and off hours, they stop the instances to save on cost. You can actually automate this entire process. And then the state is terminate, which means that you're releasing the capacities to Amazon forever. So you'll not get the same system state back. So you're releasing the capacity. So in termination, you have an option whether you want to terminate the storage component as well or not. Then you have an option of enable termination protection. So in this case, if you enable it, the users would not be able to terminate the instance. This is simply a preventive measure so as to prevent accidental termination of your resource. Then you have monitoring, which refers to CloudWatch service. So by default, CloudWatch offers two flavors. So one is basic monitoring, in which the metrics are captured at a 5-minute interval. And there is detailed or enhanced monitoring, which is a paid version where the metrics are captured at a 1-minute interval. So detailed monitoring is chargeable, whereas basic monitoring is free of cost. So for production environments, if you want to use CloudWatch, make sure you enable this. Tenancy attribute, I'll discuss it in a bit. Now we're trying to automate the process to get the instance into the desired operational state. So in this case, I'm just repeating the steps that I performed after logging into the instance. So I'm passing this as a user data. So once the instance is in running state, it would execute these commands and get my instance to the required operational state. Next part again is adding the storage to this instance, and you have an option of delete on termination. So this is where you can decouple your storage component with your compute resource. So if I uncheck that, so when I issue a terminate command, only my hardware resources would be released. My storage component would still be available to us. So I can use that with another instance or for any other purpose. So I'll be using the same security group that we created earlier, since this is again part of the web tier. I'll associate the same key that we created a while back. Various attributes associated with the second instance that we have provisioned, but as associated with a public IP address, likewise it has a DNS name. So we can either use the DNS name or the IP address directly. So now for the second instance, I actually did not have to log on since I had bootstrapped the instance. And we are assuming that this state is the operational state for this instance. So there are multiple ways of approaching to this, wherein do it yourself, wherein you provision an instance, log in, get it to a desired state, automate the process. Bootstrapping is the first step in doing so. And as we move ahead, we'll be talking of various other tools like Beanstalk, Opswork, CloudFormation that further help you manage resources as a group of resources. So the next step is creating your own custom AMIs. So let's say the instance that we just created is the one that we really want. That serves as a baseline for us for provisioning further instances. So we can go ahead and create custom AMIs. So go to images and create an image. So on the left hand side of the pane, you have under images, you have AMIs. So this would indicate all the custom AMIs that you would have. So it actually depends on the size of your instance, and it's relative to time it takes to create the image of it. Okay, till the image comes up, with respect to storage, we can take a look at volumes. So we have 2 instances available to us and we're using 2 volumes. These are indicated in the volumes tab and the state indicates they are in use. So now the status is available. That means the AMI has been created. So now if I was to provision an instance, I can use this AMI as my baseline to provision it. So rest part of the process is pretty much the same, wherein you select the instance and various other configuration parameters. So this is my baseline instance. So meanwhile, I'll go ahead and terminate the instance. So this is the instance that we just provisioned. So again, we have this instance ready in the desired operational state. So custom AMIs is one of the methods that you can use to set up baseline image for your specific component of your application, and could be used as backup method also. So in case something was to happen to my compute resource, I can use this AMI again to provision a new instance. So we have already seen that the provisioning of instance happens like under 2 to 3 minutes. So this is good for environments with less dynamic release cycles, wherein I've seen organizations doing multiple deployments as of today. So maintaining AMIs in those cases would be an admin nightmare. So depending upon your specific use case, if the release cycle is less dynamic, you can use the AMI approach, or else we can use different other tools or build in automation to mitigate the effect of an outage. So I'll just quickly connect to one of the instances. Let's connect to Web 2. So what I'm trying to demonstrate here now is user metadata and instance metadata. So in the first part, we'll be looking at user metadata. So this is essentially the script that we supplied during the boot process. So that would be visible to us. So this is the user metadata, essentially the configuration or the script file that we supplied during the boot process. The second one is the instance metadata. So this is information about the instance itself. So the attributes that what we see in the description tab, if I want to check these attributes at the instance level, I can refer them using instance metadata. So these are static URLs. So 169.254, 169.254. This is a loopback address that is assigned to every instance. So this would always remain the same. So if you had to check the user data or instance metadata, you'll be using this. In this case, you see all the attributes that are available at the instance level. So for example, you want to check from your instance, what is the public IP address available or assigned to this instance? You'll get to know that. So if you want to check the details about instance attributes, you'll look out for instance metadata. And if you want to check the script or series of commands applied during the launch process, you'll look out for user metadata. So I've given you both these URLs. So these URLs would be applicable across all the instances. So the next thing that what we'll do is we'll analyze the stop behavior of when we stop the instance and start it again. So I've captured the public IP address that has been assigned to this instance. Now, if I were to actually stop this instance, that means I'm releasing my hardware resources back to Amazon. So in this case, what has happened is the private IP address remains the same, but the public IP address that was associated with this instance, you lose the affinity to it. So if you stop an instance and start it again, your instance would lose the affinity to the public IP address that it was assigned to it earlier, and the instance would get a new public IP address assigned to it. So this is something that is controlled by Amazon by default. And there are ways and methods. Let's say you want a static public IP address. So there's a way to do it. And that I'll be demonstrating in one of the demos today itself. So if I start it, so this time the public IP address that has been assigned should be different. So this is a different address than the one that was assigned earlier. So directly or indirectly, you will be tested on this behavior, that what would happen if you stop the instance and start it again. So public affinity to the public IP address changes. So we've seen the demo of creating a custom AMI. And in the next part, what we can do is we can provision a Windows instance. So I'm picking up a lightweight Windows instance, which is 2012 base edition. So rest of the steps are pretty similar. So we'll pick up an instance type, configure instance details. So we'll keep it as same. Then add storage to this instance, apply the security group. So in this case, let's say app security group. Since this is a Windows terminal, we'll be using RDP to connect, and that works on 3389 launch, and then associate this instance with a key pair. So we'll use the same key pair that we created a while back. So the instance is running, and in this case, we'll be using the private key file to generate the admin password for us. So the way to do it is go to connect, select the instance, go to connect, and then get password. So typically it takes about 2 minutes or 3 minutes for the service to generate the admin password for you. Just specify the key pair path and decrypt password. So this is the password that it has generated. So to connect to this instance, I'll be using the default Windows client. So you now have access to a Windows terminal, and you can perform any actions if you want to use Windows IaaS, on top of it, any specific middleware applications that you may want to use. So the process of, you need to have a baseline understanding of Windows on how to perform those steps. So we have seen 3 or 4 demos on provisioning Linux and Windows instances. So essentially the process is the same. The method of connecting to each distribution is a bit different. Otherwise, at the OS level, you need to have, or the guys working for you need to have an understanding on working on that operating system. So one thing on security groups before we move on. Okay, so this is working. So earlier, to control inbound traffic, we had said we are allowing access on port 80 and port 22. So let's say I was to X out both, or rather HTTP access to this. So now if I was to access it, this should not be available. So this means any changes that we apply to the security group, they are applied on an immediate basis. So you can expect a scenario-based question that we make changes to the security group and what is the overall impact. So the changes are immediate in nature. Another thing that we said was that security groups are stateful, which means that if you have allowed traffic in the inbound traffic, the return traffic would be allowed by default, regardless of what the outbound rule says. So let me see if I'm connected to the right instance. So now if I want to access traffic outside this instance, so let's say, so I'm able to access, so this refers to the outbound traffic. So if we take a look at the outbound traffic, all traffic is allowed by default. So you can actually change that. And it's always a very good idea that you do not allow any traffic generated from that instance to go outside. So what I'll do here is I'll just simply go ahead and kill this rule. So now I am not able to access any resource outside the instance, but I was still able to SSH into this instance. That's simply because in the inbound rules, I've specified SSH access is allowed. So this is where the term stateful comes into play, that if you have set up an allow rule in the inbound rules, the return traffic would always be allowed regardless of whatever you say in the outbound traffic. So right now, no outbound traffic is permitted. And even if I try to access the web page, I'll still be able to. So this is always a very, very good practice. Even if a hacker was to get into your compute resource, since you have already set up that no traffic generated from that instance is allowed outside, you are looking at a good security option for your compute resources. So moving on, we'll talk about hardware tenancy. So when we provision an instance, we have an option to choose the tenancy. So what does tenancy mean? So tenancy in this case means that whether you're willing to work on a shared tenancy or a dedicated instance tenancy or dedicated host tenancy. So let's say I pick up this AMI. So you have a tenancy attribute out here. So the first one and the default tenancy that is selected is shared tenancy. And how this works is in the background, you would have a physical host. This physical host in the shared tenancy model would be shared across multiple AWS customers. So let's say I have provisioned 2 instances. There could be another AWS customer who could be assigned this physical host. So this is the shared tenancy wherein the underlying physical host is shared across multiple AWS customers. So this is the cheapest options of all. And for lower environments, it's a great fit. Also recall that when we talked about the stopped behavior of when you stop an instance, it loses the affinity to the public IP address. So there'll be thousands of physical hosts with Amazon. So let's say if I was to stop this instance, I'm releasing this capacity from this physical host. So this is gone. So when I start it again, it is likely to be provisioned onto a different physical host. So in the background, it loses the affinity to the physical host. So I'll come back to this reference when we start talking on EBS because there's an option that you can use out in the shared tenancy attribute. Then you have dedicated host. So in this case, what would happen is Amazon would allocate dedicated physical host to your account. And you have a dedicated physical server to your account and you are responsible for provisioning your instances on top of that physical host. So in this case, in the case of dedicated host affinity, your affinity between the host and instance is always maintained. And you additionally get visibility to various other parameters such as number of sockets, scores, and host ID. So specifically, if you want segregation at compute layer, you can opt in for dedicated host model wherein you would be assigned dedicated physical host and any resources, any compute resources that you provision, you can provision them to your that specific physical host. So this allows you to maintain the affinity between the host and instances. So specifically for PCI compliance, they actually look at dedicated physical host kind of a model. And they have added a variant between shared and dedicated host, which is referred to as a dedicated instance. So in this case also, Amazon would assign a physical host to your account, But the major difference is that the affinity between the host and instance is not maintained. So let's say this was the physical host that was assigned to me. So based on the capacities that were available to Amazon, Amazon might have dedicated a physical host that is much higher in capacities. So that is lost of dollar value to Amazon. So in that case, Amazon would go ahead and dedicate a physical host to your account. But when you stop the instance, so it would again check whether it has a physical host of lesser capacities. If it has, it is likely to place this instance, the next physical host. Again, this physical host would be dedicated to your account. So if your need is purely from compliance perspective, dedicated instance is the way to go. With respect to dedicated hosts, there's another benefit. So there are a lot of licenses that you actually are tied to specific physical hosts. So if as an organization you have already spent money on those licenses, you want to use them in AWS environment, you can always use that. So the default tenancy attribute is shared. That's only eligible under the free tier. If you choose dedicated or dedicated host, you'll be charged for it.
What is a VPC? In order to understand, let us think about today's scenario. Today, we are facing a pandemic situation. In this situation, the utmost priority for all of us is to maintain a private sanitized space. Even when we are visiting a public space, we need to take care that the social distancing norms are being followed. Similar to this, enterprise want to use all the services available in AWS, but they want to do it in their own private sanitized space. This space is provided by a service in AWS known as VPC. VPC provides us the private space that is required inside AWS, wherein we can define our own network and also use all the services of AWS as per our requirements. So the technical definition of a VPC is, as can be seen from the illustration, let us try to understand it. A VPC is defined in a region of AWS. As we all know, there are various availability zones within the region. It should be noted here that the VPC can be spread within a region in all the availability zones. In this illustration, there is shown a region with two availability zones. The VPC is spread among both these availability zones. The other point to be taken into consideration is a VPC is generally a large network. In order to have better control over the network, the large network of a VPC is further divided into smaller groups or smaller chunks. These smaller chunks within VPC are known as subnets. So now let us discuss why a VPC is required. For an enterprise using the cloud or migrating to a cloud, the most important concern is privacy, security, and the security of their proprietary data. They are not comfortable when they need to use a public network of a cloud service like AWS in order to use their services. Therefore, a VPC provides them an extra layer of security wherein they can define their own network. It not only gives them security, but it also gives them ease of connecting to their instances or services. When we create our AWS credential, a default VPC is created, but in industry or at a production level, we need to customize our VPC. The tools required to customize our VPC is provided by AWS, wherein we can explicitly create subnets, NAT, security groups, internet gateway, etc. All these terms shall be explained with the hands-on in this session. Before we move and understand the components of what makes a VPC, let us first spend some time and understand what is an IP address. The IP address or the Internet Protocol address is a logical numerical label assigned as a unique identity to each device in a network. In more lay terms, it can be understood as every human being has a fingerprint. It is unique to each of us. Similarly, every device which is connected to a network has an IP address which is unique to itself. It's like a fingerprint for that device. Let us get more deeper into understanding of an IP address. Take for illustration the computer's IP address 155.67.35.0. It consists of 4 parts. These 4 parts are known as octets. Each octet contains 8 bits. So in all, the IP address consists of 32 bits, 4 octets, each octet consisting of 8 bits. Therefore, 4 into 8, 32 bits. Let us now understand another important topic or important definition, that is CIDR, classless inter-domain routing. CIDR is basically a methodology to represent a IP address. Let's take an illustration. 172.31.0.0/16. The /16 part here represents the number of bits present in the network ID. Let us understand it a little deeper. As explained earlier, the IP address consists of 4 octets and each octet consists of 8 bits. The 16 here denotes the number of first 16 bits out of this 32 bits which are locked. So in short, in this IP address, the /16 denotes that in this network, this 16 bits are locked. So what does it signify? It signifies that the remaining 16 bits out of this 32 bits are available for use in the network. Therefore, the total bits which are available to be used in the network are 32 minus 16 is equal to 16. Therefore, the total number of IP addresses which can be generated from this 16 bits would be 2 raised to 16. Let us take, for better understanding, one more illustration. Suppose 172.31.0.0/28. This is a little tricky as 28 is not a multiple of 8, but let us understand. So this denotes that in this IP address, out of 32, 28 bits are locked. The number of bits which can be changed in this IP address are the last 4 bits. Therefore, the total number of IP addresses which can be generated from this CIDR are 2 raised to 4 or 16 IP address. What does this denote? It denotes that this IP address is a much larger network wherein you have provisioned it with the larger number of IP addresses which can be assigned within this network. Whereas in this IP address, the number of IP addresses available to be used within this network are very small. Therefore, classless inter-domain routing reduces the wastage of IP addresses by providing the exact required number of IP address to the users. It is also a methodology by which we can gauge the vastness or the largeness of the network it has been assigned to. Now that we have understood the basics of IP address and CIDR, let us see what are the key components of VPC. The key components of VPC that we would be talking and also discussing and doing hands-on on are the following. 1. Internet Gateway and NAT. It logically enables routing of traffic in the public network. That is, it gives us the gateway like a firewall from which our VPC can connect to the internet. DNS, standard which resolve names used over the internet into IP address. Elastic IP, it is a static IP which never changes. VPC endpoints, private connection between your VPC and other AWS services without using internet. This is one of the key features of VPC, wherein we will be discussing that in detail during this session. Network interface, a point of connection between a public and private network. Egress only IG allows only outbound communication from EC2 over IPv6. Route tables, another important feature to understand VPC. It defines how a traffic is routed between each subnet. VPC peering, connection between VPCs. We will be discussing about each of these components during the course of this session. Now that we have understood what is an IP, what is CIDR, and what are the key components of a VPC, let us understand what are subnets. As explained earlier, a VPC may consist of a large network. In order to have better architecture within this large network, we may divide it into smaller networks. So it is a concept of network within a network. It may also be understood that the large network of VPC has been divided into smaller networks. These smaller networks are known as subnets. Therefore, a subnet is a logical subdivision of a larger network. Here comes a picture of CIDR. IP addresses with common prefix are used in the same subnet. As can be seen in this illustration, 172.31.0.0/16 is the IP address of this VPC. We have two subnets here. One is known as a private subnet and the other public subnet. We have assigned a common prefix of 172.31 to both these subnets, and the IP addresses have been divided. The various types of subnets are private subnet and public subnet. Why is this a requirement? Let us understand it, maybe with the example of a website like Facebook. There are certain parts of Facebook which we require access to, or which Facebook wants us to access. But there are other parts of Facebook which Facebook wouldn't want us to get access to. That is their database. This bifurcations can be done using private subnet and public subnet. When we do hands-on, we will understand how do we categorize a subnet which has been created inside a VPC as private or public. So let us now start our hands-on in order to better understand the concepts which we have understood till now. That is VPC, region, availability zone, and subnets. Let us start our hands-on and reiterate what we have learned. In this hands-on, we would be creating an architecture similar to the illustration as seen in the image. Within the AWS, we will be creating in one of the region a VPC. In that VPC, we will be creating two subnets. One is the public subnet and the other is a private subnet. We will then provide an internet gateway which will give access to the subnet to the public network or the internet. Also, we will understand how we shall create a router or a route table. We will be creating a route table for each of the subnets that we are creating and understand how important it is for VPC. So let us start this session. So let us now log in to our AWS console. We are signing in to our AWS console. So this is the dashboard which reach into when we start our AWS management console. The point to be taken into consideration here are: 1. This is the region wherein we are going to create our VPC. It should be noted there are various regions. We have chosen this region in which we are going to create our VPC. Now, how do we access VPC as a service? We can do it either by searching on the search bar, or we may go and click on the VPC service inside networking and content delivery section of AWS. We have launched into the VPC service of AWS inside North Virginia region. Now, we need to create our VPC. AWS provides us one of the wizards by which we can launch a VPC, but we shall be creating our VPC by clicking on this link. Let us first, as you may see, there is already a VPC residing here. This is the default VPC which I am talking about. This default VPC comes packaged whenever we create our AWS credential. We are now going to create our own custom VPC. Let us name the VPC as Edureka demo. Before we discussed about a topic known as CIDR, herein comes its use. We need to allocate an IP address to this VPC in the form of a CIDR block. We are just providing it 10.0.0.0/16. So basically, we are creating a VPC in which we can assign, as explained before, 2⁻16 IP addresses. Let us create this VPC with the default settings. The VPC has been created. The next thing which we discussed about was subnet. Let us understand what we did till now again. We created a VPC inside the AWS region, North Virginia. Now, we are going to create inside this VPC smaller networks or smaller chunks of this network known as subnets. We go into the subnet module. There is already one default subnet available. We are going to create our own subnet. The first subnet which we will create is the private subnet. Let us name it as private subnet. The VPC inside which this subnet will reside, we need to select it. So we are going to select the one which we created, that is Edureka demo. The availability zone. This is what I was talking about. We created a VPC inside the region North Virginia. In North Virginia, there are 6 availability zones. In the illustration which we had discussed, it had 2 availability zones. In North Virginia, there are 6 availability zones. What we are going to do is, we are going to create a private subnet in one of the availability zones. Let us select this one. The other thing to be noted here is, as soon as we associated this subnet with the VPC, the corresponding CIDR of the VPC has been mentioned here. Now we need to mention a CIDR block for the subnet which we are creating. It needs to be mentioned here. We need to give a CIDR block here, which is a part of this network. So 10.0 will remain fixed. As explained earlier, the first 16 bits of this network or IP address is blocked. So 10.0 cannot be changed. So we change the third digit or the third octet as 10/24. So we are locking in this subnet the first 24 bits 10.0.1. So it has to its dispose 2⁸ IP addresses which can be assigned within this subnet. Let us create this subnet. Herein, the first subnet, that is private subnet, has been created. Now let us create another subnet, which is our public subnet. Public subnet. We assign this subnet again inside the VPC Edureka demo. We can assign this public subnet in the same availability zone which we did for private subnet, or we can have it in other availability zone. For this demo, let us create this subnet, that is our public subnet, in a different availability zone. As explained, we can now assign IPv4 CIDR block to this subnet by fixing 10.0 and assigning it a different IP address. This is the subnet which we are going to create. Perfect. Till now, whatever we have done is what we have discussed. We have created a VPC inside the region North Virginia of AWS services. In the VPC, we have created 2 subnets. One is the private subnet and the other is the public subnet. It can be noted here that these 2 subnets have been assigned to these 2 VPC. So within this VPC, we have these 2 subnets. We have also assigned the IP address, or we have defined the IP addresses for our VPC, and accordingly, we have assigned a IP address to our subnet. The next part after creating subnet is creating route table. So what is the route table? Let us understand that. Route tables are the set of rules which are used to determine where the network traffic has to be routed. It specifies the destination subnet and the gateway router to reach it. So basically, a route table is a log wherein we maintain all the rules, or we specify all the rules by which we say which subnet will communicate with internet in what way. Let us better understand it with the hands-on. Herein, there are default route tables created. One of the route table you can see has already been created for Edureka demo. This is the route table which is created by default, but it is a standard that we need to create a route table for the subnets which we have created. So let us create for the 2 subnets which we have created in our VPC 2 route tables. The first route table, we will name it as public RT. The VPC is Edureka demo. So now we are creating this route table. Similarly, let us create another route table, that is private RT, for the VPC Edureka demo. Now we have created the 2 route tables, but now we need to assign the subnets which we have created to the respective route tables. That can be done by clicking on the created route table and going into this tab of subnet association. So now we will associate our subnet with the respective route tables. So we click on edit subnet association. We see that there are 2 subnets which we have created, that is private subnet and public subnet. The name of this route table is private RT, that is private route table. Let us assign the private subnet to this route table. This basically means all the rules, all the conditions of how this subnet communicates with the router will be logged into this table, that is private RT. Similarly, let us associate the subnet with public RT route table. If we click on edit subnet association, we see again that the two subnets which we had created for our VPC Edureka demo are listed here. Now it can be noted here that it shows one of the subnet, that is private subnet, has already been associated with this route table. Therefore, we shall now associate the subnet, that is public subnet, to public RT. Done. So the other thing it needs to be noted is this is the default or the main route table which has been created as we created our VPC. These two are the route tables which we have created. One for the public subnet and the other for private subnet. Now let us understand what the internet gateway is. As can be seen in this illustration, we have our public and private. So one of the public subnet needs to communicate with the internet. How do we do that? How will we provide that gateway to public subnet so that it can communicate with the public network or the internet? For that, there is a service provided by AWS within VPC that is known as Internet Gateway. This Internet Gateway shall be assigned or shall be linked to the subnets which we want to be connected to the internet. Thus, the Internet Gateway is a VPC component that helps instances to communicate over the internet using targets provided in the route table. Let us now understand how we can create this Internet Gateway. I'm going to create a new Internet Gateway. Let us name it as Edureka Demo IG. And with the default settings, we will create this Internet Gateway. This Internet Gateway has been created, but it is right now in detached state. Therefore, we need to attach it to one of the VPCs. So here we click on Attach to VPC. We select the VPC to which we want this Internet Gateway to be associated. And we create the Attached Internet Gateway. Now, if you see, the status has changed from attached to detached, and it has been attached to this VPC. So let us understand or summarize what we have done till here. We created our VPC in a region, North Virginia. We created two subnets within that VPC, private and public. We created for each subnet a route table. And now we have assigned or we have created an internet gateway for our VPC Edureka Demo IG. Now in the route table, we need to update the table by the rules or by the log that which subnet can connect to the internet gateway. Remember, as explained earlier, internet gateway provides us the access to internet. So here the public RT needs to be provided that access. How do we do that? We go to the tab routes, we edit routes, we add a route 0.0.0/0 and we select in this tab the internet gateway. Once we do that, we can see in the drop down the gateway which we have created. We select that and we save the route. So basically what we have done is we have created a route for our subnet to connect to the internet. For that, we have provided the information in the route table. Thus, till now, we have created our VPC, we have created two subnets, we have created an internet gateway, and we have updated our route table by mentioning that the public subnet can connect to the internet using internet gateway, and we have assigned the respective gateway which we had created. Now, let us create two instances within our subnet. Let us go here, click on EC2. We shall now create one instance each for the two subnets which we had created. We go to instances and we launch an instance. We need to select a machine or an instance. We select the default one and we configure our instance. So now we are going to create our EC2 instance within one of the subnets. Here you can see that the VPC which we have created, one is the default VPC and the other is a custom VPC. We can select our custom VPC from this drop down. Within that VPC, we have two subnets, private subnet and public subnet. This instance we are going to create for our private subnet. So we select the private subnet. Auto assign public IP. We all know that the instances which we want to create in our private subnet need not be exposed to the internet. Therefore, we will not assign any IP address to it. To do that, we will disable auto assign public IP. We will next look into storage. We will keep it as default. Add text, we will keep it as default. For configure security group, this is another important aspect of a VPC. Now, AWS provides us security group, which is at the instance level. So at the instance level, I can mention who all can connect to this instance. Suppose I mentioned that apart from SSH, I would want HTTP and HTTPS to be included in the protocol wherein we can communicate with the instance. These details at instance level can be mentioned in this section. We have just done that and we launch our instance. We will now need to create a key pair to communicate with this instance. I will use a key pair which I have already created. You may also download a new one by clicking a create new key pair, or you can click on choose an existing key pair. I shall use one of the existing key pair. Should be noted here, you can also create a new key pair. You can just name the key pair and download it. For now, we will use a already existing key pair. So the instance has now been created. Let us go and have a look at it. As can be noted here that an instance has been created and the key name is Edureka. There is no public IP address assigned to it. Let us name this instance as the private instance. Now let us launch another instance for our public subnet. Select. Next, let us follow it. Here in configure state instance, let us have a look. Herein, for the network, we use our private network, VPC network that we created, Edureka demo. In the subnet, we need to now create this instance for our public subnet. We need to assign a public IP to it so that we can communicate to this instance. So for auto assign public IP, we will click on enable. Next, we will keep it as default. The tag section will be kept as default. In configure security group, again, we may add more rules such as HTTP, HTTPS. And let us launch this instance. Again, let us use the existing key pair, that is Edureka demo. Let us look at the instances which we have created. As you may see, the status for the newly created instance is still in pending status. Let us, in the meantime, name the instance as public instance. The instance state has changed from pending to running. The other thing to be noted here is we had requested AWS to assign a public IP to it. It has done this. So now we can communicate with this instance using this public IP address. Let us go to our command terminal now and try to communicate with this instance. So now I open the terminal in which I have our key pair, that is Edureka demo. How do I connect? What is the command to connect to my instance? I can go here. I want to connect to my public instance. I can click on connect, and here in the SSH client tab, this is the command provided by which I can connect to this instance. I shall pass this command in my command terminal. And here I have now entered into my instance. That is my public instance. Let me now use the internet from this instance. Let me ping google.com. As you can see, it has started communicating with Google and is exchanging packets. Similarly, let us now connect to the other instance which we have created, which is the private instance. It needs to be noted here that the private instance has no IP address. So we cannot connect to this, but let us try doing that. We use again the SSH client provided exit out of our public instance and we paste for our private instance. As you may note now, it is trying to make a connection with the instance, but it is being refused, so it is not able to connect. Yes, so you can see this error now. Connect to host 10.0.1.85 port 22 connection timeout. It was not able to connect to that instance. It is obvious because there was no IP address assigned to that instance. Now that we have seen that we are not able to connect to our private instance, we can try connecting to our private instance through our public instance. So what we'll do now is we'll access our public instance. In that public instance, we will give a certificate which is required to access private instance. So we will use the network within our private cloud, wherein we will try to connect our public instance with our private instance. So let us do that now. I connect to my public instance. So now we have connected to our public instance. So now let us connect to our private instance from our public instance. So we take the sudo access of our private instance by writing this command. Let us create a blank PEM file which will contain the key to connect to our private instance. So we have created a new file, that is my.pem file, in which we will now insert the key required to connect to our private instance. I will copy paste this. I go to my command terminal. I connect to my public instance. Yes, so I have connected to my public instance. Let us now take a sudo access to this machine or to this instance. We now create a Vim file access.pem to connect to our, in which we will pass the security key required to connect to our private instance. I will copy paste the key which is there in Edureka demo to my access.pem file which I am creating. I will save this. I will now give it the read write access. And now I will attempt to connect to my private instance. Let me modify the key name before passing it on the command line. Yes. Okay, I misspelled the name of access. It should be ACC. Let us do that. Yeah. As you may now see that I have changed the IP address. I am now logged into my private instance from my public instance within the VPC. Let us now ping Google from my private instance. So I am telling my private instance to connect to Google. As you may see now that it is not able to exchange any packets. It means that my private instance doesn't have any connection with the internet, which is what we want our private instance to be. Many of our private instances inside our private subnet needs access to the internet. It may be because of practical reasons like updating our database or updating our security patch, etc. So how do we do that? For that, VPC provides us a concept of NAT gateways. NAT gateway is created so that our private subnets or the instances within our private subnet can get access to the internet. It needs to be noted here that private NAT gateways are one-way access. The full form of NAT is Network Address Translation. NAT devices enables instances in the private subnet to access the internet or other AWS resources. But it prevents the internet from initiating connections into the instances. So it's a one-way communication wherein our private subnet can connect to the internet using this device or using this NAT concept. How do we do that? We need to create a NAT. We create a NAT gateway. It needs to be noted here, or it can be seen from this illustration that the NAT gateway is created in the public subnet. We need to create Edureka demo NAT gateway in the public subnet. The public subnet of Edureka demo. We select that. We allocate to it a IP address by using the concept of allocate elastic IP address, and we create this NAT. Let us go and look whether in what state it is. As you can see, we have created a NAT gateway. It has been assigned inside VPC Edureka demo under the public subnet, and it has been assigned a private IP address. Now we need to go to the route table and update our route table for the private subnet or private RT. What we need to do is we need to give it a route 0.0.0/0 and connect it to the NAT gateway. You may see here that in the drop down the NAT gateway which we have created. Therefore, what we have done now is we have created a NAT gateway inside our public subnet. We are now connecting or providing a route for our private subnet to connect to this NAT gateway. This NAT gateway now will be connected to our IG or internet gateway and can access the internet. Let us do it. We have created our routes and updated our route table. Let us see whether our private subnet can get access to internet as it has been routed via the NAT. I am in my private instance right now. I tried pinging google.com before NAT gateway. It did not receive any information back from Google because it couldn't connect to or it couldn't ping that website. Now let us do it again. Before that, let us check whether NAT gateway has become live. It is still in pending mode. Let us wait before its status changes. Yes, so now the NAT gateway is available. Let us try pinging google.com. Perfect. As you can see now, the private subnet is able to access google.com. Why? Because we have created a NAT gateway. This NAT gateway is connected to the internet gateway. For now, the private subnet or the instances within the private subnet can access the internet via NAT gateway. This gives us the practical gateway wherein we can update our private instances. Also, it is very important to let you all know that once we have done or completed our demo, it is prudent to delete all the instances, otherwise you may be charged for the same. Let us do that so that we can repeat whatever we have done. The first thing which we need to do is delete our instances. So we have created 2 instances. Let us delete them. I am doing this so that we can repeat whatever we have done. We had created two instances, one instance in our private subnet, that is private instance, and the other instance, that is public instance, in our public subnet. Let us delete one by one. We go to instance state and we terminate the instance. Let us do it similarly for our public instance. Instance state and terminate our instance. So what we have done now is we have terminated our instances within the public and private subnet. Now the whole thing is we need to delete our whole VPC. So the first thing which we need to do is we need to delete our NAT gateway. Let us delete the NAT gateway which we created. We go to actions and we click on delete gateway and we type in delete. It has been deleting. It will get into delete stage. Once we delete our NAT gateway, which was used to access internet by the private subnet, let us go and delete our internet gateway. Before we delete our internet gateway, we need to delete it from our route tables. Otherwise, it may not allow us to delete it. We go here, we go to our routes, we edit our routes, and we delete our internet gateway. Edit routes, and this has already been deleted, the NAT gateway. So it is giving us the error. We delete that part also. Once the internet gateways have been detached, let us now delete the first, detach it from our VPC. It has detached from our VPC. Now we can go to our VPC. We need not delete our subnets one by one. What we can do is we can now delete our whole VPC. So we delete our VPC. We need to type in delete and delete. Herein the VPC is being deleted. With this, we have deleted all our instances within our subnets and we have deleted the VPC which we have created. As we did in our hands-on, we had given to each of the instances a security group. We had mentioned SSH, HTTP, and HTTPS. Therefore, security groups are working at an instance level. Security group is required to control the inbound and outbound traffic of your EC2 instance. It acts as a firewall at the instance level and not at the subnet level. So basically we are assigning the security groups, or we are assigning in layman terms who all can access our EC2 instances. AWS also provides us with an extra layer of security by the name Network ACL. Network Access Control List. It is one of the features in AWS. As you can see here, this is the default ACL list or NACL list which has been created. We can assign Network ACL to each of the subnet which we created. It is an additional security layer, controls the inbound and outbound traffic rules at a subnet level. So it means that at a subnet level, we can have one more layer of security, which will then overpower the rules which we had for our instances or the security groups which we have assigned for our instances. It allows us both allow and deny rules. Therefore, the basic difference between Network ACL and security groups is Network ACL are stateless. It responds to the allowed outbound traffic and are subjected to the rules of inbound traffic. Security groups, on the other hand, are stateful. They respond to the allowed outbound traffic and can flow regardless of inbound rules. Importantly, NACL are defined per subnet. It is an extra layer of security. Security group have to be defined at an instance level, and every instance can have a different set of security groups. Lastly, a subnet can be assigned only one NACL, and if not associated explicitly, it can be associated implicitly with the default NACL. Whereas in security group, an instance can be assigned 5 security groups and each security group has 50 rules. Now let us understand about another important concept, that is VPC peering. This is one of the ways by which we can connect different VPCs. As you may all understand, in enterprise, there will not be only a single VPC. Different groups within the same enterprise, for example, the data analytics group and say the data science group may have different VPCs. They may want to communicate between each other. AWS provides us a service known as VPC peering, by which we can connect one-to-one all the VPCs within the AWS. It may be in the same region or it may be in different regions. We can define the rules by which VPC peering can connect within different VPCs. This has an advantage wherein we don't need to connect two VPCs through a public network. It can be done using VPC peering. VPC peering allows us to connect one VPC to another VPC via direct network route using private IP address. You could peer with VPCs with other AWS account. It can be paired with other AWS account as well as with other VPCs in the same account. It has to be noted here, there is another service which is known as transit gateway, which can also be used in order to connect various VPCs. But that is a different topic of discussion. So now in this diagram, we illustrate how a VPC peering typically occurs. Here you may see that there are two VPC with two different IP addresses assigned. We need to have a connection between them. VPC peering is the service which we are opting for. We update the security groups to ensure that the traffic to and fro from the VPC peer is not restricted. As can be seen in this illustration, the peering request has been accepted by the blue group. Now there is a two-way connection between these two groups or these two VPC. To activate the VPC peering connection, the acceptor must accept the peering request as has been accepted by the blue group here. The request expires after 7 days if there is no action taken on the request. Once this peering request has been accepted, then we can create routes to connect the various instances between these two groups. Now we can update our route table once the peering request has been accepted. Update the route table of both the VPCs to enable the flow of traffic between them. Now that we have understood how a VPC is created, what is VPC peering, the other most important service of VPC is VPN and Direct Connect. At enterprise level, as can be seen in the illustration, the enterprise may have a data center which needs to communicate to a VPC. The existing data center may be keeping a copy of their data in their VPC or may have additional space in the VPC. In short, the existing data centers of the enterprise needs to connect with the virtual private cloud of that enterprise. So how do we do that? We can do it in two ways. One is virtual private network, wherein the concept of virtual gateway exists. This virtual gateway and the customer gateway can connect with each other. The two tunnels, the blue lines here, shows the two tunnels or the internet connection by which the existing data center has been connected to our VPC. VPN is a service that helps to connect your VPC to your data center through IPsec, Internet Protocol Security Protocol. So as we may all know in layman, the transfer here takes place with Internet Protocol security, or rather it takes place in an encrypted form. The security here is much more higher than connecting with the VPC via a public network. It is a secure connection between your on-premise equipment and your VPCs. It needs to be noted here, the blue lines here denote internet. Now, what if this internet connection is patchy or the speed is not up to the mark? Also, there is still some level of breach of security which may take place on these connections. To avoid this, AWS is providing with a service within VPC known as Direct Connect. So what is Direct Connect Gateway? Direct Connect is a network service that provides a dedicated network connection from your premises to AWS without using the internet. So how does it happen? It happens in such way that there are vendors who provide for each region direct connect hub. Now the customer's data center can connect to this direct connect gateway. There are third-party vendors who can lay down these lines. In short, the direct connect gateway are connected to the endpoints of the region with high quality fiber. Their speed can go up to 100 Gbps. And these are connected directly to the customers' data centers. It provides us the advantage wherein we have higher speed of connectivity between the customer data center and the VPC on the cloud. It provides us with a dedicated line which gives us higher speed of connectivity between the customer data center and the VPC. So what are the features, direct connect features? Private connectivity to Amazon VPC. The speed is having high elasticity from 1 Gbps to 10 Gbps connections. Connections and virtual interfaces are managed easily. Enhanced security through 802.IQ VLANs. It reduces the bandwidth cost and consistent network performance. All of the major larger enterprises go with this feature of VPC. It is compatible with all AWS services. Let us summarize the difference between VPN and direct connect. VPN, it can be connected via the internet in a secure way. In direct connect, we connect it via dedicated lines without the internet. VPN is suitable for small workloads. Direct connect are suitable for large and medium workloads. In VPN, we have the bandwidth constraints. In direct connect, we have virtually no bandwidth constraints. In VPN, only resources inside VPC can be used, while in direct connect, all resources of AWS such as S3, DynamoDB and VPC can be used. In VPN, the connectivity and speed is not stable, while in direct connect, the connectivity and speed is stable. Let us end this session by recommending you 4 best VPC practices. Certain best practices are: we need to design or architect our VPC thinking about mid to long-term horizon. We need to maintain proper logs of what is the outflow and the inflow of connections with our VPC. We can monitor our VPC using services like Amazon CloudWatch. We need to have proper use of all the availability zones of our VPC. This acts as a backup in case one of the availability zones are not available due to certain issues. Also, importantly, we need to study more in details about the security aspects such as security groups and NACL. The network addresses which we assign to our VPC should also be looked into in details so that it supports the growth of our VPC from mid to long-term horizon. With this, we recommend you to go through these official documentation from AWS on VPC.
Let us try to understand why we need cloud-based monitoring with a couple of scenarios. In our first scenario, consider that you have hosted a messenger app on cloud, and your app has gained a lot of fame, but lately the number of people using your application has gone down tremendously, and you have no idea what the issue is. Well, it could be due to 2 reasons. Firstly, since your application has complex multi-tier architecture, monitoring the functionality of every layer by yourself will be a difficult task. Don't you think? And secondly, since you're not using any kind of monitoring tool here, you wouldn't know how your application is performing on cloud. Well, one solution for that is to employ a monitoring tool. This monitoring tool will provide you insights regarding how your application is performing on cloud. And with this data, you can make necessary improvements, and you can also make sure that your application is in par with today's customer needs. And definitely after a while, you'll notice that the number of people using your application has increased. Moving on to our next scenario, let's say your manager has assigned you with a project and he wants you to make this project as cost effective as possible. So as you can see in this project, you're using 5 virtual servers which perform highly complex computations. And all these servers are highly active during daytime. That is, they handle most traffic during daytime. But during nighttime, the servers are idle. By that I mean the CPU utilization of these servers during nighttime is less than 15%. And yet, as you notice here, in both the cases, you are paying same amount of money. You have to notice 2 points here. Firstly, all your virtual servers are underused during nighttime. And secondly, you're paying for the resources which you're not using. And this definitely is not cost effective. So, one solution is to employ a monitoring tool. This monitoring tool will send you notification when these servers are idle, and you could schedule to stop the servers on time. So guys, this is one way to make your project most cost effective and avoid paying unnecessary operating costs. Let's consider another scenario for better understanding. So let's say I have hosted an e-commerce website on cloud, and during sales season, many customers are trying to access my website, which is definitely a good thing. But for some unfortunate reason, application downtime has occurred, and you guys have to remember that I'm not using any kind of monitoring tool here. So it'll be difficult for me to identify the error and troubleshoot it in reasonable amount of time. And it's quite possible that in this period, my customer might have moved on to different website. So you see that I've lost a potential customer here. So if I've had a monitoring tool in the situation, it would have identified the error in earlier stages itself and rectified the problem. Well, I could have easily avoided losing my customer. So I hope guys, with help of these use cases, you were able to understand as to why we need cloud-based monitoring. So let me just summarize what we've learned till now. We need monitoring firstly because it provides a detailed report regarding performance of your applications on cloud. And secondly, it helps us to reduce unnecessary operating costs which we are paying to the cloud provider. Moreover, it detects problems at earlier stage itself so that you can prevent disasters later. And finally, it monitors the user's experience and provides us insights so that we can make improvements. So well guys, in this session, we will be discussing about one such versatile monitoring tool called Amazon CloudWatch. Amazon CloudWatch basically is a powerful monitoring tool which offers you a most reliable, scalable, and a flexible way to monitor your resources or applications which are currently active on cloud. It usually offers you with 2 levels of monitoring, which are basic monitoring and detailed monitoring. If you want your resources to be eligible for basic monitoring, all you have to do is to sign up for AWS free tier. In basic monitoring, your resources are monitored less frequently, like say every 5 minutes, and you're provided with a limited choice of metrics to choose from. Whereas in detailed monitoring, all your resources are monitored more frequently, like say every 5 minutes, and you're provided with a wide range of metrics to choose from. But if you want your resources to be eligible for detailed monitoring, you'll have to pay a certain amount of money according to AWS pricing details. Now, let's have a look at few monitoring services offered by Amazon CloudWatch. Amazon CloudWatch, firstly, it provides a catalog of standard reports which you can use to analyze trends and monitor system performance. And then it monitors, stores, and provides access to system and application log files. Moreover, it enables you to set up high-resolution alarms and send notifications if needed. And Amazon CloudWatch also sends system events from AWS resources to AWS Lambda functions, SNS topics, etc. So if you have not understood any terms which I've used here, don't worry, we'll get to know more about these terms as we progress through the course of this session. Earlier, I mentioned that Amazon CloudWatch allows administrators to monitor multiple resources and applications from single console. These resources include virtual instances hosted in Amazon EC2, databases located in Amazon RDS, data stored in Amazon S3, elastic load balancers, and many other resources like auto-scaling groups, Amazon Cloud Trail, etc. So guys, now let's try to understand Amazon CloudWatch a little deeper. Firstly, we'll have a look at few Amazon CloudWatch concepts, and then I'll explain you how Amazon CloudWatch actually operates. So it's metric. A metric represents a time-ordered set of data points that are published to cloud. So what I mean by that is, suppose let's say you have 3 variables x, y, and z, and you have created a table which has values of x with respect to y over a period of time. In this scenario, the variable x which you have been monitoring till now is a metric. So you can think of metric as a variable which needs monitoring. Next we have dimensions. Let's consider same variables x, y, and z. Previously you had created a table which has values of x with respect to y. Now let's create another table which has values of x with respect to z. So basically we have two tables which describe same variable x but from two different perspectives. These are nothing but dimensions. So basically a dimension is a name value pair that uniquely identifies a metric. And Amazon CloudWatch allows you to assign up to 10 dimensions to a metric. Then you have statistics. Previously we had created two tables which had values of x with respect to y and as well as z. You can combine data from these tables like to create a chart or maybe plot a graph for analytical purposes. This combination of data is nothing but statistics. Statistics are metric data aggregations over a specific period of time. Then you have alarm. Let's say you have been monitoring this variable x for some time now and you want a notification to be sent to you when the value of x reaches certain threshold. All you have to do is set an alarm to send you notification. So basically, alarm can be used to automatically initiate actions on your behalf. Now that you have clear understanding of concepts of Amazon CloudWatch, let's see how Amazon CloudWatch operates. Amazon CloudWatch has complete visibility into your AWS resources and applications which are currently running on cloud. So firstly, it collects metrics and logs from all these AWS resources and applications. And then by using these metrics, it helps you visualize your applications on CloudWatch dashboard. Moreover, if there is some sort of operational change in AWS environment, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective action, like maybe it sends you a notification or it might activate a Lambda function, etc. And finally, it provides you real-time analysis by using CloudWatch Metric Math. So if you're wondering what CloudWatch Metric Math is, it is a service which integrates multiple CloudWatch metrics and creates a new time series. And you can view this time series on CloudWatch dashboard as well. So working this way, Amazon CloudWatch provides you with system-wide visibility. It even provides you actionable insights so that you can monitor your application performance. Moreover, it allows you to optimize resource utilization if needed. And finally, it provides a unified view of operational health of your AWS environment. So I hope that by now you know what Amazon CloudWatch is. So now let's try to understand how Amazon CloudWatch works with help of a demo. So guys, this is my AWS console. Let's say AWS Management Console. And the services which you can see on the screen are the services offered by Amazon AWS. But in this demo, we're going to use only few services. Let's say CloudWatch, and then you have EC2 and a service called Simple Notification Service. And when I click on EC2, it takes me to EC2 dashboard where you can see that I have 4 instances which are currently active. You know that here in this demo, I'm supposed to get a notification saying that CPU utilization of my instance is less than 25%. For me to receive a notification first, I'll have to create a topic and subscribe to it with my email ID. So let's explore a service called Simple Notification Service, where you can create a topic and subscribe to it. Once you reach SNS dashboard, click on Topics option on the navigation pane and click a Create New Topic. Give your topic a name. Let's say CW Topic and give the display name as well. Let's give the same name and click on Create Topic option here. You can see that I've successfully created a topic. Now click on the topic which you have created and select Actions and subscribe to Topic option. Well, I want notification to be sent to me in form of email. You have different options as well in form of Lambda function or JSON, etc. But I'm going to choose it as email and give my email ID, which is here, and then click on Create Subscription option. So now whenever AWS console wants to send me a message, it will send to the email ID which I used to subscribe the topic. Now let's go back to CloudWatch dashboard. So guys, this is my CloudWatch dashboard and you can see different options on navigation pane. Firstly, I have dashboard where I can view all my metrics at same place. Then you have alarms, which shows the list of alarms which you have configured. And then you have events and logs, which we'll be exploring later. Our topic of interest is the last one, which is metrics. Select the metrics option here and then choose EC2 and then per instant metrics. When you do that, a list of metrics will be shown to you like network out, CPU utilization, network packets in, network packets out, and various other metrics for various resources which are currently active on your cloud. So, but we are interested only with CPU utilization. So I'm going to type that here. Well, it shows the list of instances which are active on my cloud. And I'm going to choose Windows 2 instance and then click on Graph Metrics option here. Okay, let's select Windows 2 only. And then on the right side, you can see you have a alarm button. When you click on that, a dialog box will be open where you can configure your alarm. Firstly, let's give alarm a name. Let's say low CPU utilization and a brief description as well. Let's say lower than 25%. Lower than 25% CPU utilization. Now I'm going to set the threshold, which is less than 25% in this case. And on the right side, you can see a period option. If your resources are eligible for basic monitoring, this period option by default is 5 minutes. And if your resources are eligible for detailed monitoring, it's usually 1 minute. And when you scroll down, you can see a send notification to option here. So select the topic which you have previously created. That will be C topic in my case, and then click on create alarm. Well, there is some error. Okay, it says there's an alarm already with this name. So let's give it another name of my instance. Now let's try again. And when you click on this alarm button and click on refresh option here, it says that I've successfully created a alarm. Here you can see that low CPU utilization of my instance. And when you click on that, it shows you all the details like description, threshold, and what action it is supposed to take when alarm is configured and all the details. So guys, try it out. It'll be easy for you to understand CloudWatch console much better. Okay guys, now you know what Amazon CloudWatch is, what it does, and the way it operates. But to understand the capability of Amazon CloudWatch completely, we should be aware of two important segments of Amazon CloudWatch, which are CloudWatch events and CloudWatch logs. So let's discuss them one by one. Firstly, we have Amazon CloudWatch events. Consider the scenario. Let's say you've created an auto-scaling group, and this auto-scaling group currently has terminated an instance. So you can see this as some sort of operational change in AWS environment. When this happens, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective actions. Like in this case, it might send you a notification saying that your auto-scaling group has terminated an instance, or it might activate a Lambda function which updates the record in Amazon Route 53 zone. So basically what Amazon CloudWatch events does is it delivers a real-time stream of system events that describe change in your AWS resources. Now let's have a look at few concepts related to CloudWatch events. Firstly, we have event here. An event indicates change in AWS environment, and AWS resources generate events whenever the state changes. Let's say you have terminated an active EC2 instance. So the state of this EC2 instance has changed from active to terminated, and hence an event is generated. Then you have rules. Rules are nothing but constraints. Every incoming event is evaluated to see if it has met the constraint. If so, the event is routed to target. Target is where the events are handled. Target can include Amazon EC2 instances or a Lambda function or an Amazon SNS topic, etc. Now let's try to understand Amazon CloudWatch events better with help of use case. In this use case, we are going to create a system that closely mimics the behavior of dynamic DNS. And for those who don't know what dynamic DNS is, let me give an example. Let's say you want to access internet at home. Then internet service provider assigns you an IP address, but since internet service provider uses different kind of online systems, this IP address keeps changing, because of which it might be difficult for you to use this IP address with other services like webcam, security camera, thermostat, etc. So this is where dynamic DNS comes into picture. What dynamic DNS does is it assigns a custom domain name to your home IP address, and this domain name is automatically updated when IP address changes. So basically, dynamic DNS is a service that automatically updates a name server in domain name system. And Amazon offers you with a similar kind of service called Amazon Route 53. So in this use case, we are going to update Amazon Route 53 whenever an Amazon EC2 instance changes its state. Now let's see how the use case actually works. This use case precisely works this way. So whenever an EC2 instance changes its states, Amazon CloudWatch event becomes aware of these operational changes and it triggers a Lambda function. This Lambda function uses different kind of information regarding the instance like its public and private IP address, and it updates a record in appropriate Route 53 hosted zone. So let's say you have an EC2 instance and you have terminated the instance. So Amazon CloudWatch events become aware of this and it triggers a Lambda function. And this Lambda function deletes the record from Amazon Route 53. Similarly, if you have created a new instance, again Amazon CloudWatch events become aware of this and it triggers a Lambda function, and this Lambda function creates a new record in Amazon Route 53. I hope you have understood what Amazon CloudWatch events is and what it does. Now let's discuss how Amazon CloudWatch events works with help of a demo. So in this demo, we will schedule to stop and start EC2 instances with help of Lambda function and CloudWatch events. So let's go ahead with demo. So guys, you can see that I have 4 instances which are currently active. First, I'm going to create a Lambda function which is going to stop my Windows 2 instance. And you guys need to know that for Lambda function to do that, we need to assign permission. So Amazon provides you with a service called IAM, which is Identity and Access Management, where you can assign permissions. When you search for IAM in the tab, it shows you the service. Select that, and on IAM dashboard, on the navigation pane, you can see a policies option here. Select that and click on Create Policy option. First, it's asking you for a service here, which will be EC2 in our case. Click on EC2 function, then actions, which will be to start and stop my EC2 instances. So let's search for start instance. Well, a predefined function is already there, so you can choose that. Then you have stop instance. Again, select that. And then I want this to be eligible for all the resources, so I'm going to choose all resources here and click on review policy option. Let's give our policy a name, that is to start and stop EC2 instances, and description as well, a brief description, let's say to start and stop instances. And now click on create policies. It's taking a while. So I've successfully created a policy here. Next, we have to assign this policy to Lambda function. So click on roles here, then click on create role, choose Lambda function here and click on next permission. Search for the policy which we have created earlier, that is to start and stop. I found the policy, select that and click on next review option. It's asking for a name. Let's give a name. Start, stop instances and click on create role. I've successfully created a role. So what we have done here is we have assigned permission for Lambda function to control EC2 instances. Now let's create a Lambda function. You can search for Lambda in the search tab and there click on create function. Give your Lambda function a name. Let's say to stop instance and select the role which you have previously created and click on create function. You can see that I've successfully created a Lambda function. And now I'm just going to copy the code to stop EC2 instances here. I'm going to select this and paste it over here and make sure to save it. As you can see here in this function, it asks for instance region and instance ID. So let's configure the details. Let's give it as stop instance. And here you'll have to insert instance region and ID. Instance region and instance ID. Now we'll have to copy the instance region and ID of the instance whichever we need. So let's go to EC2 dashboard here. Now let's say I want my Windows 2 instance to be stopped. This is the instance ID which I'm going to paste it over there. Similarly, instance region now. Well, in this case, I'm choosing Windows 2 instance. You can choose whichever instance you want to stop. Once you're done that, you click on create option here. Test the configuration details. When you scroll down, you can see the execution results here. It says that my instance has been successfully stopped. Let's go and check in the EC2 dashboard. Here on the EC2 dashboard, I'm going to refresh it. And you can see that my Windows 2 instance has successfully stopped. Now we'll create another Lambda function which will restart this function. Again the same, search for Lambda function in the search tab and click on create function option. it asks for a name. So let's say start instance, and choose the role which you have previously created and click on create function. Again, you'll have to paste the code to start the instances over here and click on save option. Let's try to configure this. Let's name it as start instance. And again, it asks for two attributes, which are instance region and ID. Now all we have to do is copy the instance region and ID here, like we did earlier. Let's go to EC2 dashboard and copy the instance ID and region. Well, you guys can see that here my Windows 2 instance has been successfully stopped. Now I'll copy this and paste it over there. Similarly, instance region as well. And click on create option. Now test the configuration. And when you scroll down, you can see that my instance has successfully restarted. In the EC2 dashboard, I'm going to refresh this. Well, my Windows 2 instance is on its way to get restarted. Till now, I've used Lambda function to start and stop my instances. But now I'm going to automate this process with help of Amazon CloudWatch. So let's go to CloudWatch dashboard here. Well, it's taking a while to load. Then choose events option and click on create rule. So here we're going to schedule to stop my instances every day at 6:30 p.m. and to restart this instances every day at 6:30 a.m. So click on schedule. If you want to know more about cron expressions, you can visit Amazon documentation. So let me show you. It has 6 fields. Firstly, it's minutes, then you have hours, then day of month, day of week, and year. We're concerned only with minutes and hours because we want our instances to be start and stopped every day, every month. So let's give the details. So if you're going to create a rule to stop the instance, let's say 6:30 in the evening, 30 minutes and 18, which is nothing but 6 p.m. And then rest all, you don't have to mention anything. When you give a proper cron expression, sample timings will be provided to you. You can see here the rest of the sample timings. And now let's add a target function, which is Lambda function in our case, and select on stop instance function and click on configure details. Give your rule a name. Let's say stop my EC2 instance, and description to stop my EC2 instance at 6:30 p.m. every day, and click on create rule here. You can see that I've successfully created a rule to stop my instance every day at 6:30 p.m. Now let's create another rule to restart this instance every day at 6 a.m. in the morning. Again the same. Choose the schedule here and cron expression, which will be 6 a.m. in the morning. Again the sample timings are shown here. Then let's add target function, again Lambda function, and select the function that is to start instance and click on configure details. Let's name it as start my EC2 instance, and description as to start my EC2 instance every day at 6 a.m. and click on create rule. So now we have successfully created 2 rules to start and stop the EC2 instances at 6:30 p.m. and 6:30 a.m. respectively. So what we have done is we have saved our time here. We have automated the process of stopping and starting EC2 instances. So try it on yourself. It'll be easier for you to understand. So guys, now let's discuss our next topic, which is Amazon CloudWatch logs. Have you guys heard of log files? Well, log files are nothing but detailed record of events that occur when you're using your AWS environment. You can view your log files on your on-premise server as well. Search for an app called Event Viewer. Select the app and click on Windows Logs and select Systems. A list of log files will be shown to you. When you choose a particular log file, all the details regarding that log files will be shown, like the number of keywords, the login time, number of hours the file has been logged onto, and various other details. Similarly, you have log files created when you use AWS environment as well. So you can consider these log files as a data repository. Most of the metrics are generated from these log data. So whenever a metric is generated, a part of data is extracted from this log data. So you're designing metrics according to your like by choosing a part of data from this log data. So basically these log files are what you call a primary data storage place. And Amazon CloudWatch logs is used to monitor, store and access log files from AWS resources like EC2 Instances, CloudTrail, Route 53, etc. Let's try to understand CloudWatch logs better with help of some features. Firstly, you can use Amazon CloudWatch logs to monitor your application and system log files. Let's say you have made a lot of errors but trying to deploy your application on cloud. In this scenario, you can use CloudWatch logs to keep track of your errors and send a notification to you when the error rate increases certain threshold so that you can make avoiding errors again. Then you have log retention. By default, logs are kept indefinitely. But CloudWatch provides you with an option where you can set the period between 10 years to 1 day. Then you have log storage. You can use CloudWatch logs to store your log data in highly durable storage. And in case of system errors, you can access raw log data from this storage space. And then you have DNS queries. You can use CloudWatch logs to log information about the DNS queries that Route 53 receives. Now let's have a look at few concepts regarding CloudWatch logs. Firstly, we have something called log event. So log event is just a record of activity that has occurred in AWS environment. It's straightforward. Then you have log stream. A log stream is a sequence of log events that have same source. Then you have something called log group. Log group defines group of log streams that has same monitoring and access control settings. By default, you have to make sure that each log stream belongs to one or the other log group. Guys, now let's try to understand CloudWatch logs better with help of this use case. In this use case, we are going to use Amazon CloudWatch logs to troubleshoot the system errors. You can see that I have 3 instances here and a CloudWatch agent which is monitoring all these 3 instances. So what CloudWatch agent does is it collects custom level metrics from all these EC2 instances, and then all these metrics and logs collected by the agent are processed and stored in this Amazon CloudWatch logs. Amazon CloudWatch logs then continuously monitors these metrics, as you can see here. By then, you can set an alarm which will send you notification when some sort of error occurs in the system. So whenever you receive a notification saying that some sort of error is there in your system, you can access the original log data which is stored in CloudWatch logs to find the error. So this is how you can use Amazon CloudWatch logs to troubleshoot the system errors. So basically you are having a look at original data so you can solve your problems faster and quicker.
What is AWS CloudFormation? This is a service provided by AWS that helps you create and manage the resources so that you can spend less time managing those resources and more time focusing on your applications that runs in AWS. You have to create a template that describes all the resources you require, and thus AWS CloudFormation will take care of managing and provisioning all the resources. AWS provides a CloudFormation designer for designing the templates where you can put all the resources. You can also define the dependencies of all the resources that are needed, and you can also reuse your templates to replicate your infrastructure in multiple environment and region. So now let us see how AWS CloudFormation works. What it does is it creates or uses an existing template where user application composer of your text editor to create or modify a CloudFormation templates in JSON or YAML format. You can also choose your provided template where the CloudFormation templates describes the resources you want at the settings. For example, suppose you want to create an EC2 instance. Next, we are going to save the template locally or in an Amazon S3 bucket. If you created a template, then save it with a file extension like .json, .yml or .txt. Next, create a CloudFormation stack by specifying the location of your template file such as the path on your local computer or an Amazon S3 URL. If the template contains parameters, you can specify input values when you create the stack. Parameters allows you to pass in the values to your templates so that you can customize your resources each time you make a stack. You can create stacks by using the CloudFormation console, create stack API operation or create stack AWS CLI command. So this is how the CloudFormation works. So now let us see some of the use cases of CloudFormation. Infrastructure provisioning. So AWS CloudFormation provides infrastructure, which means infrastructure has code. This process can be performed multiple times to get exact replica across all environments. Next, auto-scaling environment. The infrastructure provides using AWS CloudFormation will always be provisioned with scaling environment, which will help you scale up or scale down depending on the incoming load. Integration with services. You can also integrate the AWS CloudFormation with different services like code pipeline, Jenkins CI or CD pipeline, and so on, which will help automate the deployment. Deployment in multiple regions. You can manage the AWS CloudFormation to deploy it in multiple regions, which will help you in disaster. So now let us see the main components of the CloudFormation. There are two main components such as templates and stack. Templates. An AWS CloudFormation template is a structured text file written in JSON or YAML format that defines the infrastructure and resources that needed to be deployed and manage the application on AWS. It acts as a blueprint for provisioning AWS resources in a replicable and consistent manner using declarative syntax. CloudFormation templates with their efficiency enables automation of infrastructure deployment, allowing users to define dependencies, configurations, and relationship between resources in a scalable and efficient way, making developers more productive. The main object is used to create the templates are AWS template format versions, where this specifies the CloudFormation template versions being used. It is typically at the top of the template and defines the versions of the CloudFormation template languages being used. Description. It provides an optional description of the templates. This helps document the purpose and the details of the CloudFormation stack. Metadata. Optional section that can include additional information about the template. Metadata can be used for documentation purpose or for other tools that process CloudFormation templates. Parameters. It defines input that are passed to the templates when it is deployed. Parameters allows customization of resources, configuration at deployment time. Mapping allows you to define conditional mapping for input parameters to actual values. Mapping are useful when you have different configuration based on various condition or environment. Conditions. It specifies condition that provides you with full control over whether certain resources are created or how they are configured. Condition can be intrinsic, function, and parameters to define the logic, ensuring a secure and controlled deployment. Resources defines the AWS resources that will be created or modified by the CloudFormation stack. Each resource is defined by its type and other attributes. Next is stack. In AWS CloudFormation, a stack refers to a collection of AWS resources that are created, uploaded, and deleted together as a single unit. A stack is defined by a CloudFormation template which specifies the resources and their configuration. The many types of stacks. The main types of the stacks are main stack. A main stack is a primary CloudFormation stack created directly from a template. It can include various AWS resources defined within the template and manage their lifecycle. Nested stack. Nested stack are the CloudFormation stack that are referred within another CloudFormation template as resources. They allow you to break down complex applications or infrastructure into smaller, reusable units. Nested stack improves the organization, modularity, and reusability of CloudFormation templates by encapsulation groups of resources that logically belongs together. They can be updated and managed independently while being part of a larger stack. Change set. While not exactly a type of stack, change set are a mechanism in CloudFormation that allows you to preview changes to your AWS infrastructure before implementing them. Change set shows you how proposed changes to a stack and would impact your resources while helping you to understand the scope and impact of updates. They are particularly useful for reviewing potential updates to maintain or nested stack before applying them to ensure they meet your requirements. So now let us see a demo on how we can create a stack in CloudFormation that manages our resources using the template for our applications. So before that, we'll see a sample template which we'll be using to create a stack. As you can see that this is a sample template which we'll be using to create a stack. So basically it contains the AWS template format version and it contains resources where it will be having order tables and other properties of the table such as author name, book titles, etc. It also has a key schema which specifies author name with a key type as hash and book title has a key type of range. And it uses live specification to know the time expiration of the stack when we create and when we want to delete the stack. And we use different policies. Here we are using DynamoDB query policies, where we'll be using IAM roles, which specifies IAM roles in the DynamoDB query policy. When we are creating a stack, database that we're creating in a stack will be stored in DynamoDB, and which will help us to know the difference or changes that we made in template to show in the database. So now let us create a stack. So as you can see that I have recently opened the CloudFormation. If you want to open the CloudFormation, you can directly search in search button as CloudFormation. So click on CloudFormation. So as you can see that AWS console opens a AWS CloudFormation services, where there is an option called as create stack. So when we click on create stack, there will be 3 options to create a stack using 3 different methods of templates. First, we can choose an existing template that we have already seen before, and we can use a sample template which will be already present in the AWS services, or else we can build a AWS template from the scratch where we can specify our design and all other things. So what I'm going to do here is I'm going to choose an existing template. So I'm directly going to upload a template file from the template that I have been shown you before. So I'm going to choose the file. So this file can be in any format. It can be in JSON, YAML, TXT, text format. So I'm going to click on a file called as temp, where there will be templates. So after getting uploaded, you can get an S3 URL which confirms that there is no error in your templates. And if there are any error, it specifies here. So after that, if you want to know how your application composer looks, you can go through this and you can see the application composer, or else you can directly click on next. After clicking on next, a page appears where you have to specify your stack name so that you can create your stack. So I'm going to specify DynamoDB demo as my stack name. If you want to define the parameters, it is up to you. You can define it, or else you can click on next. So after clicking on next, there are 2 options here, tags and permission options. In tags, you can specify particular tags for the IAM role to access, or else you can give the tag so that your templates looks well organized enough, or else there are many other options you can use. It is up to you. There is another option called as permission optional. Here you have to specify IAM role if you're IAM user. As you can see that I am a route user, so I doesn't need to specify the IAM role. So these are the advanced options. So make it as default and click on next. So next, there is a page appearing with reviews and create. So you can basically create your templates or provide a stack name or parameter, give a tag name, give certain permission to your tag name and parameters that you're creating if you're creating. Then there are other options like stack policies and all. And when you scroll down, there is an option called as I acknowledge the AWS CloudFormation to create IAM resources. As you can see that before I didn't allow it to create an IAM resource. So it is asking a permission for us to create an IAM resource. So I'll click on that, then click on submit. As you can see that our stack is in progress, it's creating. So it may take some time. So better be patient and keep on refreshing until it shows us it is completely created. So as you can see that the order table query role is still in progress. And you can see that order query table is created completely. And next they're creating for DynamoDB query policy. So it is still in progress. Please be patient. As you can see that the DynamoDB query policy is also created completely. Next they are creating order tables. Make sure that you refresh it correct to create the stack completely. So as you can see that the order table is also created and the stack DynamoDB demo is finally created. So now what we are going to do is we are going to DynamoDB service where we'll be assuming or we'll check whether there is an database created in the DynamoDB. So let me type search DynamoDB. So as you can see it appears, click on that. So when you go to DynamoDB, you can see this as a dashboard. So on the left side, you can see there is an option called as tables. Please click on that. So after clicking on the tables, you can see that our table, authors table is created. A database is created here. where we are giving the reading capacity as 5 and writing capacity as 5. So this is how the stack works. When we create a stack, a database is created in DynamoDB, and this is how it looks. So now what we are going to do is we are going again back to CloudFormation. So what I'm going to do here is, as you can see, that the creation is completed. So what I'm going to do is I'm going to update here. So before updating, I'm going to make some changes in the templates. So what I'm going to do here is, there is a reading capacity unit of 5. So I'm changing it to 10 and saving this. After saving this, so you have to go to stack actions. There is an option called as create change set for current stack. Click on that to update or create your stack. So again, after that, there will be a 3 option where you can use the existing template. You can use the replace existing template. That means that when there is a changes made in the template, you can replace it with the current template, or you can edit in application composer. So what I'm going to do here is replace the existing template. So I'm going to upload the template that I have changed now. So I'll choose a template. As you can see that the template is uploaded and there is no error. So click on next. So this is the overview to make sure that the change set name is here. And if you want to specify why you're changing for your reference, you can specify it, or else you can leave it blank. Then after that, you can click on repeat. After that, you can click on next. So these are the same settings that we have done when we are going to create that stack, to make sure that there is no any changes while you are changing or updating your stack. Click on next. Same. Again, you have to give and acknowledge that you are allowing the AWS CloudFormation to create IAM resources. Then click on submit. As you can see that the stack is updated completely, and here it shows as modified order table. You can see the details here of the author table prod. It is modified. It shows the option as modified. Now what we are going to do is we are going to execute the change set. So at the right side of the top corner, there is an option called as execute change set. Click on that. They'll ask for the permission if you want to make any changes in the settings. I'm not going to make any changes. I'll make it as default and execute the change set. So as you can see that there is an option coming here to known as update in progress. So your data set will be updated here, or a template that you have changed will be updated here, and this may take some time. So please be patient and make sure to refresh it. As you can see that the update is completed. So this is what we can do by using update option, where we can change or update in templates and make sure that those updates are there in our stack, and it is useful to create our resources. So if you want to know if that is updated or not, go to DynamoDB, go to tables. So as you can see that the reading capacity mode, it was 5 before. As I have changed or updated in the template, it is also changed here. So this is a difference when we use a stack or update or create a stack. Now we have seen how to create a stack, how to update a stack. Now let's go to CloudFormation again. See, even here also it shows us it is updated completely. So now what I am going to show is, we have seen how to create a stack, how to update a stack. Now the last one is how to delete a stack. This is a very simple option. As you can see that there is an option called as delete option. When you click on it, it will ask your permission whether you want to delete it permanently, because it cannot be undone. So before you delete it, make sure that you have a copy of it. And if the data is not so important, you make sure that you delete it, or else you make a copy of it. So I'm going to delete this. So you can see that here it shows as delete in progress. The status is delete in progress. So when I refresh it, it may take some time to delete the stack. So please be patient and refresh again. This may take some time, so please be patient. As you can see that the delete is completed. So when we refresh this stack, so there will be no stack. So there will be an option to create a new stack. So this is how we can create a stack, update a stack, and delete a stack by using CloudFormation. This is mainly to help our applications when we use many services together. It saves our time and resources also.
So what are the different AWS storage services? Now, when you talk about storage services, there are quite a few storage services. Let us quickly take a look at those one by one. So Amazon Elastic Block Storage is one of those storage services. What it does is it basically gives you storage in the form of blocks. Each of this block is connected to a particular system or an instance. So in order to access this memory or this storage, you have to make sure that you have an instance connected to it and you can access it through that instance only. So that is one limitation of Elastic Block Storage. Otherwise, it is highly scalable. You can kind of detach, attach volumes to your instances at your will, and it is a very good storage service. Having said that, the other storage service is Amazon Elastic File System or Amazon EFS. Now, this again works on a similar mechanism that Amazon EBS works on, but the difference is it is a shareable or shared file system. Hence, it is not attached to a particular system or an operating system. Then you have Amazon S3 Glacier, which again is a storage system or a service which basically lets you store archival data. Now, what do I mean by this? Well, there is certain data that you would not want to retrieve or use on daily basis or on frequent basis. In that case, you can actually go ahead and put your data in a service like Glacier, because what it does is it basically locks in your data for a certain while during which you cannot access it. Once you've cleared that duration, you are free to access this data. But the other issue is it takes or gives you high amount of latency. That means you cannot access this data in real time or right away. It takes a while to retrieve this data. So why should you store your data at a place or in a storage like Amazon S3 Glacier? Well, the benefit of this storage is it is very cheap, or it is more affordable when you compare it with S3. And the fact that it has high latency, that is the reason it is cheap. What kind of data can you store here? Say, for example, the data that you might not require every day. If you talk about Indian systems or Indian hospitals, we normally have our birth certificates that are delivered by hospitals to us once a baby takes birth. So what happens is once you get this so-called birth certificate, it is not every day that you're going to go to the hospital and request for a new birth certificate. But the hospital still has to maintain a copy of your birth certificate. That is, in case if you need to get this document, probably they can give it to you. So that is why this is some data which is important, but it is not needed every day. So that kind of data can be stored in Amazon S3 Glacier. I believe I've made my point. I've gone a little vague or out of the way to discuss this topic, but I hope we are on the same line. Having said that, guys, the other storage systems are AWS Storage Gateway, which basically forms a gateway between two different platforms. Say, for example, my data lies on my on-premise architecture, and I need to move it to Amazon Storage Services. So what I can do is I can have this storage gateway that lets me move my data from that environment to this environment. So in simple words, it acts as a middle layer or a gateway for storing data or for moving data. Then you have Amazon S3 Storage. Before that, I would also like to mention a couple of other services which are not there on the screen. Say, for example, you have your Snowball, which actually lets you move your data physically. I mean, you would be having a device or a system in which you would kind of copy your data, move to the desired destination, and then paste it there. But this happens physically. In case if you want to move large amount of data, then you have other storage service by AWS called as Snowmobile, which is a moving data center which works on the similar principles. You copy your data from your existing environment into the data center. It is physically transferred to the main location, and from there you can move your data to the data center where you are planning to move it. And this might take 5 to 7 working days depending upon the location where you are planning to move the data, and a lot of other policies come into picture as well. So this was about the other storage services that AWS has to offer. There are a couple of other storage services that AWS still offers, and I haven't discussed those, but you are free to visit Amazon's official channel to know more about those. As far as today's topic is concerned, our main focus would be on S3 storage. So let us just move further and try to understand what the storage exactly is. So guys, when you talk about S3, now it is a simple storage service which is simple or easier to use in real sense. It lets you store and retrieve data which can be in any amount, which can be of any type, and you can move it from anywhere using the web or internet. So it is called as storage service of the internet. What are the features of this particular service? It is highly durable, guys. Now, why do I call it durable? It provides you durability of 99.999999, some 11.9. Now, when you talk about that amount of durability, it is understandable how durable this service is. What makes it this durable? It uses a method of checksum where it constantly uses checksums to analyze whether your data was corrupted at a particular point. And if yes, that is rectified right away. And that is why this service is so durable. Then it is highly flexible as well. As I've already mentioned, S3 is a very simple service, and the fact that you can store any kind of data, you can store it in any region or any available region is what I would mean by the sentence. It makes it highly flexible to store the data in this particular service. And the fact that you can use so many APIs, you can kind of secure this data in so many ways, and it is so affordable. It meets different kinds of needs, thus making it so flexible. Available. Is it available? Yes, definitely it is very much available. As we move into the demo part, I would be showing you which regions basically let you create these kind of storages and how can you move and store data in different regions as well. So if you talk about availability, yes, it is available in different regions, and the fact that it is so affordable, making it available becomes all the more easy. Cost efficient, yes. Now to start with, we normally do not get anything for free in life, but if you talk about S3 storage, AWS has a free tier which lets you use AWS services for free for 1 complete year. But this happens in certain limits. Now, when you talk about S3, you can store 5 GB of data for free, at least to get started or get used to the service. I believe that is more than enough. And what it also does is it lets you have somewhere around 20,000 get requests and somewhere around 2,000 put requests as well. So these are something that let you store and retrieve data. Apart from that, you can move in 15 GB of data every month outside of your S3 service as well. So if you're getting this much for free, it is definitely very much affordable. Also, it charges you on pay-as-you-go model. Now, what do I mean by this? Well, when I say pay-as-you-go model, what we do here is we pay only for the time duration that we use this service for, and only for the capacity that we use this service for. So that is why as you move along, if you need more services, you would be charged more. If you do not need more amount of the service, you won't be charged to that greater extent. So is it cost efficient? Definitely it is. Scalable? Yes. That is the best thing about AWS services. Most of them are scalable. I mean, you can store huge amount of data, you can process huge amount of data, you can acquire huge amount of data. If it is scalability that is your concern, you do not have to worry about it here, because even this service readily scales to the increasing data that you need to store. And the fact that it is pay-as-you-go model, you do not have to worry about the cost factor as well. Is it secure? Definitely it is. Now you can encrypt your data. You have various bucket policies as well that let you decide who gets to access your data, who gets to write data, who gets to read data. And when I said you can encrypt your data, you can actually go ahead and encrypt your data both on client side and on your server side as well. So is it secure? I believe that answers the question on its own. So guys, these were some of the features of Amazon S3. So guys, now let us try to understand how does S3 storage actually work. Now it works with the concept of objects and buckets. Now bucket, you can think of it as a container, whereas an object is a file that you store in your container. These can be thought of as AWS S3 resources. Now when I say an object, basically object is your data file. I've already mentioned that you can store any kind of data, whether it's your image, whether it's your files, docs, whatever it is. These are nothing but your data, and this data comes with metadata. When I say an object, it is combination of your data plus some metadata or information about that data. What kind of information? Basically, you have the key, that is the name of the file that you use, and version ID is something that tells you which version are you using. As we discuss versioning, probably I would talk about version ID a little more. But meanwhile, I believe this is more than enough. Your objects are nothing but your files with the required metadata. And the buckets, as I've already mentioned, these are nothing but containers that hold your data. So how does it work, guys? Well, what happens is basically you go ahead and create buckets in regions and you store your data in those regions. How do you decide what buckets to use, what regions to use, where to create the bucket and all those things? Well, it depends on quite a few factors. When I say I have to create a bucket, I need to decide what region would be more accessible to my customers or to my users, and how much cost does that region charge me, because depending upon the region, your cost might vary. So that is one factor that you need to consider. and latency as well. I mean, if you put your data in an S3 bucket that is far away from you, fetching it might cause high amount of latency as well. So once you consider these factors, you can create a bucket and you just store your objects. When I said version ID, key, actually your system automatically generates these features for you. So for you, it is very simple. Create a bucket, pick up your object, put it in it, or just go ahead and retrieve the data from the bucket whenever you want to. So I believe this gives you some picture about what S3 is. Now, let me quickly switch into the demo part and let me give you a quick idea or quick demo as to how S3 works so that it is not too much theory for you people. So guys, what I've done is I've actually gone ahead and I've switched into my Amazon Management Console. Now, as I've already mentioned, AWS gives you a free tier for which you can use AWS services for free for 1 complete year. Mine is not a free tier account, but yeah, if you are a starter, you can create a fresh account. You just have to go ahead and give in certain details. All you do is you just go to your web browser, search for AWS free tier and sign in with the required details. They would ask you for your credit card or your debit card details. Enter any one of those for the verification purpose. And you can actually go ahead and set up alarms as well, which would tell you as in, okay, this is the limit to which you have used the services. And that way you won't be charged for access of data usage or service usage. Having said that, guys, this is about creating an account. I believe it is fairly simple. You can create an account. Once you create an account, guys, this is the console that would be available to you. What you have to do is you have to go ahead and search for Amazon S3. If you search S3 here, it would kind of redirect you to that service page. So guys, as you can see, this is the company's account probably. Somebody uses it in the company and they have their buckets that are already created. Let's not get there. Let us just go ahead and create our own bucket and just go ahead and put in some data into it. It is fairly simple, guys. I've already mentioned it is very simple to use kind of service. All I have to do is click on create bucket and enter in name for some bucket. Guys, now this name is unique. It is globally unique. Once you enter a name for the bucket, you cannot use the same name for some other bucket. So make sure you put in valid name. And the fact that I use the term global, something reminded me to be explained of. So guys, as you can see, if I go back here, I want you to notice this part. So guys, when you are into the management console or you open any service, by default, the region is North Virginia. Okay, so if I create a resource, it would go to this region. But when I select the service that is S3, you can see that this region automatically goes to global. That means it is a global service. It does not mean that you cannot create bucket in particular regions. You can do that, but this service is global is what they're trying to say. So let us just go ahead and create the bucket. Let us call it today's demo. You cannot use caps, guys. You cannot use some symbols. So you have to follow the naming convention as well. Today's demo. Sorry, I'm very bad at naming conventions, guys. I hope it is okay. Let it be in US East. You can choose other regions as well, guys, but for now, let it be whatever it is. So I'm gonna stick to North Virginia. There are 76 buckets that are being used. Let us just say next. Bucket name already exists. So this was already taken, guys, see. So you cannot use it. Let's call it, say, Ramos bucket 13113. Okay, do you want to keep all the versions of the object? We will talk about what versions are. Okay, guys. Meanwhile, you just bear with me. I'm just going to go ahead and create a bucket. Create a bucket. And there you go, guys. I'm sure Remo's bucket should be here somewhere. Here it is. If I open it, I can just go ahead and create folders inside it, or I can directly upload data. So I say upload, select a file. Let's just randomly select this file. It is Van Rossum, founder of Python, basically. Let's just say next, next, next. And the data is uploaded, guys. You can see the data being uploaded and my file is here for usage. So guys, this is how object and bucket kind of stuff works. You can see that this is the data that I have. If I click on it, I would get all the information. What is the key? What is the version value? For now, let's not discuss version, but this is the key or the name of the file that I've uploaded. So it is fairly clear, right, guys? So let us just quickly switch back to the presentation and discuss some other stuff as well. Now guys, another important topic that is to be discussed here is S3 storage classes. Now we've discussed how the data is stored or how buckets and objects work. But apart from that, we need to discuss some other pointers as well. As in, how does AWS charge me, or what kind of options do I have when it comes to storing this data? So it provides you with 3 options, guys: standard, infrequent, and glacier. Let me quickly give you an explanation to what do these storage classes mean and what all they offer to us. When I say standard, it is the standard storage which gives you low latency. So in case if there is some data that needs to be fetched right away, you can actually go ahead and use standard storage. Say for example, I wish to go to a hospital for certain kind of checkup. So in that case, my details would be entered in. And the fact that I'm getting myself checked in a hospital or diagnosed in the hospital, what happens is this data is important, and if it is needed right away, it should be available. So this kind of data can be stored in your standard storage where the latency is very less. The next we have infrequent access. Now what do I mean by that? Now in this case, my latency period has to be low because I'm talking about data that I would actually need anytime if I want to. But when I store this data for a little longer duration, all I want is this data to be retrieved quickly. Say for example, I get a particular report or a particular test done. So in that case, I would actually go ahead and submit my details, or say for example, my blood samples, but I need this information maybe after 3 days. So what happens is, in this scenario, I would want to store this data for a longer term, but the retrieval should be faster here. In the first case, that was not the case. If I needed that data right away, and if I wanted it to be stored for a very short duration, I would use standard. But if I want to store it for a longer duration and I want a quick retrieval, in that case, I would be using infrequent access. And finally, I have Glacier. We have already discussed this. Here, your retrieval speed is low and the data needs to be put in for a longer duration. And that is why it is more affordable. If you take a look at the stats that are there in the image above, you can see that minimum storage duration is nothing for standard. For infrequent, it is 30 days, and for Glacier, it is 90 days. If you take a look at latency, it is milliseconds, and 4 hours. So that itself explains a lot of stuff here. So what are storage classes and what do they do? I believe some idea is clear to you people. Again, as we move into the demo part, we would be discussing this part as well. And we would also discuss expiration and transition that supports these terms. But let us move further and try to understand something else first. Versioning and cross-region replication. Now guys, when I say versioning, I'm actually talking about keeping multiple copies of my data. Now, why do I need versioning and why do I need multiple copies of my data? I've already mentioned that AWS S3 is highly durable and secure. How is that? Because you can fix the errors that are there, and you can also have multiple copies of your data. You can replicate your data. So in case if your data center goes down, a copy of it is mentioned or maintained somewhere else as well. How is this done? By creating multiple versions of your data. Say for example, an image, I store it in my S3 bucket. What happens here is there is key, the name is same, image, and version is some 33333, right? Now take a look at the other image. If I actually go ahead and create a copy of the first image, its name would remain same, but its version would be different. So suppose both of these images, they reside in one bucket. What these images are doing is they are having multiple copies or giving me multiple copies. Now in case of image, not a lot would change, but if I have doc files or data files, in that case, versioning becomes very important, because if I make changes to particular data, if I delete a particular file, a backup should always be there with me. And this is where versioning becomes very, very important. What are the features of versioning? By default, versioning is disabled when you say, or when you talk about S3, you have to go ahead and enable this versioning. It prevents overwriting or accidental deletion. We've already discussed that. You get non-concurrent version by specifying version ID as well. What do I mean by this? That means if I actually go ahead and create one more copy of the data and store it, so the latest copy would be available on top. But I can go to the versions option, put in the ID that belong to the previous version, and I can fetch that version as well. So what is cross-region replication? Now guys, we've discussed versioning. Let us talk about another important topic, that is cross-region replication. Now when you talk about S3, basically what happens is you create a bucket in a region and you store data in that region. But what if I want to move my data from one region or from one bucket in one region to other bucket in other region? Can we do that? Yes, cross-region replications let you do that. So what you do is you basically go ahead and create a bucket in one region, you create another bucket in another region, and probably you give access to the first bucket to move data from itself to the other bucket. So this was about versioning, this was about cross-region replication, and I believe we've also talked about storage classes. Let me quickly switch into the demo part and discuss these topics to little more detail. So guys, moving back, what we have done is we've actually gone ahead and created a bucket already, right? When you talk about what was the name of the bucket, it was Remos, if I'm not wrong. Yep. So if you click on the bucket name, Remos, what it does is it basically shows you these details, guys. Now you can see that your versioning is disabled, right? So if I click on it, I can actually come to this page and I can say enable versioning. That means a copy of the data that I create is always maintained. So if I go to Remos bucket or I just move back, okay, this interface can be a little irritating at times. You have to move back and forth every now and then. So guys, there is a file which we have stored. You can just take a look at this date first. It says that it is 2:35. That was the time when the object was moved. Let me just say that upload the same file. This was the file we uploaded. I say next, 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 upload. So guys, this file is getting uploaded. You can see the name of the file is still same. We have only one file here. Why? Because it was recently modified at 2:45. From 2:25 to 2:35, it got changed to 2:45. So it is fairly clear, guys, what is happening here. Your data is getting modified. And if you wonder as in what happened to the previous version, don't worry. If you click on this show option, you can see that both of your versions are still here, guys. This was created at 2:35 and at 2:45. So this way, data replication and data security works much better. So you can secure your data, you can replicate your data. So in case if you lose your data, you always have the previous versions to deal with. How does the previous version thing works? So guys, what happens is if I delete this file, what Amazon S3 would do is it would set a marker on top of this file. And once I delete it, if I search for that ID won't be available. Why? Because the marker has switched to the next ID now. So whatever I want to do, I can do with the next ID as well. So guys, one more thing that you also need to understand here is what happens to the file. I mean, I've actually deleted a file, but a version is there with me. Can I delete all the versions? Yes, you can specify the ID and you can delete all the versions that you want. You can also do one thing, that is you can set a particular life cycle for your files. When I say life cycle, you can decide as in, okay, now I have a file in standard storage. We've discussed these storages, right? Standard storage, infrequent, and Glacier. What you can do with your lifecycle management is you can decide as in, okay, for a particular time duration, I want this file to stay in standard. Maybe after a while, I want to move it to infrequent, and after a while, I want to move it to Glacier. Say, for example, there is certain data which was very important for me, but having used that data, I don't want to use it for next few months. So in that case, I can move to the substitutes or to the other storage classes where probably I won't be needing to use that data for a longer while. And doing that, I won't be paying for this data as I used to pay for the standard, because standard is the costliest of the three. So let us quickly see, can we do that, or how does it work at least? If I just go back, this is my file. I can actually just go ahead and switch to management. In that, I have the option of life cycle. If I click here, there is no life cycle. Add a life cycle. You can add a life cycle rule as well, guys. New, let me call it new, and let me say next. It asks me what do I want to do. You can add rules in lifecycle configuration to tell Amazon S3 to transition objects to another storage class. There are pre-request fees when using lifecycle to transition data to any other S3 or S3 Glacier storage. So which version do I wish to use? Current, I can say yes. Add transition, and I can select transition to this tier when after 30 days. And if I say next, it would agree. Expiration, you can select other policies as well. So guys, when I say transition, first thing what it does is it tells me what time to transition to which storage class. And expiration, it tells me when does this expire. So I can decide when to clean up the objects and when not to. Let's not do that for now. Let's just say next. Next. So guys, what will happen here is after 30 days, my data would move to standard 1A storage. So you can actually go ahead and decide whether you want to move to Glacier. In that dropdown, you had more options as well. I did not show you that, but it is pretty understandable. You can move to Glacier as well. So this is about life cycle, guys. One more thing, you have something called as replication. You can add replication as well if you wish to replicate your data. Cross-region replication. I believe, guys, I do not have access to do that because I'm using someone else's account for now. But let me just give you some idea as to what you can do to replicate your data. You can just go ahead and click on Get Started. So replication, to remind you people, it is nothing but a process of moving your data from bucket in one region to other bucket in some other region. So for that, I need to select a source bucket. So let us just say that this is the bucket that I have. Next. Now guys, in my case, I haven't created the second bucket. What you can do is you can just go ahead and create one more bucket. Once you create the bucket, you can select the destination bucket. For now, let us just say that this is a bucket that has been created by someone else. I'm not going to transfer data here, but let's just select this for the demo sake. This is the bucket that I have. See, it says that bucket does not have versioning enabled. This is very important point, guys. I showed you how to enable versioning, right? If you select the bucket, there is an option on the right side saying versioning. You can actually go ahead and enable versioning there. So once you enable versioning, you would be able to use this bucket. Do you want to change the storage class for the replicated objects? If you say yes, it would give you the option of selecting what storage class do you want to select, right? If you don't have to. You can say next. You have to enter an IAM role. If you do not have any, you just say create a role and then the rule name. In this case, I do not have any details about this and I don't want to create a role because this account does not belong to me. Sorry for that inconvenience, but you can actually go ahead and select create a role and just say next. And I'm sure that you can actually go ahead and your bucket starts working or your cross-region replication starts working. What happens after that is once you store your object in a particular file, you can actually move that object, not in a particular file, in a particular bucket. You can move that data from that bucket to the other bucket. And a copy of your data is maintained in both the buckets that you use. So this is what cross-region replication is, guys. I believe that we've discussed what are storage classes, we've discussed what is cross-region replication, and we've discussed versioning in general. Let us quickly move back to the presentation and discuss the remaining topics as well. So guys, I've switched into the presentation part. Till time we've discussed how cross-region replication works, we've discussed how versioning works, and we've seen how to carry out that process. The other important topic that we need to focus on is we've known like how to create versions, how to move data from one place to the other. But the thing is, what if I have to move data from a particular location to a location that is very far away from me and still ensure that there is not too much latency in it? Because if you're moving data from one location to a location that is far away from you, it is understandable that it would take a longer while. Why? Because we are moving data from internet. So the amount of data that you move and the further you move, it should take a longer while for that. So how do you solve that problem? You have S3 transfer acceleration. You can do that by using other services as well. We discussed Snowball and Snowmobile as well, but they physically move the data and at times it takes n number of days to move your data. With S3 transfer acceleration, that is not the issue because it moves your data at a very fast pace. So that is a good thing. So how can you move your data at a faster pace? By using S3 transfer acceleration. Now guys, let us first understand what it is exactly. So what it does is it enables fast, easy and secure transfers of files or long distances between your client and S3 bucket. And to do that, it uses a service called as CloudFront and the edge locations it provides you. As I move further, I would be talking about what CloudFront is. Do not worry about it. First, let us take a look at this diagram. So normally, if you are moving your data or directly uploading your data to a bucket that is located at a faraway distance, I mean, suppose I'm a customer and I wish to put my data into an S3 bucket, which is located maybe a continent away from me. So using internet, it might take a longer while. Instead, what I can do is I can use transfer acceleration. So how is it different? Now guys, there is a service called as AWS CloudFront. What it does is it basically lets you cache your data. When I say cache your data, that means you can store your data at a location that is in the interim or that is close to your destination. Now this service is basically used to ensure that data retrieval is fast. Suppose I'm searching for a particular URL. What happens is when I type that URL, a request is sent to the server, it fetches the data and sends it to me. So if it is located at a very far location, it might take a long while for me to fetch the data. So what people do is they analyze as in how much requests are coming from a particular location. And if there are frequent and a lot of requests, what they do is they set up an edge location close to that particular region. So you can put your data, you can cache your data on that edge location, and that data can be fetched from that edge location at a faster rate. So this is how edge locations work. What transfer acceleration does is it basically puts in your data at the edge location so that it can be moved to your S3 bucket at a quicker pace. And that is why it is fast. So guys, this was about S3 data acceleration. Let us quickly move into the console part and try to understand how S3 acceleration works. So guys, I've switched into the console. S3 acceleration or data transfer acceleration is a very easy thing to do. I do not remember the bucket name. I think it was Remos something. Okay, if I select this and open it, I can actually go to the properties part. Guys, there are other things that you might want to consider. You can come here and take a look at those as well. For now, I'm just going to say go ahead and enable transfer acceleration. It is suspended. I can enable it. It gives me the endpoint as well, and I say save. So guys, what this means is if I'm putting my data into this bucket, it would be transferred very quickly, or I can use this bucket to transfer my data at a quicker pace by using data transfer acceleration by S3. Again, guys, I missed out on one important point. The fact that we have been talking about buckets and stuff like that, there is something important that I would like to show to you people. First, let us just go back and disable this part. I do not want it to have the transfer acceleration thing going. And I just wanted to show it to you people how it is done. I just say go back to suspended. And one more thing, guys, if you once you actually enable the transfer part and if you upload a file, you can see the difference in the speed. The problem is you need a third-party tool to do that. So you can actually go ahead and download a third-party tool as well. And using that, you can actually go ahead and see how it works. Having said that, I was talking about buckets in general. So let us just go back and go to Remos again. There you go. And I'm going to copy the ARN. I'll tell you why. I've copied the ARN. Now, when I open this bucket, guys, we have quite a few things. Permissions, I talked about security, right? So you can decide public access as in who gets to access your bucket. So guys, you can actually go ahead and decide who gets to access what kind of buckets. Say, for example, here in your block public access, you can decide who gets to access what data publicly. For that, you have access control lists. Using these ACLs, you can actually decide who gets to access how. Other thing you can do is you can just go ahead and create a bucket policy and decide who gets to access your bucket or who gets to put your data, delete your data, and do all these things. Let us just go ahead and create a policy. Now you can write your own policy or you can just use a policy generator, which again is a third-party tool. So I want to create a bucket policy for my S3. So let's just say S3 bucket policy. And what kind of effect I want? I mean, do I want someone to access my system or do I want to deny someone from accessing my system? I can decide that. So let's for now just say that I want to deny someone from doing something. And what I want that someone to do is to deny a particular thing for that person for all the objects. I mean, I do not want that person to access any of the objects that is there. So what I say is star. That means nobody should able to do anything to any of the objects that are there in this bucket. So it says star service Amazon S3. What action I want? I want to prevent someone from deleting an object. There you go. And this is the ARN. That is why I copied it. It should be followed by a / and a star. Add a statement. And I say generate policy. So guys, the policy has been generated. I just have to copy it. If I copy this thing and I go back to the console, if I paste it here, I can say save. It's saved. I'll save it again just to be safe. So guys, we have actually gone ahead and let me just go ahead and again go to Remos. So guys, now there is an object here. Let me just try and delete this object. If I just go to the actions part here and I say delete, see the file is still here. Is it the other version? No, it's not deleted. See, there's an error here. If I click on it, it says 100% failed. Why? Access denied, because I do not have the access to delete the object right now. Why? Because I've created a bucket policy, guys. So that is what bucket policies and ACLs do. They let you make your objects or your data more secure. And as you saw in the option, there are quite a few options that you have at your disposal, which you can choose from, which you can mix and match and decide as in, okay, this is what I want to do. I want to probably give someone an access to delete a bucket. I want to give someone an access to do this or do that. So guys, this was about S3 data transfer acceleration, and we've also seen how you create a bucket policy, how you attach it to your bucket and stuff like that. Now let me just go back and kind of brush up this session or finish this session up with a use case so that you can probably understand the topics that we've discussed a little more. First, let us go back to the use case, guys. So guys, I've switched into my presentation console again, and we would be discussing IMDb Media. Now, for people who watch movies, they might know what IMDb is. It is a website that gives you details about movies. They tell you what are the movies that are nice. If you probably select or type a particular movie name, they would give you details about it, as in who were the actors, how was the movie, how was the review, a short snippet explaining you what the movie is about, its genre and stuff like that. Plus they have their own ratings to kind of gauge in the customers even better, as in IMDb being a popular site, and when they say that this movie is this person good or liked by these many people, people normally believe it. So they have that score as well. So if you talk about a website that basically deals with movies, you understand the number of movies that are released worldwide. And if most of them are present here on IMDb, that means that database is huge. But we are talking about data that is being processed in great numbers, great amounts. I mean, when you talk about the data that is here, what is happening here is you have n number of movies that are being released. So if someone searches for a particular movie, it has to go through the database and that data has to be fetched to him right away. So how do you deal with the latency issue? Well, this would answer a lot of questions, or it would sum up a lot of topics that we've discussed here. Let us go through this use case probably. So what happens here is, in order to get the lowest possible latency, all the possible results for a search are pre-calculated with a document for every combination of letters in the search. What this means is, probably based on the letters, you have a document that is created, and it is traversed in such an order that all the data is scanned letter-wise. When you actually go ahead and put forth a query, what happens is, suppose if there is a 20-character letter or a word that you put in, so there are somewhere around 23 into 1030 combinations that are possible. So your computer has to go through these many combinations. What S3 does is, it basically lets you store the data that IMDb has. And once IMDb has stored that data, they use CloudFront again. We have discussed what CloudFront is. They use CloudFront to store this data to the nearest possible location, so that when a user fetches this data, it is fetched from that location. So what happens is, basically, when these many possibilities or combinations are to be dealt with, it becomes complicated. But in practice, what IMDb does is, it basically uses analytics in such a way that these combinations become lesser. So in order to search for a 20-character letter, they basically have to go through 150000 documents. And because of S3 and CloudFront, you basically can distribute all the data to different edge locations and to buckets within hours. And since we are talking about huge amount of data, it is more than terabytes. It is like hundreds, thousands of terabytes of data. So we can understand how much data are we talking about. And S3 actually features or serves a number of such use cases or requirements. So guys, I believe by now you've understood what S3 is. Let me give you a quick sum up or a quick walkthrough as to what we've studied, because we've talked about a lot of topics, guys. First, we started with the basics of different storage services. We've understood storage services like EFS, EBS, storage gateway. We've talked about Glacier, we've talked about Snowmobile, Snowball, and then we moved to S3. S3, we talked about buckets, we talked about objects, we talked about versioning. We understood why versioning is needed, so that we can basically replicate our data, prevent it from deletion, prevent it from corruption. We also talked about a cross-region replication, where you can move data from one region to the other. We talked about how we can move data faster by using S3 data transfer acceleration. And then we also took a look at basics like what are the storage classes, what are the bucket policies, how to create bucket policies. And we also discussed an important topic called as transition and expiration, where if your data expires, it is deleted. If your data needs to be transferred to different stages, you can do that as well. So all these topics were discussed, and we also discussed some important features. And finally, we finished this session up with a use case.
I'm sure you know what a data warehouse is. You can think of data warehouse as a repository where data generated from your organization's operational systems and many other external sources is collected, transformed, and then stored. You can host this data warehouse on your organization's mainframe server or on cloud. But these days, companies are increasingly moving towards cloud-based data warehouses instead of traditional on-premise systems. And to know why, we need to understand the underlying architecture and the disadvantages of using traditional data warehouses. So let's begin by looking at architecture part. It is important to understand where the data comes from. Traditionally, data sources are divided into two groups. First, we have internal data, that is, the data which is being generated and consolidated from different departments within your organization. And then we have external data, that is, the data which is not getting generated in your organization. In other words, that is the data which is coming from external sources. So this traditional data warehouse follows a simple three-tier architecture. To begin with, we have bottom tier. In bottom tier, we have a warehouse database server, or you can say a relational database system. In this tier, using different kind of backend tools and utilities, we extract data from different sources and then cleanse the data and transform it before loading it into data warehouse. And then comes the middle tier. In middle tier, we have OLAP server. OLAP is an acronym for Online Analytical Processing. This OLAP performs multidimensional analysis of business data and transforms the data into a format such that we can perform complex calculations, trend analysis, and data modeling on this data very comfortably. Finally, we have top tier. This top tier is like a front-end client layer. This tier holds different kind of query and reporting tools using which the client applications can perform data analysis, query reporting, and data mining. So to summarize what we have learned till now, traditional data warehouse as a simple three-tier architecture. In the bottom tier, we have backend tools using which we collect and cleanse the data. And then in middle tier, we have tools, which is OLAP server, using which we transform the data into the way we want. And then finally, top tier, in which using different query and reporting tools, we can perform data analysis and data mining. Moving on to the disadvantages of traditional data warehouse concept, there is this leading US business service company, and this company is running a commercial enterprise data warehouse. This data warehouse has data coming from different sources across different regions. The first problem that this company faced was when it was setting up a traditional data warehouse. As we discussed earlier, the architecture of traditional data warehouse is not very simple. It consists of data models, extract, transform, and load processes, which we call ETL, and you have BI tools sitting on top. So this US-based company had to spend a lot of money and resources to set up a traditional data warehouse. Data warehouse, which was initially 5 terabytes, was growing over 20% year over year, and it was expected that there might be higher growth in future. So to meet this continuously increasing storage and compute needs, the company had to continuously keep upgrading the hardware. Again, this task of upgrading the hardware continuously involves a lot of money, manpower, and too many resources. So, autoscaling in traditional data warehouse is not an easy concept. And since the company could not meet all the storage and compute needs easily, it was facing a lot of performance issues as well. And finally, the company had to deal with increasing costs. Initially, they had to spend a lot on setting up data warehouse, like that to spend on hardware, manpower, electricity, security, real estate, and deployment costs, and many other. And as their data warehouse grew, they had to spend again to meet storage and compute needs. So to sum it up, setting up a data warehouse and deploying it and managing it later involves a lot of money and resources. Moreover, autoscaling in traditional data warehouse is not an easy concept. Because of all these reasons, many companies are increasingly moving towards cloud-based warehouses instead of traditional on-premise systems. So guys, in this session, we'll be dealing with one of the most famous cloud-based data warehouse provided by Amazon, which is Amazon Redshift. In simple words, Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost-effective for you to analyze all your data across your data warehouse and data lake. Guys, I have a definition which is put up on the screen, and I have few words which I have highlighted over there. So as we progress through the course of this session, we'll know what those words exactly mean. So let's ignore them for now. But there are certain key concepts which you should be aware of when you're dealing with Amazon Redshift. So we'll discuss them now. Amazon Redshift Dataware is a collection of compute resources which we call nodes. And these nodes, when organized into a group, they become clusters. Each of these clusters run an Amazon Redshift engine and it contains one or more databases. So this cluster has a leader node and one or more compute nodes. As for the leader node, it receives queries from client applications and then it passes these queries and develops a suitable query execution plan. And then it coordinates the parallel execution of these plans with one or more compute nodes. Once the compute nodes finish executing this plan, again the leader node aggregates the results from all these intermediate compute nodes and then sends it back to client application. Then we have compute nodes. You can think of these compute nodes as a compute resources that execute the query plan which was developed by leader node. And when they are executing this plan, they transmit data among themselves to solve many queries. These compute nodes are further divided into slices, which we call node slices. Each of these node slices receive part of memory and disk space. So the leader node distributes data and part of user query that it receives from client application to these node slices. And all these node slices work in parallel to perform operation and increase the performance of your Redshift data warehouse. So to say, we have leader node, we have compute nodes and node slices. But how do they interact with client application? That is the question here. So I have these client applications, basically BI tools, or it can be any other analytical tools, which communicate with Amazon Redshift using drivers like JDBC and ODBC. JDBC refers to Java Database Connectivity Driver. It is an API for programming language Java. Then we have ODBC. It refers to other database connectivity driver and it uses SQL to interact with leader node. So basically using these drivers, client application sends a query to leader node. Leader node, on receiving the client application's queries, it passes these queries and develops a suitable execution plan. Once the plan is set up, compute nodes and compute slices start working on this plan. They transmit data among themselves to solve these queries. So once the execution is done, leader node again aggregates the results from all these intermediate nodes and sends it back to client application. So this is the simple explanation of Amazon Redshift concepts. Moving on, when you launch a cluster, you need to specify the node type. Basically, we have two types of nodes. Dense storage nodes. These are storage optimized and they are used to handle huge data workloads. And basically, they use hard disk drive or HDD type of storage. And then we have dense compute. These dense compute nodes are compute optimized and they are used to handle high performance intensive workloads. And they mainly use solid state drive or SSD kind of storage. But there are three things that you should keep in mind when choosing one among them. Firstly, you should be aware of the amount of data that you want to import into your Amazon Redshift, and then the complexity of the queries that you run on your database, and the need of downstream systems that depends on the results of these queries. So, keeping these three things in mind, you can choose either dense storage nodes or dense compute nodes. So guys, that was the architecture and its key concepts. Now, we'll take a look at few reasons as to why Amazon Redshift is very popular. As we discussed earlier, setting up a traditional data warehouse involves a lot of money and resources. But it's very easy to set up, deploy, and manage a suitable data warehouse using Amazon Redshift. On Amazon Redshift console, you will find Create a Cluster option. When you click on that option, Amazon Redshift asks you for certain details like the type of node you want to choose, the number of nodes, the VPC in which you want to create your data warehouse, user ID, password, and many other details. Once you feel that you have given the right set of details, you have an option which says Launch the cluster. And one click, your data warehouse is just created. So with one click, you can easily create a data warehouse in Amazon Redshift. Once your data warehouse is set up, Amazon Redshift automates most of the common administrative tasks like managing, monitoring, and scaling your database. So you don't have to worry about managing or scaling your database needs. So that's how easy it is to develop or set up a data warehouse using Amazon Redshift. We also learned that auto-scaling is difficult in traditional data warehouse, but you can scale quickly to meet your needs in Amazon Redshift. Well, we already know that a cluster node has a leader node and one or more compute nodes. So if you want to auto-scale in Amazon Redshift, all you have to do is resize your cluster size. As we know, these compute nodes are like compute resources. So if you want to scale up, you can increase the number of compute nodes. Similarly, if you want to scale down, you just have to decrease the amount of compute nodes. Alternatively, we have something called single node and multiple node. In single node cluster, one node takes the responsibilities of both leader and compute functionalities. And the multi-node cluster contains one leader node and user-specified number of compute nodes. So suppose you want to resize your cluster and you are using a single node cluster, then you can change from single node cluster to multi-node cluster. Similarly, you can change from multiple node cluster to single node cluster when needed. So that's how easy it is to scale up and down in Amazon Redshift. Moving on, we learned earlier that while using traditional data warehouses, it's possible that the performance of your data warehouse might decrease. But with Amazon Redshift, you can get 10 times better performance than any other traditional data warehouse. It uses a combination of different strategies like columnar storage and massively parallel processing strategies to deliver high throughput and response times. So let's discuss these strategies one by one. Well, first we have columnar data storage. To understand what that is, first we should know row storage. Most of the traditional data warehouse and databases use this row storage. In row storage, all the data about a record is stored in one row. Okay, so let's say I have this database here. I have 3 columns and 2 rows. The first column contains the unique number associated with student. The second column contains the name of a student and the third column contains the age. As we already know, data is stored in form of blocks in databases or data warehouses. So as you can see in row storage, the block 1 contains all information there is about a particular student, his SSN, his name, and then age. So basically it stores all the information that there is in a single row. So in the first block, you have information about first student, and in the second block, you have information about second student, and it goes on. Now the columnar storage. Again, I'm using the same database. Again, I have 3 columns and 2 rows. But column storage stores data by columns, with data for each column stored together. So again, we have blocks, but the first block here has all the data that is there in first column. So you have all the SSN stored in first block, and all names stored in second block, and all the ages stored in third block. So it goes on. There are a lot of advantages of using this column storage. Firstly, since in column storage, a single block contains same type of data, you can achieve better data compression. As you can see, columnar storage can hold values 3 times the records as row-based storage. Because of this, the number of input-output operations decreases. And thirdly, by storing all the records for one field together, columnar database can query and perform analysis on similar type of data far quicker than row storage. So this is how the concept of columnar storage, which is used by Amazon Redshift, provides us a better performance. And then we have massively parallel processing. I'm sure you might have heard of parallel processing in computer science. It's just that number of different processors work together or compute together or in parallel. Similarly, massive parallel processing in Amazon Redshift is nothing but clustering. We have already discussed this earlier. We have a cluster, and this cluster has a leader node and one or more compute nodes. And this compute nodes is further divided into something called node slices. So when this leader node receives a query, it develops an execution plan, and this compute nodes and compute slices work together or in parallel to execute this plan. And later, this leader node sends the results back to client application. So basically, this compute slices and compute nodes work in parallel to achieve better performance. Moreover, Amazon Redshift is also able to smartly recognize the data on nodes before running a query, which dramatically boosts the performance. So that's how we can get a 10 times better performance using Amazon Redshift. And then the cost. In traditional data warehouses, people had to spend a lot of money to set up and then later to maintain the data warehouse. But Amazon Redshift is the most cost-effective cloud-based data warehouse. If you remember, in traditional data warehouse, they had to spend on hardware, real estate, manpower, electricity, and deployment cost and many others. And as their data warehouse grew, they had to spend again on meeting the storage and compute needs. But in Amazon Redshift, we don't have to pay any upfront cost. So Amazon Redshift is most cost effective and it costs 1/10 of traditional data warehouse. You can start small for just $0.25 per hour without any commitments, and you can gradually scale up later if you need. In addition to all those advantages, Amazon Redshift allows you to query data from Data Lake. Data Lake is a storage repository that holds a vast amount of raw data in its native format until it is needed. So in Data Lake, you have data in different formats. You can load data from Amazon S3 into your Amazon Redshift cluster for analysis very easily. That is, from data lake, you can store easily into your Amazon Redshift. But it needs more effort and cost. Effort because loading data into Amazon Redshift cluster involves extract, transform, and load, which we simply call ETL process. And this process is very time consuming and compute intensive. And it's costly because uploading lots of data, cold data from Amazon S3 for analysis requires growing your clusters, which is again costly and requires a lot of resources. So as a solution, we have something called Amazon Redshift Spectrum, which acts as an interface between your Amazon S3 or data lake and Amazon Redshift. So you can directly query data stored in Amazon S3 or data lake with this Redshift Spectrum without need for unnecessary data movement. I hope that was clear. And finally, with Amazon Redshift, your data is safe and secure. It offers backup and recovery. So as soon as data is created or stored in Amazon Redshift, a copy of that data is made, and through secure connections, a snapshot of it is sent to Amazon S3 for later. So suppose you lose your data, or if you have deleted the data from Amazon Redshift by mistake, you can restore the data easily from Amazon S3 service. Amazon Redshift also provides you with an option to encrypt your data. So when you enable this encrypt option, all the data in your cluster, in your leader node and your compute nodes and node slices is encrypted, and this way your data is very safe and secure. So guys, these are all the advantages of using Amazon Redshift. So now you have a basic idea of its architecture, its various key concepts like clusters, nodes, leader node, node slices. Now it's time to work on a demo. In this demo, we'll see how to transport data from Amazon S3 to Amazon Redshift data warehouse and perform simple queries. So I hope that was clear to you guys. Let's get started. But the first thing, there are certain softwares which you need to pre-install so that you can start working on Amazon Redshift. First, suppose you want to perform queries on the data on Amazon Redshift, then you need a SQL workbench where you can perform your queries. And as we learned earlier, the client application need a connection to communicate with Redshift. So we need to install a JDBC driver. And for that JDBC driver to run, we need to have a Java runtime environment. So we have three things to install here now. I'll show you how to install each of them. And I have this Java runtime environment download link by softonic.com. So it says free download and you click on that, it'll be downloaded. You can store it anywhere. And once you're done with that, search for Amazon Redshift documentation. So here it is. Okay, not that. This one. And when you scroll down, it says Amazon Redshift get started. Click on that. And in the step 1, we have prerequisites. Okay. Scroll down and it says in the step 2, you have an option where you can download or go to SQL Workbench website and download it. So click on that. And here it says build current version. And you have download generic packages for all systems. You can download it. Once you click on that, it'll start downloading. And there is one more thing, which is JDBC driver. Go back to documentation part. Scroll down and the step 4, you can see configure a JDBC connection. Click on that. It'll take you to a page where you have JDBC drivers of different version. You can download the first one. Click on this and it'll be downloaded. So once all these three things are downloaded, store them in a file of your choice. Well, I have stored them on my desktop. I have this AWS folder and in that Redshift. So here's my workbench, a zip file. It was a zip file, so I extracted all the files. And then I have my JDBC driver here. Well, Java runtime environment isn't download, so that's okay. So I hope that was easy. So just install all these things and you're set to go. And we're back to our Amazon management console. I have previously used Amazon Redshift, so I have this Amazon Redshift in recently visited services. Anyway, you can search for Amazon Redshift here. Here it is. Well, it's taking time to load. Okay, this is my Amazon Redshift console page. And you have different kind of options on your navigation pane on the left side. And there are two ways to create or launch a cluster. First, you have quick launch cluster option and launch cluster option. This is the very easy way to launch a cluster. But suppose you want the freedom to specify all the details as in the VPCs, the security groups, different type of nodes, username, password, and all that, you can go for launch cluster option. Let's go ahead and explore that. So first it asks for a name, let's say my cluster, and database, DT1, and the port, this is default port, 5439 is the default port which will be handled by Amazon Redshift. Then the master username, let's say AWS user, and password. That's it. And confirm your password and click on continue option. So cluster details are done and dusted. Then you have node configurations. Well, for the free tier, you only have DC2 large. But suppose you have a premium membership, then you can choose any of this. For this DC2 large, this is the CPU capacity, memory, and storage. And the input output performance is moderate. You can go ahead and choose the cluster type. We discussed this. We have multi-node and single node. In single node, we have both the leader and the compute node responsibilities handled by single node. The multi-node, we have a single leader node and user specified number of compute nodes. Click on continue. And then here it asks for the VPC details, parameter group, and suppose you want encryption or not, and all the details. So basically, in this launch cluster option, you have the freedom to specify all the details. But for this demo, I'm going to use quick launch cluster option. So again, as for the free tier, I'm using DC2 large. And again, for the free tier, I'm using DC2 large type. It says there are 2 compute nodes. And let's retain the same cluster name. As for the master user, AWS user, now let me give the password. And the default port is 5439. And last option, we have to choose among the available IAM users or IAM roles. But the question is why we need an IAM role here. In this demo, I said that we're trying to import data from Amazon S3. But you need certain set of permissions to access data which is stored in Amazon S3. For that, we need to create an IAM role. So let's go back to IAM service. Let me close all these tabs. Okay. Here you have roles option. You can click on that and click create role. And since we're dealing with Amazon Redshift, select Redshift, Redshift customizable, and click on next permissions. So we want Amazon Redshift to access data from Amazon S3. So search for S3 here. And you have a permission which says Amazon S3 read-only access. Well, for this demo, this is an if, but there is one more permission which says Amazon S3 full access, so you can perform read and write operations as well. As for this demo, I'm going to choose this permission which says Amazon S3 read-only access provides read-only access to all the buckets in Amazon S3. And click on next review. Give your role a name. Let's say my Redshift role 2 and click on create role. So now our Amazon Redshift database has permission to access data from Amazon S3. Let's go back to Redshift console. Okay, let me refresh this. And now it's showing the role which has been created is showing here. So as you can see, unlike other launch option, in this, I didn't have to specify much details, just the node type, the number of nodes, and then the master username, cluster identifier, and password, and the default database port. And you can click on launch cluster option. So with one click, you've easily deployed a database on Amazon Redshift. If you remember, when we tried to use this launch cluster option, we had option to select a default database or use or create our own database. But when you use this quick launch cluster option, a default database called dev will be created for us. So guys, this cluster has been created. So before we connect it to your SQL workbench, let's try to explore here. You need to make sure that the database health status and in maintenance status, everything is in green color. As for the cluster status, it should be available. And for the database health, it should be healthy. Only then you can make a perfect connection with your SQL workbench. So you have this icon here, click on that. Well, you get all the information there is about your cluster. Or you can just go ahead and click on this cluster. So this is the endpoint. This tells me all about how to make a connection with this cluster. I have this. When I click on that, it says publicly accessible, yes. And the username is AWS user. And the security groups, apparently it just shows the TCP rules which are set. So that's about the endpoint. Then the cluster name, you have cluster type, node type, and it shows the nodes and the zone and the date and time when it was created. And you have cluster version as well. On the right side, you have cluster status, which is available, database health healthy. So is it currently in maintenance mode? No. And then you have parameter group apply status, which is in sync with your database. And there are a few other features as well. But here you can see this VPC group. Click on that. Go for inbound and make sure it is set for TCP. Okay, edit. Make this custom TCP rule. And here 5439. Custom. That's it. And click on save option. So that's the default port with which you can access the Redshift. And let's go back. Clusters. Okay, where were we? We changed the default group of VPC. So this is the URL with which you can connect to the SQL workbench. So let's copy this and paste it in our text file. I've pasted it over there. Well, if you're using ODBC connection, then you can use this URL. When you scroll down, you have capacity details of your entire cluster. It's DC2 large. So 7 EC2 compute units, total memory, storage, and platform. Okay. Let's go back to this IAM role. But I should have an IAM role option here. Let me see. Check it out. Okay. There's an option which says see IAM roles. You can copy this entire thing and paste it again in the editor so that while connecting it, it'll be easy for us to find it. Okay, then so now your cluster is created, your database or data warehouse is set up. Now you can just connect it with SQL Workbench and start working on it. So let's go back to the folder where I've stored my Workbench. Here it is. When you scroll down, there's a file which says SQL Workbench executable jar file. Open. So here it is. It's asking for a default profile name. Let's say new profile 1. Okay, then driver. That was Amazon Redshift driver only, JDBC driver. And this was the URL. We copied it earlier in the editor, so I'm going to paste it over here now. This is the URL. Control C and paste it. AWS user in the password. Okay, that should work. Make sure that you select this auto commit. Save it and then click on OK. It says connecting to the database. Now it's successfully connected. So I can easily perform queries now. First, let's create some tables. Well, I'm using the sample database from Amazon S3. So you have this AWS Redshift documentation. Go back to that. And here it says get started. And in the step 6, you have this default SQL queries and tables provided. So you can go ahead and use that. I have it stored in my editor. So I'm going to copy. First, I'm going to create all the tables. Control C and paste it over there. Let's check what tables are there. First, we have user table. Well, this is like an auction data schema. So you have user table, many users, and you have category users, the category, different categories to which users belong to. And then you have date on which a particular event occurred. Then you have event table, all the details regarding an event. Listing, as in the items which are being sold are listed here, all the details about the items. Then you have sales, as in which user is buying, how much, which item, and all that details. So basically we have 6 to 7 tables. I'm going to select all that and say run option. So here it says table users created, table venue created, category, date, event, listing, and sales. So all the tables are easily created now. As for the next part, we need to copy the data or the data for the database from Amazon S3 to Amazon Redshift. Let's go back to the editor. And I have this copy command. I'll explain you the format. Control C. And let's paste it here. Okay, let's explore this copy command. It says copy to the table users which you just created from this path. That is from the file which is stored in S3 bucket. But this is the credentials AWS IAM role which we copied to the editor earlier. Apparently, we're just giving a permission to access the data from S3. So we need to copy this IAM role here. And then we have delimiter. As in, let me go back to editor and show you an example. Okay. Let's say I have a data. Let's say I have name, Archana, space, some age, B, hobbies. So you can see this straight line. This is the delimiter, as in the thing which you're using to separate all the fields or the columns. So going back. So that's delimiter which separates the data. And this is region in which your S3 bucket is located. So that's it. But we have to replace the IAM role. This is the ARN of the role. I'm going to copy it. And wherever this is, you need to just paste it. Control V. Okay. We're done. Last one. So select everything and click on this execute button. It might take a while because the data set which was stored in Amazon S3 might contain large number of rows. So it might take a while. So as you can see, it states executing statement here. It says 1 out of 7 finished. So we have 6 more to go. So this SQL Workbench has successfully executed all the script which we have written here. Let's go and start performing some simple queries. Let's say I want to extract the metadata of user table. I have this query. Okay, select star from page table definition. So since we are extracting metadata from table name, let's say users, and click on execute option. So you have so many columns. Here it says first column user ID of type integer, encoding delta. Then you have username, first name, last name, city, state, email. So basically that's the metadata or the structure of user table. So we have sales ID, list ID, seller ID, buyer ID, and many other details. Let's execute some other command. Let's say I want to find total sales on a given date. Okay. Sum the count. Here I have some function which will count the number of sales from sales and date, where the sales date ID is date ID, and the date on which I want to calculate, I've specified it here, and then click. Okay, the sum error, it should show a number here. Rest is working, only that is not working. I've selected the user table and I've asked them to display all that there is in the user table. So this is the data. Okay, select star from users. So I want to extract the names of people who are from, let's say some states. Let's consider some state. Let's take NH. So STATE like NH. It should work now. It says executing statement. So these are the people who are from state NH. So basically, once you have the perfect connection from your SQL Workbench to your Amazon Redshift, you can perform whatever queries you like. So let's go back to our Amazon Redshift console. Well, so this is the cluster. I'm going to click on this. Here you have queries. When you click on that, all the queries which you performed till now will be shown. So this is the query. So it says first name from users who was from state NH. This was the query which we performed earlier. So you have all the data or all the information regarding the queries which you executed. Well, that's all about Amazon Redshift. So guys, this is how easy it is to create a data warehouse using Amazon Redshift. Go ahead and explore many other features of Amazon Redshift. Well, I've just showed a part of them here. So go ahead and create a database, perform various queries, and have fun.
What is AWS Kinesis? So Amazon Kinesis is one of the best managed services which particularly scales elastically, especially for real-time processing of the data at a massive point. These services can be used to collect large streams of data records which are especially consumed by the application process that runs on Amazon EC2 instances. This Amazon Kinesis is used to collect, streamline the process, and analyze the data so that easily we can get the perfect insights as well as the quick response with respect to the information. It is also offering the key capabilities at a cost-effective price in order to process the streamlined data at a particular scale with the help of flexible tools according to the needs and requirements. Through the Amazon Kinesis, you can also get the real-time data like the video, audio, application logs, as well as the website click streams, machine learning, and other applications too. This new technique by the Amazon will help you to analyze and process the data instantly instead of waiting for long hours after collecting the data. So this was a quick overview of AWS Kinesis. So now let us move on to the next part here, which is the advantages. So basically the first and foremost advantage of Kinesis is that it is real time. Amazon Kinesis enables you to ingest, buffer, and process streaming data in real time so that you can derive insights in seconds or minutes instead of hours or days. The next point here is that it is fully managed. Amazon Kinesis is fully managed and runs your streaming applications without requiring you to manage any complex infrastructure. And the third point here is the scalability. Amazon Kinesis can handle any amount of streaming data and process data from hundreds of thousands of sources with very low or minimal latency. So these were a few advantages of using Amazon Kinesis. And now let us talk about the next part here, which is the Amazon Kinesis capabilities. So the first service or the capability of Amazon Kinesis is the Kinesis video streams. The Amazon Kinesis video streams are used to secure all the stream data like videos, photos, and the connected devices to the AWS for machine learning, analytics, and other processing, which can give access to all the video fragments and encrypts the saved data without any problem. So you can refer to the diagram that is present on your screen right now. The next point here is Kinesis data streams. So this Amazon Kinesis data streams in the Amazon is specifically used to build the real-time custom model applications by preceding the data stream process by using the most popular frameworks. It can easily ingest all the stored data with all the data streaming prices by using the best tools like Apache Spark that can be successfully run on the EC2 instances. So the next point here is Kinesis data firehose. In order to capture, load, and transform the data streams into the respective data streams, this Kinesis data firehose is used to store in the AWS data store near all the analytics with all the existing intelligence tools. These tools can be used to prepare all the loads of the data continuously according to the destination with the durable for analytics, which gives an output like analyzing the streaming data. And the last point here is the Kinesis data analytics. The Kinesis data analytics in the Amazon Kinesis is one of the easiest ways in order to process all the real-time technique with SQL that has to learn all the programming languages with processing frameworks. This Kinesis data analytics is used to capture the streamed data that can run with all the standard queries against the data streams in order to precede the analytical tools for creating alerts by responding it in real time. So these were the capabilities of AWS Kinesis. So now let us discuss the use cases of Amazon Kinesis. So the first point here is the video analytical applications. This Amazon Kinesis in the application is also used to secure all the streaming video for the camera equipped devices which are placed in factories, public places, offices, and the homes to AWS account. This video streaming process is also used to play the video, monitor the security, machine learning, and face detection along with other analytics. The second point here is batch to real-time analytics. Using Amazon Kinesis, you can also easily perform all the real-time analytical steps on the respective data to analyze the batch processing from the data warehouses through Hadoop frameworks. Data lakes, data sciences, and machine learning are one of the most common methods used in such cases. In order to load the data continuously, you make the use of Kinesis Firehouse to update all the machine learning models more frequently for the new and accurate data outputs. The third point here is building real-time applications. If you want to build the real-time applications, you can also use this Amazon Kinesis in order to monitor the fraud detection along with the live leader results. This process can be used to ingest all the streaming data easily to the Kinesis streams with the analytics and the data that is stored in the application itself with the end-to-end latency. All these processes can help to learn more about the clients, products, services, and the applications to react immediately. And the last point here is analyzing the IoT devices. This Amazon Kinesis is used to process the streaming data directly from the IoT devices like the embedded sensors, TV setup boxes, and consumer appliances. You can also use this data in order to send the real-time alerts to the actions programmatically when the sensors exceed the entire threshold operating. It is better to use the sample of IoT analytics codes while building an application. So these were the use cases of Amazon Kinesis. And now we will move to the next part here, which is the comparison between Kinesis and SQS. Amazon Kinesis is differentiated from Amazon's simple queue service, that is SQS, in that Kinesis is used to enable real-time processing of the streaming big data. SQS, on the other hand, is used as a message queue to store the messages transmitted between distributed application components. Kinesis provides routing of records using a given key, ordering of records, the ability for multiple clients to read messages from the same stream concurrently, replay of messages up to as long as 7 days in the past, and the ability for a client to consume records at a later time. Kinesis streams will not dynamically scale in the response to an increased demand. So you must provision enough streams ahead of time to meet the anticipated demand of both your data producers and the data consumers. SQS provides for messaging semantics so that your application can track the successful completion of work items in a queue, and you can schedule a delay in messages of up to 15 minutes. Unlike Kinesis streams, SQS will scale automatically to meet application demand. SQS has lower limits to the number of messages that can be read or written at one time compared to Kinesis, So applications using Kinesis can work with messages in larger batches than when using SQS. So this was a comparison between Amazon Kinesis and Amazon SQS. So the next part here is to understand how does it work. So here I'm going to discuss the Amazon Kinesis data stream, which is one of the capability of Amazon Kinesis. So you can use Amazon Kinesis data streams to collect and process large streams of data records in real time. You can create data processing applications known as Kinesis data streams applications. A typical Kinesis data stream application reads data from a data stream as data records. These applications can use the Kinesis client library and they can run on Amazon EC2 instances. You can send the processed records to dashboards, use them to generate alerts, dynamically change pricing and advertising strategies, or send data to a wide variety of AWS services. Kinesis data streams is a part of Kinesis data streaming platform, along with other components as we previously discussed, such as Kinesis data firehose, Kinesis video streams, and Kinesis data analytics. So before discussing the architecture, let us have a look at the few of the terminologies that are used very frequently with Kinesis data stream. First term here is, what is a Kinesis data stream? A Kinesis data stream is a set of shards. Each shard has a sequence of data records, and each data record has a sequence number that is assigned by Kinesis data streams. So we will discuss shards and sequence in the later part of this session. The next term here is a data record. A data record is the unit of data stored in the Kinesis data stream. Data records are composed of a sequence number, a partition key, and a data blob, which is an immutable sequence of bytes. Kinesis data streams does not inspect, interpret, or change the data in the blob in any way. A data blob can be up to 1 MB in size. The next term here is the retention period. The retention period is the length of the time that the data records are accessible after they are added to the stream. A stream's retention period is set to a default of 24 hours after creation. You can increase the retention period up to 168 hours, that is 7 days, using the increase stream retention period operation, and decrease the retention period down to a minimum of 24 hours using the decrease stream retention period operation. So additional charges apply for streams with a retention period set to more than 24 hours. The next term here is the producer. So producers put the records into Amazon Kinesis data streams. So say for example, a web server which sends log data to a stream can be called a producer. And next term here is the consumer. Consumer gets the records from the Amazon Kinesis data streams and processes them. These consumers are known as Amazon Kinesis data streams application. The next term here is Amazon Kinesis data streams application. An Amazon Kinesis data streams application is a consumer of a stream that commonly runs on a fleet of EC2 instances. So there are two types of consumers here. So the first one is the shared fan-out consumer, and the second one is the enhanced fan-out consumers. The output of Kinesis data streams application can be an input to another stream, which enables you to create complex topologies that process the data in real time. An application can also send data to a variety of other AWS services. There can be multiple applications for one stream, and each application can consume data from the other stream independently and concurrently. So the next term here is a shard. A shard is a uniquely identified sequence of data records in a stream. A stream is composed of one or more shards, each of which provides a fixed unit of capacity. Each shard can support up to 5 transactions per second for reads and up to 1000 records per second for writes. The data capacity of your stream is a function of the number of shards that you specify for the stream. The total capacity of the stream is the sum of the capacities of its shards. If your data rate increases, you can increase or decrease the number of shards allocated to your stream. The next point here is the partition key. A partition key is used to group data by a shard within a stream. Kinesis data streams segregates the data records belonging to a stream into multiple shards. It uses a partition key that is associated with each data record to determine which shard a given data record belongs to. Partition keys are Unicode strings with a maximum length limit of 256 characters for each key. An MD5 hash function is used to map partition keys to 128-bit integer values and to map associated data records to shards using the hash key ranges of the shards. When an application puts data into a stream, it must specify a partition key. So the next term here is the sequence number. So each data record has a sequence number that is unique per partition key within its shard. Kinesis data streams assign the sequence number after you write to the stream with client.putRecords or client.putRecord. Sequence number for the same partition key generally increase over time. The longer the time period between the write requests, the larger the sequence numbers become. The next term here is the Kinesis client library. The Kinesis client library is compiled into your application to enable fault-tolerant consumption of data from the stream. The Kinesis client library ensures that for every shard there is a record processor running and processing that shard. The library also simplifies reading data from the stream. The Kinesis client library uses an Amazon DynamoDB table to store the control data. It creates one table per application that is processing the data. So these were some of the terms that you must be aware of before moving on to the architecture part. So the next part here is the architecture of how does Amazon Kinesis data streams work. So what happens here is, as you can see the diagram that is present on your screen right now, the producers continuously push data into the Kinesis data streams. So as you can see here, these are the producers which produce the data. So for example, EC2 instances, client, mobile client, or the traditional servers. So these devices produce the data here, and the consumers process the data in real time. So as you can see here, this data produced by the producers is processed using the Kinesis data stream here. So these are the number of shards that are required for this data here. And these are the consumers which consume the processed data. So say for example, here it is shown that EC2 instances are the consumers. So consumers can store their results using an AWS service such as Amazon S3, DynamoDB, Redshift, EMR, Kinesis Firehose, and so on. So this is the overall working of Amazon Kinesis data streams. So now let us just move on to the last part of this session here, which is the demo. So as far as demo part is concerned, I will show you how do you create a Kinesis data stream and how do you add data to that stream and how do you read that data. So let us just move on to the Amazon console here. So for that, you have to log into your Amazon console here. And once you log in, you will see this main page here, and here you have to click on services. So in the services part, in the analytics section, you have to click on Kinesis. Okay. So once you're done with that, you have to click on get started. So here you can find the documentation part of Amazon Kinesis, which you can read for your further understanding. So let me just click on get started here. So as discussed earlier, these are the 4 capabilities of Kinesis: data stream, delivery stream, which is the Firehose, analytics, and the video streams. Okay. So as of now, I'll click on this create data stream here. So let me just name it. You can name it whatever you want. So let me just name it my Edureka stream. So, and here you have to click on the number of shards. For timing, I'm just writing here 1. So this is the bare minimum value that you can enter here. And depending upon your account, so in my case, it is a free tier account. So for that, I can enter maximum of 200 shards. So the write capacity is 1 MB per second, that is 1000 records per second. And the read capacity is 2 MB per second. So click on Kinesis stream here. So creating a stream takes only a few seconds. So as you can see here, you get this message here, stream, my Edureka stream has been created and the status is active. So now what we will do, we'll go to the command prompt here and we will try and execute a few commands. So the first command here is the describe stream command. So the command for describing an already created stream is AWS Kinesis described-stream here. And then you provide the name of the stream using this parameter stream name, that is my Edureka stream. And then you just have to specify the region here. Okay, so the region here in my case is Asia Pacific South 1. Okay, once you do that, just hit enter here. Okay, so as you can see here, you get the description or the information of the stream that you just created. And for this, we have one shard ID here, as you can see here, this part. So we will see how to use this shard ID here. So this is the description of the stream that we just created. So the next command that we are going to see is, you have to put the data in this stream, data, or you can see the record. So the command for that is AWS Kinesis put record, stream name, the name of the stream, the partition key, I've just specified it to 1, and the data. So data, you can enter whatever value that you want here. For time being, or for this example, I have entered here 1, and then you have to specify the region here. So just hit enter here. So for this record here, you have the shard ID and the sequence number. So similarly, let me just enter one more record here. So let me just enter the data 11, and the partition key should be different. So it's 2 here. Again, hit enter here. So one more record has been added. Just let's add one more record here. Data is 111 and partition key is 3. Okay, so just hit enter here, and you'll see this record has also been entered with a shard ID and sequence number. So the next command that we're going to see here is the command to get the shard iterator. Okay, so what a shard iterator will do, so let me just brief you regarding that. So a shard iterator will iterate through a set of records here. So if you just had to iterate through the number of records that you have in your data stream, so for that purpose we use shard iterator here. So the command for that is very simple, as you can see on the screen. AWS Kinesis get shard iterator type, which is trim horizon here in this case, and then you have to enter the shard ID here. So for these records, so say for example for the first record here, the shard ID is this one. Okay, so let me just copy it and paste it here. So once you do that, you just have to hit enter here, and after this command gets executed, you will get a shard iterator. So this is the shard iterator that we have just got. Okay, so this lengthy thing here, so let me just copy it. So now once you have the shard iterator, what you have to do is you have to get the number of records here. So for that, the command is AWS Kinesis get records shard iterator, and then you have to copy this iterator here, copy it, you can just paste it here, and you have to enter the limit here. So say for example, if you want only 2 records, so you can do that using this flag or parameter called limit here. So let me just enter the limit for 3 here, since we have entered 3 records. So if you just hit enter here, so as you can see here, you have got 3 records here. Okay, so this is the data and this is the partition key. So data is in encoded form here, this MQ equal to, okay, and the partition key is 1. So similarly, we have another data, and the partition key for that is 2. Okay, so this was 1, this was 11, and this was 111. So you can also decode this data if you want. And for the third record here, the partition key is 3, and this is the data here. So this is how you write data and you get records from the Kinesis data stream here. So I hope this demo here, it is good enough to get you started with Amazon Kinesis here. Similarly, you can get started with other Amazon Kinesis services here, such as the Firehose, Analytics, and the video streams. So this was the demo part here that I've just covered.
In this video, I'll demonstrate how to use AWS Lambda and API Gateway to create a REST API, showing how Lambda functions are triggered by incoming requests and also display results directly in the browser. Now let's take the example of Netflix, which is one of the world's leading entertainment services with over 260 million members in more than 190 countries, and is transforming its infrastructure with AWS Lambda. Netflix is no stranger to complexity. Each quarter, they deliver billions of hours of videos to millions of customers worldwide. Supporting this demand requires a powerful, agile infrastructure, and Netflix as an AWS customer relies on AWS Cloud Power to keep up. With Neil Hunt, Netflix's Chief Product Officer, leading the way, Netflix plans to use AWS Lambda to create rule-based, self-managing infrastructure to replace outdated, inefficient processes, reduce errors, and free up time. By integrating Lambda, they have set their sights on automating tasks that are once required hands-on management. With Lambda, Netflix now has the potential to improve efficiency, reduce costs, and also deliver a more seamless experience. Here's how Lambda has already helped solve some major challenges. First, we have is encoding media file. Netflix receives huge volume of media files from studios. With Lambda, every new file triggers rules that break down,
encode and reassemble content for streaming. This automation speeds up the encoding process, reducing wait times and manual effort. Next we have is backup for disaster recovery. Previously, data backups were time-intensive. Now, Lambda can trigger backups whenever new data is saved, ensuring all data is backed up automatically and securely, and rerunning failed backups when needed. Similarly, two more problems: security and conformity, and then dashboards and monitors. By building this rule-based, self-managing infrastructure with AWS Lambda, Netflix is turning its vision of a fully automated and efficient system into reality, serving millions of members with a smarter, faster, and more secure service. But how? You only have to spend running the code once. So, there is no wasted resources and no need to worry about under or over provisioning servers. Pretty cool, right? AWS Lambda really helps businesses like Netflix, Flipkart, which handle high volume tasks without the stress of managing all the infrastructure. Now let's understand what exactly means by AWS Lambda. AWS Lambda is a serverless computing service provided by Amazon Web Services that allows you to run code without provisioning or even managing servers. Alright, let's dive into a demo where I'll show you how to use Lambda function and API gateway to create a REST API. We'll also see how it triggers the Lambda function and how it all works together. Let's get started. Now as you can see this AWS platform, let's start with the first step. Now let's create a Lambda function. This function will act as our API backend. Now let's go to AWS Lambda service and click on Create Function and name it as New API Lambda. We have the runtime as Node.js. Now let's change the runtime to Python. Let's click on Create Function. For this demo, I'll keep it simple with a basic message response. But in a real-world setup, this function could hold any backend logic for your application. Add the desired functionality for your API in the Lambda function code. For this demo, add code to simply return the message here. By default, we have hello from Lambda. Now let's type into hello from Edureka as well. Moving forward, now click on Deploy. So here you can see the deployment is successful. Moving forward, we have to create a REST API in API Gateway. For that, let's go to API Gateway Service in AWS and select REST API. Now, choose New API, name it as My First API and set the endpoint type to regional and click on Create API. Now we will create a method for the API. Select the /resource in the API gateway and click on Create Method. Then choose Get as HTTP method. For the integration type, select Lambda function. Choose the Lambda function created in the previous step, that is, New API Lambda. Click on the Create method. Confirm any prompts to grant API gateway permission to invoke the Lambda function. Here you can see that the API is successfully created by the get method. Now let's configure the integration and test the setup. If you see here, this is how the API works. First we have the client. The client sends a request to the API. So in method request, the API checks the request like permissions and then an integration request. The request is forwarded to the Lambda function and then comes the Lambda integration. Lambda processes the request and returns a result. Next in the integration response. The Lambda output is formatted for the API. And in the method response, the API prepares the response for the client. At the last in, we have the client. The final response is sent back to the client. This is how the flow works from the client to the Lambda and back. So, we can also test this API. For that, let's deploy the API. In API Gateway, go to Actions, Deploy API, create a new stage. Let's put the stage name as Dev and click Deploy. Now the API is deployed. Now let's invoke the API. Copy the invoke URL from the deployed stage. Paste the URL in a browser like Chrome or a tool like Postman to test the GET request. Here you can see the response as status code 200 along with hello from Edureka. So, this is a short demo using the AWS Lambda function and API gateway to create a REST API.
What is AWS EMR? So Amazon EMR, that is Elastic MapReduce, is the service offering that lets you scale and run data lake services on demand in the Amazon cloud. EMR is designed to be an alternative to on-premise big data server provisioning and processing using open source products such as Hadoop, Hive, Spark, Flink, Presto, TensorFlow, working with S3 for storage and EC2 instances for computing power. So EMR is a fully managed data lake service that can decouple data storage from compute resources, and instead it can make compute clusters scalable, available to be utilized on demand. It includes the ability for multiple clusters to access the same data sets at once. So this was the definition of AWS EMR. And now let us talk about the benefits or the advantages of AWS EMR. So as you can see here, the first advantage that EMR has to offer us is the reduce the cost of physical infrastructure. As with all cloud-based compute services, EMR removes the need to purchase, maintain, run, and house physical server infrastructure that would be performing big data computational services on-site. You can use the same tools and services that you currently use on-site in the cloud instead, but instead pay per second for the compute cluster resources that you use. So the second point here is it saves system admin time. One of the most important advantages of using EMR is savings in the system administrator's time that would otherwise be spent configuring and provisioning on-site servers for big data computational tasks. It is possible that you may have self-built scripts to aid in this process. For every change that's made or new service that's added, these will need to be tweaked. With EMR handling all these operational details for you, it means you spend less time configuring manual admin tasks. The next point here is the optimum resource utilization. The key to EMR's cost-saving benefits really lies in the fact that storage and compute can be decoupled. This means that you can spin up and scale EC2 instances and clusters when needed. Then release resources once you're done. Inbuilt elasticity with AWS auto-scaling implies that you only pay for what you need. Here you must keep in mind that to get the same performance as in-house processing, your storage will need to be kept locally. And apart from this, if you talk about the other benefits, so EMR includes 24/7 customer support as standard with a subscription, which is far less than other Spark and Hadoop vendors charge, fast spin-up times for instances to run your service, and an EMR that can be run on AWS Virtual Private Cloud for increased corporate data security. The benefits of EMR extend far beyond simply time and cost savings. EMR is useful to deliver real business value by processing big data. So these were the benefits, or you can say the advantages of AWS EMR. And now let us talk about the AWS EMR applications. So the first application here is change the rigid in-house cluster infrastructure. Running the same complete cluster infrastructure anytime you need to analyze big data, no matter what the terms of analysis are, is a waste of resources. Unless you have managed to configure elastic clustering on your machines, EMR is more resource efficient. The second point here is the hassle-free Hadoop management. Currently, businesses rely on on-premise Hadoop for their big data processing needs. With Hadoop fully managed on EMR, this implies that you remove the time and complexity involved with in-house Hadoop management, such as upgrading, maintenance, node failures, operational costs, and so on. And the last point here is the less time for data processing. If running processing in-house is too time consuming, leaving people waiting around for results or other teams waiting to add to the queue, then you have the option to either add new physical hardware to speed up the process, or you can choose a completely scalable EMR solution to complete tasks in a fraction of the time. Switching to EMR reduces the time on average to run the queries by 40% and increasing the number of queries run each day by 33%. So these were some of the applications or the scenarios, or you can even say the usages of AWS EMR. So one of the most common query is like when to use AWS EMR and when to use AWS Redshift. So if you talk about Redshift, that is AWS Redshift, so you must use Redshift when you have a traditional data warehouse. Second point here is when you need the data to be relatively hot for analytics such as the business intelligence. Third, when there is no data engineering team. Fourth point here is when you require joins on your data. And the last point here is when you need a cluster which is to be available 24/7. So these were the circumstances when you should use AWS Redshift. Now, if you talk about the AWS EMR, you should use AWS EMR when you don't need a cluster 24/7. The second point here is when elasticity is more important. Like one of the top priorities of your application is the elasticity. So the third point here is when the cost is important. The next point here is you must use AWS EMR when you have until a few hundred terabytes of data, or even you can say petabytes of data. And finally, you should use AWS EMR when you want to separate compute and storage. So these were the scenarios where you should use AWS EMR. So let's just consider a use case here. So there's this company called Yelp, which was founded in the year 2004 with the main goal of helping people connect with great local businesses. The Yelp community is best known for sharing in-depth reviews and insights on local businesses of every sort. In their 10 years of operations, Yelp went from one city wonder, that is San Francisco, to an international phenomenon spanning across 29 countries with more than 120 markets. Yelp had an average 138 million monthly unique visitors and more than 61 million local reviews that have been written by Yelpers, or the people who use Yelp. So what was the challenge in front of this company called Yelp? So Yelp has established a loyal consumer following due in large part to the fact that they are vigilant in protecting the user from shill or suspect content. Yelp uses an automated review filter to identify suspicious content and minimize exposure to the consumer. The site also features a wide range of other features that help people discover new businesses, such as lists, special offers, and events, and communicate with each other. Additionally, business owners and managers are able to set up free accounts to post special offers, upload photos, and message customers. The company has also been focused on developing mobile apps and was recently voted in the iTunes Apps Hall of Fame. Yelp apps are also available for Android, BlackBerry, Windows 7, and so on. So local search advertising makes up the majority of Yelp's revenue stream. The search ads are colored light orange and clearly labeled sponsored results. Paying advertisers are not allowed to change or reorder their reviews. So how did Yelp made use of AWS, that is Amazon Web Services? So Yelp originally had to depend upon giant RAIDs to store their logs along with their single local instance of Hadoop. When Yelp made the move to Amazon Elastic MapReduce, they replaced the RAIDs with the Amazon S3, that is Simple Storage Service, and immediately transferred all Hadoop jobs to Amazon Elastic MapReduce. Yelp uses Amazon S3 to store daily logs and photos, generating around 1.2 TB of logs per day. The company also uses Amazon EMR to power approximately 20 separate batch scripts, most of those processing the logs. So if you talk about the features of AWS EMR, their jobs are exclusively written in Python, while Yelp uses their own open source library called MRJob to run the Hadoop streaming jobs on Amazon EMR, with Boto to talk to Amazon S3. Yelp also uses S3 CMD and the Ruby Elastic MapReduce utility for monitoring. So Yelp developers advise others working with AWS to use the Boto API as well as MRJob to ensure full utilization of Amazon Elastic MapReduce job flows. Yelp runs approximately 250 Amazon Elastic MapReduce jobs per day, and all this can be done with the help of AWS with other Hadoop application development. So how did Yelp gain out of this application? So using Amazon Elastic MapReduce, Yelp was able to save $55,000 in upfront hardware costs and get up and running in a matter of days and not months. However, most important to Yelp is the main opportunity cost. So these were the benefits that Yelp gained by making use of AWS EMR. So now let's just move on to the next part here, and which is the final part of this session, that is the demo part. So here we are going to create an EMR cluster in AWS. So let me just quickly show you how are we going to do this. For that, you just need to log into your AWS console here. So this is the management console. Once you log in using your credentials, you'll be navigated to this page, AWS management console. So once you go here you have to click on EMR. So EMR can be found in the analytics section here. Okay, as you can see here, just click on that. And this is where you'll be navigated to. Since we have to create a cluster here, so let's just click on the cluster here. Once you do this, you have to name your cluster. So you can name it whatever you want as per your convenience. I'm naming it Arvind cluster, and launch mode is by default cluster. The release is the latest one, EMR. And depending upon your application, you can select this, any one out of this 4. If you have core Hadoop application, select this option. Whereas if you want to run a Spark application, you can select this option. Okay. So as of now, we are selecting this only. And the hardware configuration by default, it's 3, 1 master, 2 core nodes. So after this, you have to select one EC2 key pair. If you don't know how to create an EC2 key pair, you can click on the link here and create it. So now I'm clicking on this create cluster here. So as you can see here, it shows starting. The message is being displayed here, starting. So this might take a few minutes. Okay, so as you can see here, it is still starting. So we just need to refresh this, and this might take a few minutes here. Since our cluster is starting now, and the cluster will be ready once it goes into the waiting state. So before that, we have to create a few things here. So as you can see here, security groups for master. You have to click on this link here, and you'll be navigated to this page here. So once you do that, you have to click on the security group of master here. Okay. After that, you have to click on this inbound tab here. Okay. So once you do this and click on edit. So what you have to do is you have to click on add rule here. And for that, you have to select one option called SSH. And here it says anywhere. You have to select this option anywhere. And you have to just save this. So the same thing can be done for slave as well, but it is totally optional. So once we're done with this, let me just close this. So let me just refresh the EMR console here. And there's this option here to connect to the master node using SSH. So these are the steps that you must follow. This is the procedure to connect to the master node, and you can then write your steps or jobs. You can write your jobs using the command line. So the steps are very simple here. For that, you have to download an application called Putty. So I've already downloaded that. I have to click on this. So once you do this, you have to click on session here. On this session, you have to enter the host field name. Just copy this and paste it here. And once you do this, you have to click on connection here. You have to enable this option here, enable TCP keep lives. Just click on here, and after that, click on SSH here. And once you do this, click on authentication here, and you have to select a private key here. That is Putty private key. So I already have this key here, Edureka key pair. Select this and click on open. So you'll get this alert here, Putty security alert, whatever this is written here. You have to just click on yes here. So as you can see here, this is the command line from where you can write your jobs. So this is how you connect to the master node. As you can see here, previously it was starting and now it is running. So which means the cluster is ready. As you can see here, Arvind cluster, it's running, and the green symbol here. So after this, how do you write jobs for this cluster? So for that, you have to click on steps here. So what you can do is you have to click on add step here. So depending upon the type of application, say for example, if you have to write a pig program, Hive program, streaming program, or any custom jar. So say for example, you have a Hadoop program on Eclipse, you can export it using a jar, and you can select that jar here. So custom jar, whatever the name of the jar, and the location where you have this jar. So you can keep that jar file on the Amazon S3, which is basically used for storage purpose. So similarly, if you have a Hive program like Hive queries, So you can select even that as well. So for Hive, there's a script called Hive script, and which can be stored on S3. As you can see here, you can store it on S3 and script input and output. So basically here what you do is when you go to S3, you have to create 3 separate folders. So one folder will have a script. You have to just copy the location of that over here and the input data and the output. These are the various things that you can perform using a cluster in AWS EMR. So let me just click on cluster here. Okay, so as of now, you can see it is in the running state. Once it is running, you write whatever steps or the jobs that you want. You perform your operations or tasks. And after that, once you're done with this, you have to terminate this. So it's very important to terminate the EMR cluster here, else it will fetch you unnecessary charges. Like cluster is running and you're not doing anything on it. It is simply running. So this will cost you unnecessarily a few dollars maybe. So whenever you're done with using a cluster, you must terminate it. For that, you have to select this cluster here and click on terminate. So it says, are you sure? I'm sure. So once you're done using your cluster, you can just terminate it here. Okay. So here it says terminating user request. What is AWS Glue? AWS Glue is a fully managed ETL, that is extract, transform and load service that makes it simple and cost effective to categorize your data, clean it, enrich it and move it reliably between various data stores. It consists of a central metadata repository known as the AWS Glue Data Catalog, an ETL engine that automatically generates Python or Scala code, and a flexible scheduler that handles dependency resolution, job monitoring, and retries. AWS Glue is serverless, so that there is no infrastructure to set up or manage. So this was a quick definition of AWS Glue. Moving on to the next part, when do you use AWS Glue? The first one is to build a data warehouse to organize, cleanse, validate, and format data. You can transform and move AWS cloud data into your data store. You can also load data from disparate sources into your data warehouse for regular reporting and analysis. By storing it into a data warehouse, you integrate information from different parts of your business and provide a common source of data for decision making. The next situation is when you run serverless queries against your Amazon S3 data lake. S3 here means Simple Storage Service. AWS Glue can catalog your Amazon Simple Storage Service, that is Amazon S3 data, making it available for querying with Amazon Athena and Amazon Redshift Spectrum. With crawlers, your metadata stays in synchronization with the underlying data. Athena and Redshift Spectrum can directly query your Amazon S3 data lake using the AWS Glue Data Catalog. With AWS Glue, you can access and analyze data through one unified interface without loading it into multiple data silos. The next point here is when you want to create event-driven ETL pipelines. You can run your ETL jobs as soon as new data becomes available in Amazon S3 by invoking your AWS Glue ETL jobs from an AWS Lambda function. You can also register this new dataset in the AWS Glue Data Catalog as a part of your ETL jobs. And the fourth point here is to understand your data assets. You can store your data using various AWS services and still maintain a unified view of your data using the AWS Glue Data Catalog. You can view the data catalog to quickly search and discover the datasets that you own and maintain the relevant metadata in one central repository. The data catalog also serves as a drop-in replacement for your external Apache Hive metastores. So these were a few circumstances where you can make use of AWS Glue. Now next we will talk about the various benefits that AWS Glue has to offer us. So as you can see on the screen, these are the various benefits that AWS Glue has to offer us. The first benefit here is less hassle. AWS Glue is integrated across a wide range of AWS services. AWS Glue natively supports data stored in Amazon Aurora and other Amazon RDS engines, Amazon Redshift, and Amazon S3, along with common database engines and databases in your virtual private cloud running on Amazon EC2. The next benefit here is the cost effectiveness. AWS Glue is serverless. There is no infrastructure to provision or manage. AWS Glue handles provisioning, configuration, and scaling of the resources required to run your ETL jobs on a fully managed, scaled-out Apache Spark environment. You pay only for the resources that you use while your jobs are running. And the third benefit here is the increased power. AWS Glue automates much of the effort in building, maintaining, and running ETL jobs. It crawls your data sources, identifies data formats, and suggests schemas and transformations. AWS Glue automatically generates the code to execute your data transformations and loading processes. So these were the few benefits of AWS Glue. Moving on, now we will discuss a few core concepts and terminologies related to AWS Glue. First, let us discuss the architecture of AWS Glue. As you can see on the screen, this is the diagram that represents the architecture. So you define jobs in AWS Glue to accomplish the work that is required to extract, transform, and load data from a data source to a data target. So if you talk about the workflow, the first step here is you define a crawler to populate your AWS data catalog with metadata table definitions. You point your crawler at a data source and the crawler creates table definitions in the data catalog. In addition to table definitions, the data catalog contains other metadata that is required to define ETL jobs. You use this metadata when you define a job to transform your data. In the second step, AWS Glue can generate a script to transform your data. Or you can also provide the script in the AWS Glue console or the API. In the third step, you can run your job on demand, or you can set it up to start when a specified trigger occurs. The trigger can be a time-based schedule or an event. And finally, when your job runs, a script extracts data from your data source, transforms the data, and loads it into your data target. The script runs in an Apache Spark environment in AWS Glue. So this was the overall workflow of AWS Glue, and we will also discuss about this workflow when I'll show you the demo part. So moving on, now we will talk about a few terminologies that are frequently used in AWS Glue. So as you can see on the screen, these are the few terms that are used in AWS Glue. So let us start with the first one, that is the data catalog. So data catalog is nothing but the persistent metadata store in AWS Glue. It contains table definitions, job definitions, and other control information to manage your AWS Glue environment. Each AWS account has one data catalog per region. The next term here is the classifier. A classifier determines the schema of your data. AWS Glue provides classifiers for common file types such as CSV, JSON, XML, Avro, and so on. It also provides classifiers for common relational database management systems using a JDBC connection. You can write your own classifier by using a grok pattern or by specifying a row tag in an XML document. The third term here is the connection. So connection contains the properties that are required to connect to your data store. Moving on, let us talk about the term crawler. A crawler is nothing but a program that connects to a data store. Maybe a source or a target, progresses through a prioritized list of classifiers to determine the schema for your data, and then it creates metadata tables in the data catalog. The next term here is the database. So database is a set of associated data catalog table definitions organized into a logical group in AWS Glue. So the next term here is the data store. A data store is a repository for persistently storing your data. The examples include Amazon S3 buckets and relational databases. So if you talk about the next term, which is a data source is a target data store that is used as an input to process or transform. And the next term here is the data target. So as the name specifies, a data target is a data store that a process or a transform writes to. The next term here is the development endpoint. So development endpoint is an environment that you can use to develop and test your AWS Glue ETL scripts. Moving on to the next term, which is nothing but a job. A job is nothing but a business logic which is required to perform the ETL work. It is composed of a transformation script, data sources, and data targets. Job runs are initiated by triggers that can be scheduled or triggered by events. The next term here is the notebook server. So notebook server is a web-based environment that you can use to run your PySpark statements. PySpark is a Python dialect for ETL programming. You can set up a notebook server on a development endpoint to run PySpark statements with AWS Glue extensions. The next term here is the script. So script contains the code that extracts data from sources, transforms it, and loads it into the targets. AWS Glue generates PySpark or Scala scripts. So the next term here is the table. So table in AWS Glue data catalog consists of the names of columns, data type definitions, partition information, and other metadata about a base dataset. The schema of your data is represented in AWS Glue table definition. And the next term here is the transform. You use the code logic to manipulate your data into a different format using the transform. And the last term here is the trigger. A trigger initiates an ETL job. You can define triggers based on a scheduled time or an event. So these were a few terminologies that you must be aware of that are related to AWS Glue. Now coming to the main part of this session, that is how does AWS Glue works. So guys, as you can see on the screen, these are the steps that we are going to perform in this demo. So let me just quickly show you how are we going to deal with this demo part here. So guys, there's one prerequisite here. You need to have a free tier account of AWS. Let's just sign into the console here. I'll enter my username and password here. So once you do that, you'll be navigated to the home page here. Firstly, we will create one Amazon S3 bucket. So Amazon S3 bucket will consist of our data here. So you can name your bucket whatever you want. So for creating a bucket, you must click on this button here, create bucket. So you can name your bucket whatever you want here. So say for example, Glue demo bucket Edureka. Okay. And just select the region here and click on create. So this will create one Amazon S3 bucket here. As you can see, this bucket has been created here. And in this Glue demo bucket Edureka, we will create two folders. The first one will be read and the second one will be write. So the read folder will consist of our input data and the output will be stored in the write folder. Okay. So for that, let's just click on create folder here. Name of the folder, as you can see here, read, click on save. So as you can see here, this folder has been created here, and quickly create one more folder, write, click on save here. So as you can see, we have created two folders here, read and write. And let me just click on read here, and here we have to upload one data file here. So in our case, the data file is a CSV file. Let me just show you the data here. So as you can see here, this is a very small file just consisting of few rows, and the source for this data is the IMDb website. So as you can see here, there are only 10 rows in which the first column is the rank of the movie, movie title, year of release, and the rating for that movie. Just for the demo purpose, I've purposely taken small data set. And what we are going to do is we will perform an ETL operation on this data set. I'll talk about the ETL operation in the later part of this session. So this was the data set here, and we just have to upload this on the, so this was the data set here, and we have to upload it on the Amazon S3 bucket here. Okay, so for that, click on upload here, click on add files, just navigate to the folder, click here. So once you do that, click on upload. So as you can see here, this file has been uploaded here. Now let us move to the next step and click on AWS Glue here. So now, as per our steps here, we will create a crawler here. So as you can see, AWS has provided a definition of crawler. A crawler connects to a data store. In our case, it is an Amazon S3 bucket here, and in that we have a CSV file. Progresses through a prioritized list of classifiers to determine the schema for your data, and then creates metadata tables in your data catalog. So this was the definition of crawler, and we have already discussed this in our previous slides. And let's just quickly create a crawler here. Click on add crawler. You can name the crawler whatever you want. So say for example, Glue demo crawler. Click on next here. For crawler data source type, click on data stores, click on next here, and we just have to navigate to the read folder here. Okay, here it says choose S3 path, and we just have to select this folder that we created in the previous step. Okay, read folder, and it has our movie data CSV file. Click on select here, click on next, add another data store. As of now it is not needed, so click on no and click on next. So here it says choose an IAM role. So for that you can create a new role if you want. So as you can see here, to create a new IAM role, you must have create role, create policy, and attach role policy permissions here. So since I've already created one role here, and I'll choose the existing role. So this was the role that I created. After that, click on next here. And the frequency here is run on demand, hourly, daily. You can also choose the days if you want any specific day, weekly or monthly. As of now, we will click here on run on demand and click on next. So here it says configure the crawler's output. For that, we need a database here. Okay, so we can just create a new database here. So say for example, you can name it whatever you want as per your convenience. Glue demo DB. Okay, click on create here, click on next. Quickly review the information if you want. Just check if all the details are correct and click on finish here. So here you can see crawler was created to run on demand. Run it now. Yes, you can click on run it now and it will run the crawler now. So as you can see here, the status of the crawler, it is starting. And once a crawler has run successfully, you will see a table has been created, metadata table. So the crawler was successful. And now let us just click on databases here. So as you can see here, this was the database that we created. And in this database, if you click on tables here, you will see a table has been generated by the name read. This means that crawler was successful. So the next step here is to create a job here. Okay, so for that, in this ETL section, click on jobs. And what is the job? So as discussed earlier, a job is your business logic that is required to perform ETL operation. For that, click on add job here. Again, the name of the job as per your convenience. So let me just name it Glue Demo Job. Can choose the IAM role here. By default, the type is Spark here and the Glue version. So as you can see here in this section, this job runs a proposed script generated by AWS Glue. So AWS Glue can generate a script for you. Also, you can have your own script in which you have your logic of ETL operation. Let's just click on this option here, a proposed script generated by AWS Glue. Now you have to click on this security configuration. And in this section, you have to enter the maximum capacity as 2, which is the minimum, and job timeout as 10 minutes. Okay. So once you do that, click on next here. Choose a data source. Click on this read table here. Click on next. Choose a transform type. By default, it is change schema. Click on next here. Choose a data target, read in our case. So as you can see here, in this section, map the source columns to the target columns. By default, this has been mapped here. You can change the mapping if you want. You can add a new column as per your requirements. So as of now, in our example, we don't have to change anything. Click on save job and edit script. So as you can see here, AWS has generated a script for us. But if you want your own script here, you can also do that. So say for example, I have this script here, as you can see. I'll just show you what I have written in this script. So this script basically contains the ETL operation here. So what are we going to do? As I showed you the data set that we have. For that data set, we will have a transform operation in which the first column will be the decade, and the second column would be the count of the movies in that particular decade, and the third column would be the average rating for the movies in that decade. So this is the operation that we are going to perform, and this is the script written for that purpose. In the script, you just have to specify the parameters here, the Glue database name, the Glue table name, the read here, and the S3 write path. These parameters will be as per your naming that you did in the previous steps. And here you have to specify the right folder of Amazon S3 bucket. As you can see here, S3, the bucket name and the right folder. So let me just quickly copy this. Let me just paste it here. So looks good. So click on Save here and click on Run Job. So as you can see here, the job is running as of now. So guys, as you can see here, our job has been successfully executed. And now let us just quickly go through the right folder in Amazon S3 bucket and let's just check if something has been generated here. Yes, as you can see here, this file has been generated here. And if you click on open here, this file gets downloaded on your system. So let me just open this file here. So guys, as you can see here, this is the output that has been generated as per our ETL script. As you can see here, the first column is the decade, movie count, and rating mean. So this also is a CSV file here. I mean, the format is in CSV format. So say for example, the 1990 year or this decade had 4 movies and the average rating of those movies was 8.95. This was the output that has been generated.
Why exactly we needed Apache Hive? It all began in the early 90s when Facebook started. Slowly, the number of users at Facebook increased, that is, nearly 1 billion users, and along with the users increased the data, which is nearly equals to thousands of terabytes of data and nearly 1 lakh queries, then also 500 million photographs uploaded daily. And this was a huge amount of data that Facebook had to process. And the first thing that everybody had in their mind was to use RDBMS. And we all know that RDBMS couldn't handle such a huge amount of data. And neither it was capable enough to process it. And the very next big guy who was capable enough to handle all this big data was Hadoop. Even when Hadoop came into picture, it was not too easy to manage all the queries. It used to take a lot of time to execute all the queries performed. So one common thing that all the Hadoop developers had was the SQL. So they thought to come up with a new solution that has Hadoop's capacity and interface like SQL. That is when Hive came into picture. So now we understand the exact definition of Apache Hive. Apache Hive is a data warehouse software project built on top of Apache Hadoop for providing data query and data analysis. Hive gives a SQL-like interface to query data stored in various databases and file systems that integrate with Hadoop. Also, Apache Hive has data warehousing software utility. It can be used for data analytics. It is built for SQL users, manages querying of structured data, and it simplifies and abstracts the load that is on Hadoop. And lastly, no need to learn Java and Hadoop API to handle data using Hive. So followed by this, we shall understand Apache Hive applications. Apache Hive is used in many major applications. Few of the major applications are as follows. Hive is a data warehousing infrastructure for Hadoop. The primary responsibility of Hive is to provide data summarization, query, and data analysis. It supports analysis of large datasets in Hadoop's HDFS as well as on Amazon S3 file system. Followed by that, we have document indexing with Hive. The goal of Hive indexing is to improve the speed of query lookup on certain columns of a table. Without an index, queries could load an entire table or partition a whole process as rows. This would be troublesome. So, with Hive, we have solved this problem. Followed by that, predictive modeling. The data manager allows you to prepare your data so it can be processed in automated analytics. It offers a variety of preparation functionalities, including the creation of analytical records and timestamp populations. Followed by that, the next important application of Hive is business intelligence. Hive is a data warehousing component of Hadoop, and it functions well with structured data, enabling ad hoc queries against large transactional datasets. Hence, it happens to be a best-in-class tool available for business intelligence and helps many companies to predict their business requirements with high accuracy. Last but not the least, log processing. Apache Hive is a data warehouse infrastructure built on top of Hadoop. It allows processing of data with SQL-like queries and is very pluggable so that we can configure it to provide our logs quite easily. So these were the few important Hive applications. Now let us move ahead and understand Apache Hive features. The first and the foremost important feature of Apache Hive is SQL type queries. The SQL type queries present on Hive will help many of the Hadoop developers to write queries with ease. Followed by that, the next important feature of Apache Hive is OLAP based design. OLAP is nothing but online analytical processing. This allows users to analyze database information from multiple database systems at one time. So using Apache Hive, we can achieve OLAP with higher accuracy. Followed by the second feature, we have the third feature which says Apache Hive is really fast. Since we have SQL-like interface in Apache Hive, using this feature on HDFS will help us writing queries faster and executing them. Followed by that, we believe Apache Hive is highly scalable. Hive tables are defined directly in Hadoop file system. Hence, Hive is fast and scalable and easy to learn. Followed by that, it is known to be highly extensible. Apache Hive uses Hadoop file system, and Hadoop file systems or HDFS provides horizontal extensibility. And finally, the ad hoc querying. Using Hive, we can execute ad hoc querying to analyze and predict data. So these were the few important features of Apache Hive. Let us move on to our next topic, where we deal with Apache Hive architecture. The following architecture explains the flow of submission of query into Hive. The first stage is the Hive client. Hive allows writing applications in various languages including Java, Python, and C++. It supports different types of clients such as Thrift Server, JDBC Driver, and ODBC Driver. So what exactly is Thrift Server? It is a cross-language service provider platform that serves the requests from all these programming languages that supports Thrift. Followed by that, JDBC Driver. It is used to establish connection between Hive and Java applications. The JDBC driver is present in the class org.apache.hadoop.hive.jdbc.hive driver. Finally, we come to ODBC driver. So what exactly is ODBC driver? ODBC driver allows the applications that support ODBC protocol to connect to Hive. Followed by that, we have the Hive services. The following are the services provided by Hive. They are Hive CLI, Hive Web User Interface, Hive Metastore, Hive Server, Hive Driver, Hive Compiler, and lastly, the Hive Execution Engine. The Hive CLI or Command Line Interface is a shell where we can execute the Hive queries and commands. Followed by that, the Hive Web UI is just an alternative for Hive CLI. It provides a web-based graphical user interface for executing Hive queries and commands. Followed by that, the Hive Metastore. It is a central repository that stores all the structured information of various tables and partitions in the warehouse. It also includes metadata of column and its type information, the serializers and deserializers, which is used to read and write data, and the corresponding HDFS files where the data is stored. Followed by that, the Hive Server. It is referred to as Apache Thrift Server. It accepts the requests from different clients and provides to the Hive driver. Moving on, we shall deal with Hive driver. The Hive driver receives queries from different sources such as Web UI, CLI, Thrift, and JDBC or ODBC drivers. It transfers the queries to the compiler. Followed by that, we have the Hive compiler. The purpose of Hive compiler is to parse the query and perform semantic analysis on the different query blocks and expressions. It converts HiveQL statements into MapReduce jobs. Finally, we have Hive Execution Engine. Hive Execution Engine is the optimizer that generates the logical plan in the form of DAG or directed acyclic graph of MapReduce tasks and HDFS tasks. In the end, the execution engine executes the incoming task in the order of their dependencies. Followed by that, we have the MapReduce and HDFS. MapReduce is the processing layer which executes the mapping and reducing jobs on the data provided. Lastly, the HDFS or Hadoop Distributed File System is the location where the data which we provide is stored. So this is the architecture of Apache Hive. Then moving next, we have Apache Hive components. So what are the different components which are present in Hive? They are, first one, the shell. Shell is the place where we write our queries and execute them. Followed by that, we have Metastore. As discussed in the architecture, The metastore is a place where all the details related to our tables is stored, like schema, etc. Followed by that, we have the execution engine. So execution engine is the component of Apache Hive, which converts the query or the code which we have written into the language which the Hive can understand. Followed by that, driver is the component which executes the code or query in the form of acyclic graphs. And lastly, the compiler. Compiler compiles whatever the code we write and executes and provides us the output. So these are the major Hive components. Moving ahead, we shall understand Apache Hive installation on Windows operating system. So Edureka is all about providing the technical knowledge in the simplest way as possible, and later play around with the technologies to understand the complicated parts of it. So now let's try to install Hive into our local system in the most simplest way as possible. To do so, we might need the Oracle VirtualBox, which looks like this. So once after you download Oracle VirtualBox and install it into your local system, the next step would be to download the Cloudera Quick Start VM for your local system. The link to this will be provided in the description box below. Now let's quickly start our Cloudera Quick Start VM with our Oracle VirtualBox. Select Import option and now provide the location where your Cloudera Quick Start VM is existing. In my local system, it is in the local disk drive F. There you go. Select Open and now just make sure your RAM size is more than 8 GB. Just randomly I'm providing 9000 MB, which is just above 8 GB, so that you have a smooth functionality of Cloudera. Now select Import and there you go. You can see that Cloudera Quick Start VM is getting imported. Now you can see that Cloudera Quick Start VM has been successfully imported and it's ready for deployment. You can just double click on it and it'll get started. You can see that Cloudera VM has been successfully imported and it started. And also you can see that we have gone live on Cloudera. You can see all the Hue, Hadoop, HBase, Impala, Spark, which are pre-installed in Cloudera. Now our concern would be to start up Hive. So to start Hive, you need to start up Hue first. So let me remind you one thing. In Cloudera, every single password and username is Cloudera by default. So for example, we have got Hue username and password here. So the username, that is the default username for Cloudera's Hue, would be Cloudera. And along with that, even the password will be Cloudera. That is by default. So we have got Cloudera and Cloudera as username and password respectively. Let's just sign in. You may select remember option in case if you forget your passwords. So now we are getting connected to Hue and we are live on Hue now. There you go. We've got started our Hue. So now we'll enter into HDFS. There we go. We have our Hive here. Now that we have successfully installed Hive into our local system, let us move further and understand a few more concepts in Hadoop. Firstly, we shall deal with the data types. The data types are completely similar to any other programming language which we have. They are tiny int, small int, integer, big int. Similarly, followed by that we have float. And inside Hive, float is used for single precision. And if you want double precision, you can go ahead with double. And followed by that we have a string and boolean, which are completely similar to any other programming languages which we use in this daily life. Followed by that we have Hive data models. So these are the basic data models which we use in Hive, that we basically create databases and store our data in the form of tables. And sometimes we also need partitions. We will discuss each one of these data models in our demo ahead. So we'll first create databases, and inside databases we will be creating tables inside which we will be storing data in the form of rows and columns. And along with that, partitions. Partitions, they are like advanced way of storing data. Like if you have, just imagine you're in a school, say standard 1, and inside standard 1 you have sections A, B, C, D. So partition is like you're getting partitions for section A, section B, section C, and section D. You're storing different students in different sections, so that when you're querying for a particular data, For example, say you're searching for a kid called Sam and you have the section of his class as B. So you just don't have to just search for Sam in all the 4 sections. You can just directly go into section B and call in Sam and you'll get access to him. That's how partitions work. Followed by partitions, we have buckets. So similar to partitions, even buckets work in the same way. Let's understand each one of these in much better way through a practical demo. After data models, we shall understand about Hive operators. So what are operators? Operators are any other operators that we use in normal programming languages such as arithmetic operators, logical operators. We shall also go through some examples based on arithmetic and logical operators in Hive in the Hive demo. We will use some arithmetic operations as well as logical operations on the data which we have stored in the form of tables in Hive. We shall go through a brief look on that as well. So before we get started, let's have a brief look on the CSV files that I have created for today's demo. These are the small CSV files that I've personally created using MS Excel, and I've saved them as .csv files. I've made the CSV files to be smaller because just to make sure the execution time consumed is as less as possible. Since we're using Cloudera, the execution time might be a little more. So it's better if we use smaller CSV files. So this is my first CSV file, which is employee.csv, which has employee IDs, employee name, salary, and age. Similarly, we have another employee2.csv file, which has the same details along with one more column, that is the country column. I've included country because we will be using this country column in joins that we will be performing in future. Followed by that, we have the department. So here we have department ID and department name. So we have development, department, testing, product, relationship, admin, and IT support. Similarly, we also have student CSV. This is another CSV file that I have created. This has ID, name, course, and age of the student. Followed by that, we have another CSV. This is student report.csv, which has the reports of a particular student, gender, ethnicity, parental education, lunch, course, math score, reading score, writing score, and other. So these are the CSV files that we will be using in our demo today. So now let's quickly begin with our demo. So to start Hive, we shall open a terminal. So starting or firing up Hive in Cloudera is really simple. You just have to type in Hive and enter. There you go. Logging initialized using configuration files and etc. The Hive CLI is deprecated and migration to Beeline is recommended. And there you go. Your Hive terminal or CLI has been started. So first, let's try to create a database. To save time, I've already created the document which has all the codes that we will be executing today. So this is the particular file which I will be using today. So don't worry, this file will be linked in the description box below. You can use the same file and try executing the same codes in your personal systems just for practice if you feel so. So just to save time, I've already created the document which has the codes that we are going to execute today. So this code or this file will be attached in the description box below. You can get access to it and you can also execute the same codes in your own personal system to have a practical experience about this particular Hive tutorial. So the first thing that we will be doing today is to create a database. So I'm going to create the database using SQL type commands, which are create database, name of the database, which is Edureka. There you go. The database has been successfully created. So now you can also use the following command to check if your database has been created or not. So show databases will help you to find it. So there you go. You can see the first database, which is a default database, which will be pre-existing. And followed by that, you have our own database, which we have created now, that is Edureka. So followed by this, next we will move ahead and try to create a new table. So when you come into tables, you need to understand there are 2 types of tables in Hive. They are managed tables or internal tables, followed by that external tables. So what is the difference between these 2 tables? So internal table or managed table is the default table that will be created whenever you try to create a table in Hive. So for example, if you're trying to create a new table, say Edureka, then Hive considers that particular table as an internal table by default. So when you create an internal table, your data is not secured. Understand this. So when you create an internal table, your data is not secured. In case, just imagine you are working with a team and all your team members have access to your Hive or Hue. So the table has been existing in your Hive, and some random newbie or some random inexperienced guy tries to change few things in your table and accidentally he ends up deleting the table. So when you delete the table, then if the table was created using an internal table code, then your data will be erased. So that's the disadvantage of using internal tables. But in case if you create an external table, even if somebody tries to delete your table, the table or the data, whatever is there, will be deleted from their own local system, but not from Hive. So that's the best part of using external tables. Don't worry, we will discuss about internal tables and external tables as well. So first we'll try to create an internal table. So this particular code is based on internal tables. So we are using SQL type command here, which is create table, and the table name is employee. And the columns inside our table are ID of the employee, name of the employee, salary, and age. So row format has been delimited, followed by that. Since this is a CSV file, so the fields will be terminated by comma. And don't forget, you have to use semicolon. Unless you use semicolon, your code is not complete. So let's fire and enter and see if the table gets created or not. Yeah, the table is created successfully. Now we shall see the table, or let's describe the table. So describing the table means you can see what are the columns which are present in your table. So to describe a table, you can use the keyword describe and name of the table, which is employee. And don't forget semicolon. There you go. So your table has the columns ID, name, salary, age. So those are the 4 columns which you have included in your particular table employee. Now let's move ahead and see if this particular table is an internal table or managed table, or the other type of table, which is the external table. So to do that, we can just write in describe formatted table name and semicolon. There might be a small issue here. Yeah, there is a typing mistake. That is describe. I missed S. So there you go. We got it. So this particular table is managed table, as you can see here. Now let's move ahead and try out external tables. Let's clear our screen first. You can use Ctrl+L to clear your screen. There you go. We have a clear screen now. Now let's try to create an external table. Creating an external table is completely similar to that of internal table, but the only difference is that you need to add in a keyword which is external. So this particular keyword is used to create an external table. Now let's fire and enter and see if the table gets created or not. You can see the table got created. Now let's try to describe the table, employee 2. Don't forget the semicolon. I'm saying this again and again because most of the times we miss semicolon and we will get an error. So you can see the table got described and we have the following columns inside our table. Now let's move ahead and see if this particular table is an external table or a managed table. To do so, you can type in describe formatted, the same code what we have used earlier, that is describe formatted, name of the table, that is employee 2. Semicolon, don't forget. There is some issue again. I think I've missed something, or maybe a typing error. Yeah, this is a typing error. Yeah, there you go. The table type is external table. So that's how we create an internal table or managed table and external table. So now that we have understood how to create a database and table and the 2 types of tables, that are internal table or managed table, followed by that the second type of table, that is the external table. Now let's try to create an external table in a particular location. So for that, you can use the following code, but the only difference is you are specifying the location, that is user Cloudera Edureka employee. EDUEMP is a file that we will be creating in our Hive. So let's fire and enter and see it if it's created or not. Yeah, it's successfully created. Let's go back to Hue and see if the following table is created or not. So one thing you have to remember is when you fire in a command, or if you try to create a table, the first folder that will be created is a warehouse. So inside Hive, you have your warehouse, and inside warehouse, you have all the databases that we have created. Our first database was the Edureka database, and after that we have created table which is employee, and the second table is employee 2. So this is in the particular location which is user Cloudera, and the file is employee 2. Let's see that. This was the file. Yeah, sometimes Hue will not show it because of network issues. You don't have to worry about it. You will get back that data. Now, followed by this, let us enter into 𝐬 again. So when you come back into 𝐬, if you have to upload a file into 𝐬, you can just select this particular option, which is plus. So selecting this will give you a dialog box, which will be something like this. And here you can just select any of the files which you want to upload into 𝐬. Now let me select a student report.csv and select open. So there you go, upload is in progress. So the data file has been successfully uploaded. Now, if you want to access your data file, you can just click on that. So there you go, you have all your data successfully loaded onto 𝐬. You can also perform queries on this particular data. You can just select query, and inside that you just need to select editor, and you have various editors over here, which is Pig, Impala, Java, Spark, MapReduce, Shell, Sqoop, and we also have Hive in here. So if you just select Hive, and there you go, you have the editor here. You can just type in your commands or queries, whatever you have. So you have many dictionaries as well. You can just select any one of those, select, and that's how you write queries on the Hive terminal. Now let's not waste much time here, and we have a lot to learn. So let's continue with the next topics in our today's session. Now we shall try to edit the tables. Now we have created the new table, that is employee 3, and we have named the columns as ID, name, string, salary, age, and float. Now we shall try to make some alterations to our table. So the first alteration that we will try to make to our table is to rename our table as EMP table. You know that our employee table was named as employee 3. Now we are trying to rename it to EMP table. So we are using the keyword alter here. So just fire an enter and see if this is possible or not. Yeah, it is possible. The name has been changed to EMP table. Now let's try if it's completely changed or clearly changed or not. You can just type in describe EMP table semicolon. If we get the same column names in our description, then it should be changed. So there you go. We can see the same columns here. So we have successfully changed the name to EMP table. Now we shall also try to add in some more columns to our table, which is EMP table. So here we'll try to add in a new column, that is the surname of string data type. So I'm doing that by using the keyword alter, followed by that table. The table name is EMP table, and I'm using the keyword add columns, and the column name is surname, and the data type of that column is string. So now let's fire and enter. And there you go, we have successfully added a new row to our table. Now let's try to describe our table again and see if the column has been successfully added or not. There you go. You can see the last row, which is the surname that we have added most recently. So this is how you can alter the table, and you can also change the names of the existing columns. Let's try to do that one as well. Now what I'm doing is I'm changing the column name to first name. So one of the column name in my table EMP table is the name, which gives me the names of the employees. So since I added surname, I'll change this column name from name to first name. So this is the command that I'm using for that operation right now. Let's fire and enter and see the result. Yeah, the change has been made. Let's describe our table. Don't forget the semicolon. There you go. You can see that earlier we had name. Now it's been changed to first name, and we also have a surname. Let's clear our screen. So that's all for alterations. Now we shall move ahead into our next major topic, or the data model, which is partitioning. So we have dealt with the first two data models, that are databases and tables. So we have learned how to create a database, and we have learned how to create a table. We have learned how to create internal or managed table, and also we have created external table, and also we have learned how to create an external table in a particular location in your Hive and load data to your table, and also how to alterate your tables, the column names, the name of your table, and how to add or delete new columns to your table. So far so good, and now we shall continue with the next type of data model, that is the partitioning. As we have discussed earlier about partitioning, it's completely similar to a school or a college. Just imagine that you are in a college and you are in computer science section. So a college has many branches. So maybe computer science, mechanical, and electronics and communications. So imagine your name is Harry. So if someone comes to your college and if he's looking for Harry, so there are many Harrys in your school. So if the person is asking specifically about you, that is Harry from computer science, then can you imagine how simple is this query? So you don't have to search for electronics and mechanical. You just have to come into the class computer science and search for Harry, and there you go, you're present. So that's how partitions work. To execute commands or to execute queries on partition, we will create a whole new database here. Let's start everything from fresh. So we'll create a separate database for executing our new data model, that is partitioning. So I'm creating a new database, that is Edureka student. So there you go, the database has been successfully created. Followed by that, let's use this database now. To use the database, you just need to add in the keyword use and name of the database. So let's fire and enter, and now we are currently using Edureka student database. Now let's create a table in Edureka student database. So here I'm creating a normal table, that is the managed table. So inside my student table, I'll be having some basic columns such as ID number of the student, name of the student, what is his age, and course. So you're not finding course here because I'm going to partition the table based on course. So here you can find the course. I'm using the keyword partition, and on what terms? So on the terms of course, I'm going to partition students. So we have discussed about our students CSV file, right? So here we have our CSV file, and the courses that this particular institute is offering are Hadoop, Java, Python, and yeah, so these are the courses that this particular institute is offering. So I'm going to categorize, or I'm going to partition these students based on their courses. So this is how I'll be partitioning them using this following code. So basically the table has all the columns, and I'm going to partition the table using course. So let's fire and enter and see the execution of this particular code. The partition has been done. Now all we have to do is try to load in our data. Before that, let's try to describe it. Let's try to see what are the columns present in our particular table student. So as you can see, the course column is present. Don't worry. The code looks that we have messed out course, but we did not mess the course column. It is present in the table. The only thing is that we have just partitioned it based on the course that we are going to offer. Now let's try to categorize the students based on their course. So you can do that by using the following code. We are going to load the data using the command load data local in path. So this particular folder, that is the student.csv, is in my local location. So that is home, Cloudera, desktop, student.csv. And I'm loading the data present in this particular location into the student, which is present in Hive right now. So I'm going to partition the student based on their course Hadoop. Now let's fire in this command and see the output. Yeah, now you can see some map reduce jobs taking place. Yeah, the data has been successfully loaded. Let's now refresh our Hive. You can refresh your Hive or Hue based on two methods. The first one is just clicking refresh button on the URL, or you can also select a manual refresh. This is the manual refresh, and there you go, it's done. You can see the new database, that is the Edureka student database that we have right now created. And inside that you can see the student table that we have created, and there you go, we have the file of students based on course Hadoop. Now we will try to add in few more students based on the course Java. For that, all you need to do is just replace the course name with Java. There you go. Here we had Hadoop course, and now here we have Java course. Just fire and enter and you can see the output. Followed by that, we also had another course, that is Python. So let's also execute a code for that. There you go, Python. So now we have uploaded student details into our Hive, and we have also partitioned using one of our data models, that is partition, into three categories that are based on Hadoop, Java, and Python. Now let's go back to our Hue and see if the three categories are done or not. Yeah, we need to refresh that. There you go, you have successfully refreshed. Still, there is no sign of Java and Python. Maybe a manual refresh could help. Yeah, the manual refresh has resulted in the two new files, which are Java and Python. So you have all the three partitions here, Hadoop, Java, and Python. Just enter them and you can see the student details. And now that we have understood partitioning, sorry, I forgot to mention, we have two types of partitioning, which are dynamic partitioning and static partitioning. So the static partitioning is in static or manual partitioning. It is required to pass the values of partition columns manually while loading the data into the table. Hence, the data file does not contain partition columns. You can see that we have sent the partition columns manually for Python, Java, and Hadoop. But when it comes to dynamic partitioning, you just need to do it once, and all the three files will be automatically configured and the files will be created. So now what is dynamic partitioning? So dynamic partitioning, the values of partition columns exist within the table. So it is not required to pass the values of partition columns manually. Now what is this? Don't worry, we shall execute the code based on dynamic partitioning and we shall understand this in a much better way. Now let's clear our screen. Now let's start fresh again. Let's try to create a new database for dynamic partitioning and let's start again fresh. So here we'll be creating a new database that is Edureka student 2. So earlier we created Edureka student and now we'll be testing our dynamic partitioning on our new database that is Edureka student 2. So there you go, the database has been successfully created. Now we shall use this particular database. Currently we were in Edureka student 1 database. Now we'll enter into student 2 database. So we'll use it now. Now we are in Edureka student 2. Now before we start up with dynamic partitioning, we have to set Hive execution to dynamic partition is equals to true. Because by default, the partitions that will be taking place in Hive will be static. So we need to convert that into dynamic partition by specifying this particular code. Now we are good to go with dynamic partitioning. Along with that, we need to execute another command which says partition mode would be non-strict. So by default, when you are partitioning using the static partition, the partition mode will be strict. So now you're specifying it to be non-strict. Now let's execute this. So there you go. We have executed the two required codes for that. Now let's create a new table. So the name of the table will be Edureka student, that is EDUSTUD, and this will have the same columns, which are the ID of the student, name of the student, course, age, etc. Now we will try to load in the data from our local path, that is home, cloud, or our desktop, student.csv into the table EDUSTUD. So the data has been successfully loaded and the size is 267 KB. Number of files is 1. Now comes the tough part. So here we are going to partition. So we will be partitioning the table based on the same thing, which is the course, and we will be separating the data using the comma. Now let's fire an enter. Now the table has been separated based on course, and now we will be loading the data to this particular table, which is the student part. So this particular table that we have created based on dynamic partitioning, and we are going to partition the data based on course. Now it's been created. So the student part table has been successfully created. Now the only part remaining is to load the data to this particular table. Now we will be writing a code. So using that code, the MapReduce will automatically segregate the data members or the students based on their courses. So the guys which are in Hadoop will be separated. Guys in Java will be separated and loaded into different file, and similarly with Python. Now let's see how to do it using the code. So there you go. We are going to insert into student part, partition based on course, select ID, name, course, age from the table Edureka. So the data will be imported from the table what we have created here, that is Edureka student. So this particular location has the student.csv file. Now let's fire an enter and see if it's created or not. Fine. You can see some of the MapReduce jobs are getting executed. You can see we have 3 jobs. So first one is getting executed. We have 3 because one is for Hadoop, one is for Java, and one for Python. So this will take a little time. So this is the reason why I have chosen smaller CSV files, so to save time. When you take up the course from Edureka, then you can work on real-time data so that you get hands-on experience from real-time, and you can get yourself placed in some good companies with the experience what you gain from this particular course. So the stages are been successfully finished and the data has been loaded. Now let's see what are the data present in the particular table, student part. There you go. You have the output executed here. So these are the data members present in the partition student part. So these are the data members which are separated based on their courses. That is the partition based on their courses, that is Hadoop, Java, and Python. So now that we have understood dynamic partitioning and static partitioning, we shall move ahead into the last type of data model, which is bucketing. Once after we finish the bucketing, we shall enter into some query functionalities of Hive or query operations which can be performed in Hive. And followed by that, we will also learn some functions which are present in Hive and some of the other things like group by, order by, sort by. And finally, we shall wind up the session with joins which are available in Hive. For now, let's get continued with bucketing, the last type of data model present in Hive. So for that, let's again start fresh. We shall create a new database for that. Before that, let's go back to Hue and check if our partition has been made or not. Let's refresh. Also, let us make a manual refresh. So our database was Edureka student 2 database. And inside that, we have the table that is student part. And there you go. You can see the files which are based on the partition. So 22 is for a different course, 23 is for a different course, and 24 is for a different course. And this is the default partition which has all the data members. As we discussed earlier, now let's start with the last data model in Hive, that is bucket. Now we have created a new database that is Edureka bucket. Now we shall also create a new table for that. Before that, we need to start with this particular database, so we can use the command use Edureka bucket. Now we are in Edureka bucket. Now let's create a new table. So the table name will be Edureka bucket, and it will be containing the ID name, salary, age of the employees. The table is created. Now let's try to load the data. So the data file that we will be using is the same one, that is the employee.csv. So the data has been successfully loaded into the location. Now comes to the major part, that is the bucketing part. So to start bucketing in Hive, we need to use the command set hive.info.bucketing is equals to true. So that's done. Now we will cluster or classify the data present in this particular file using this particular code. So we will be clustering based on the ID, and we will be categorizing them into 3 different buckets. So let's fire in this command and see if it happens. Yeah, that's successfully done. Now we will override the data using the following command. Now we'll be inserting data into this buckets that we have made, that is 3 buckets, and we will override the table using this particular code. There you go. You can see some MapReduce jobs to be taken care of now. So 1 mapper and reducers are 3 for now. So stage 1 is getting done. So we should be having 3 tasks basically. So let's see what's the output. Stage 1 is finished. The process is finished and data has been successfully inserted. Now let's go back to Hive and check if it's done or not. So before that, let's do a refresh. Now a manual refresh would be much better. There you go. We have our database here, which is Edureka bucket. And inside Edureka bucket, we have EMP bucket, and that's our data, employee.csv. There you go. Now let's move ahead and understand the basic operations we can perform in Hive. So for that, let's start fresh again. Let's create a new database. I'm creating a new database for each and every option or each and every operation that I'm performing in this particular tutorial, just to make things or keep things in a sorted manner. So as you can see here in our particular file system, I have separated each and everything, like I have sorted everything. So for bucketing, I've got a separate database, and for partitioning, I've got a separate database, and for understanding how to create database and tables, I've got a separate database for that, just to keep things arranged and sorted. This looks in a much better way. So now let's discuss about the operations that we could perform in Hive. So I'm creating a new database again for this. So the database would be Hive query language. Now let's use this particular database. This creates a habit of learning things in a better way, or it's like a revision for the things what you have performed or learned so far. As you can see, the table has been successfully created. Now let's try to add in some data into this particular location. That is employee data. It's been successfully loaded. Now let's try to see what are the details present in this particular file. We can use in the command select star from the table Edureka employee. So there you go. These are the details or information present in the table Edureka employee. Now we shall see what are the functions that we can perform on this particular file. So since we discussed that the mathematical operations and logical operations can be performed on Hive, so let's try to perform an addition operation. So I'm selecting the column salary, and as we have seen here, the salaries are 25, 30, 40, 20,000 rupees for every employee. Now let me add in 5,000 more to each and every employee. So I'm adding the value 5,000 by using the addition operation. So let's enter. You can see we have added 5,000. So the first element was 25. Now it's 30. So similarly, all the other employees got 5,000 rupees hike all of a sudden. Now let's try to remove 1,000. So to do so, all you need to do is replace the addition operation with a subtraction operation, that is minus. Fire and enter, and there you go. Each and every employee lost 1,000. So the initial amount was 25,000. So removing 1,000 from that will result in 24. So this is considering the first initial values. So this is how it's working. Followed by that, let's also perform some logical operations. Let's clear the screen, and yeah, here I'm fetching for the employees who are having a salary equal to or greater than 25,000. So these are the employees which are having the salaries above or equal to 25,000. Similarly, let's execute another one which detects the employees with salaries less than 25,000. So we have got two employees which are having lower salaries, which are Amit and Chaitanya. Fine. So this is how you perform some operations in Hive. So now let's move ahead and understand the functions which you can perform on Hive. So in the same way, let's create a new database again, and let's use this particular database, that is Hive functions. Now let's create a table in this particular database. So the table is employee function, and it's created. Now let's try to load in the data. Yeah, the data has been successfully loaded. And now let's see if the data is correctly loaded or not. Yeah, the data is loaded correctly. Now let's try to apply some functions in this particular data. So the first thing, or the first function I'm going to apply, would be a square root function, where I'll be finding out square root of the salaries of the employees. So there you go. The square root of 25,000 was 158 dot decimal numbers. So this is how you perform some basic functions on your data. Now let's try to find out the maximum salary. So yeah, the job is getting executed. You can see some MapReduce jobs here. I think the biggest salary would be from Sanjana. So the maximum salary is 40,000. So this is how it works. Since we are working on Cloudera and the system configuration is limited, the execution speed is a bit low. But if you're working in real time, then this process would take like a few seconds and it's done. There you go. You have the value 40,000 as shown here. So 40,000, the employee name is Sanjana, is the maximum salary. So that's what we got here. Now let's try to find out the minimum salary. So the minimum salary is 15,000, and who would that be? Yeah, it's Chaitanya with minimum salary 15,000. So that's how you do some operations in Hive. Let's execute some more operations, such as converting the names of the employees to uppercase. So you can see the employee names are converted to uppercase here, and similarly let's try to convert to lowercase. So here you can see we have converted them to lowercase. So this is how you learn technology. You need to play with the technology. Then you'll come to know the advantages and disadvantages. So you can learn the possible ways where you can make things work out. This is how you do it. Now let's move ahead and understand group by function in Hive. So for that, we'll be creating a separate database that is group. Now we will use this particular database that is group. So we'll type in command use group semicolon. Now we'll create a table. So the table has been successfully created. Now we will load data into this particular table. Now we will use the new CSV file, which will be employee2.csv. Now we are using this particular table because we have an additional column in this particular table, which is the country column. Now, as discussed before, we will be grouping the employees based on country. Let's see our data first. So we have countries such as USA, India, UAE. So these are the 3 countries that we are having in our CSV file. So we will be categorizing the employees based on their countries. So this is the particular command that we will be using. So maybe I made an error while creating the table. I think I gave a wrong table name here. So let's drop our table. So by mistake, I gave different table, that is employee order. So to drop a table, you just need to use the keyword drop and it's done. Yeah, the keyword table was missing. So you need to type in drop table and the table name, and the table gets dropped. So we were supposed to create a different table, that is employee group. So now let's create a new table, that is employee group. Employee group has been created. Now let's try to add in data into the employee group. So we have used employee 2 here because the employee 2 has another column which is based on country. So the countries that we are having here are India, USA, and UAE. So we will be using the group by function here, and we will categorize the employees based on their countries. So there you go. You can see some MapReduce jobs getting executed. Yeah, there you go. We have categorized the employees based on their countries, that is India, UAE, and USA, and the sum of the salary. So the guys working in India, and their summation of the salary is 90,000, and similarly UAE is nearly 1,05,000 and USA is 80,000. Now let's also execute a different command based on group by. So here we'll be using group by function, and we will categorize based on the country as well as the summation of the salary, which is greater than or equals to 15,000. So it's similar to the previous command. So you can see the data got executed and we got the same output. Now let's move ahead and understand order by and sort by methods. So for that, we'll create a new database, orders. Now we'll use orders. Now let's create a new table again. So the new table is employee order, and the table got created. Now let's load the data into this particular table. By now, I think you have some good practice of how to create a database, how to create a table, and how to load data into that particular table. So the data got loaded, and now we are going to order the data present in this particular table based on the descending order of their salary. So you're seeing some MapReduce jobs going ahead. So here we'll see the employees ordered based on their salaries in descending order. So the highest salary will be at the first place and the lowest salary will be at the last place. Yeah. So we have Sanjana at the first position with 40,000 as the highest salary, and she's working for UAE. And we have Chaitanya with lowest salary, 15,000, working for India. Now let us also execute another command based on sort by. So first we try to execute a command based on order by. Now let's see the same output using sort by. So basically both work in the same way. So there you go. We have sorted the records based on descending order of salary. Now that we have learned what are the various operations that can be performed in Hive, that are the arithmetic operations, logical operations, and also some of the functions such as maximum, minimum, group by, order by, sort by. So these are the various operations and functions that you can perform in Hive. Now let's move ahead into the last type of operations that can be performed in Hive. Those are the joins. So for that, let's again create a new database. So here I'll be creating a new database that is Edureka join. And followed by that, let's use this particular database now. For that, we need to use the keyword use, and there you go. We are in Edureka join. Now let's create a new table for that. So the table will be emp join here. You can see that I forgot to mention semicolon. So now the table got created. Now we shall load the data into this particular table. So now I've created the first table, that is employee table, and I'm loading the employee data into this particular table. Now to perform join operations, we always need two tables. So in this particular database Edureka join, I've already created the first table, that is employee join. Now let's create second table, that is the department table, which will be present in the same database. So this particular table is a department table, which will be having the entities that are department ID and department name. Now let's load the data of department into this particular table. So the data has been loaded. So you can see the employee2.csv had the columns ID, name, salary, age, and country. And similarly, the department.csv has the entities which are department ID and department name. So the department IDs are present here and the names are development, testing, product, relationship, and admin and IT support. Now we have created both the tables and we have loaded the data also. Now we have 4 different joins available in Hive. They are inner joint, left outer joint, right outer joint, and full outer joint. Now let's perform the first type of join, which is the inner joint. So in inner joint, we are going to select the employee name and employee department. And based on the employee ID and department ID, we are going to perform the join operation. That is the first join, inner joint. So you can see some jobs getting executed. So the map reduce task successfully completed. So the first set of join has been successfully finished and the output has been generated. Now let's try out the second type of join, that is the left outer join. So the only difference is that we are using the keyword left outer join. Now you can see one of the job got started. So you can see the output has been generated as well of the left outer join. Now let's move ahead and understand right outer joint. So for right outer joint, you need to use the keyword right outer join. Fire in the command and you can see the jobs getting executed. So you can see the output of right outer join has been successfully executed or displayed. Now let's type in the last join operation, that is full outer join. So here I'm using the keyword full outer join. Fire in the command and you can see it's getting executed. So the output for full outer join has been displayed here. So this is how the join operations are executed in Hive. So we have learned how to create database, how to create table, how to load data, and the various data models present in Hive, that are the tables, databases, partitions, bucketing. And after that, we have also understood various operations that are the arithmetic operations, logical operations, and functions that can be performed in Hive, such as square root and summation, minimum, maximum. And after that, other operations such as group by, sort by, order by, and also the joins that are possible in Hive, which are inner join, left outer, right outer, and full outer. So each and every operation that could be possibly executed in Hive have been displayed in this particular tutorial, and everything is sorted here in the base of databases, and you can get all the details about this And you'll also get the code that I have used in the description box below, and you can try it out. And also, if you're looking for an online certification and training based on big data Hadoop, then you can check out the link in the description box below. And during the training, you'll get to have real-time hands-on experience with real-time data. You'll learn a lot of things in the training. And so far, so good. Now we shall also discuss some of the limitations of Hive. So Apache Hive limitations. So Hive is not capable of handling real-time data. Hive is capable of batch processing. If you have to work with real-time data, then you have to go with real-time tools such as Spark and Kafka. So it's like Hive will actually take in the data. For example, imagine you're working on Twitter and you have 1 lakh comments on a particular post. So if you had to process those 1 lakh comments, you'll have to first load all those comments into Hive. Then you need to process it. So while you're loading the data from Twitter to Hive, you may also get a few more comments that you will be missed out. So it's not preferable for real time. Hive is preferable for only batch mode processing. So followed by that, it is not designed for online transaction processing. So online transaction processing is something which only works in real time. So Hive cannot support real time processing. So last but not the least, Hive queries contain high latency. Yeah, Hive queries take a longer time to process. As you've seen, I've taken a smaller CSV file, and the time consumed to process such a small CSV file was taking so long. So yeah, Hive queries contain high latency. So these are the few important noticeable limitations of Hive.
So what were the problems associated with the relational database system? As I have already mentioned that for a Hadoop developer, actual game starts after the data is being loaded in HDFS, and the developers play around this data in order to gain various insights that are hidden in the data stored in HDFS. So, for this analysis, the data residing in the RDBMS needs to be transferred to HDFS. And you all know that the task of writing MapReduce code for importing and exporting the data from relational database to HDFS is tedious. So this is where Apache Sqoop comes to rescue and remove the pain of data ingestion. So why do we need Sqoop? It's a known fact that before big data came into existence, the entire data was stored in relational database servers in the relational database structure. But with the advancement of Sqoop, it makes the life of developers easier by providing CLI for importing and exporting the data. And Sqoop internally converts a command into MapReduce tasks, which are then executed over HDFS. It uses Yarn framework to import and export the data, which provides fault tolerance on top of parallelism. It also uses Yarn framework to import and export the data, which provides fault tolerance on top of parallelism. Not only that, it is also very useful for data analysis, high in performance, and provides command line interface. Now let's understand what is Sqoop. So before I tell you what is Sqoop, let me tell you how the name Sqoop came into existence. By now, I hope that you have got an idea that it is used for data transfer between relational database and HDFS. So before I tell you what is Sqoop, let me first tell you how the name came into existence. The first 2 letters in Sqoop stands for the first 2 letters in SQL, and the last 3 letters in Sqoop refers to the last 3 letters in Hadoop, that is OOP. So it clearly depicts that it is SQL to Hadoop and Hadoop to SQL. That is how the name of Sqoop came into existence. So what is Sqoop? It is a tool used for data transfer between RDBMS like MySQL, Oracle, SQL, etc. and Hadoop like Hive, HDFS, HBase, etc. It is used to import the data from RDBMS to Hadoop and export the data from Hadoop to RDBMS. Simple. Again, Sqoop is one of the top projects by Apache Software Foundation and works brilliantly with relational databases such as Teradata, Netezza, Oracle, MySQL, etc. It also uses MapReduce mechanism for its operations like import and export work and work on a parallel mechanism as well as fault tolerance. As I have already mentioned that it provides command line interface for importing and exporting the data, the developers just have to provide the basic information like database authentication, source, destination, operations, etc. And the rest of the work will be done by Sqoop tool itself. Sounds much reliable, correct? Now let's move further and talk about some of the amazing features of Sqoop for big data developers. First, full load. Apache Sqoop can load whole table by a single command. You can also load all the tables from a database using a single command. Next, incremental load. Sqoop provides a facility of incremental load where you can load the parts of a table wherever it is updated. Next, parallel import and export. Again, as already mentioned, Sqoop uses Yarn framework to import and export the data, which provides fault tolerance on top of parallelism. Next, compression. You can compress your data by using gzip algorithm with compress argument or by specifying compression codec argument. Next, Kerberos security integration. So what is Kerberos? It's a computer network authentication protocol which works on the basis of tickets to allow the nodes that are communicating over a non-secure network to prove their identity to one another in a secure manner. Next, load data directly into Hive and HBase. Here, it is very simple. You can load the data directly to Apache Hive for analysis, and you can also dump your data in HBase, which is a NoSQL database. Now let's see what's next. The architecture is one of the empowering Apache Sqoop with its benefits. Now, as we know the features of Apache Sqoop, let's move ahead and try to understand Apache Sqoop's architecture and its working. So when we submit our job or a command through Sqoop, it is mapped into map task, which brings the chunks of data from HDFS. And these chunks are exported to a structured data destination. And combining all these exported chunks of data, we receive the whole data at the destination, which in most of the cases is RDBMS server. Next, reduce phase is required in case of aggregations. But Apache Sqoop just imports and exports the data. It does not perform any aggregations. Map job launch multiple mappers depending on the number defined by the user. For Sqoop import, each mapper task will be assigned with the part of data that is to be imported. And Sqoop distributes the input data among all the mappers equally in order to achieve high performance. Then, each mapper creates a connection with the database using JDBC and fetches the part of the data assigned by the Sqoop and then writes that data to HDFS, Hive or HBase based on the arguments provided in the command line interface. So this is how Sqoop import and export works. Like they gather the metadata, again it submits only map job, the reduce phase will never occur here, and then it stores the data in HDFS storage. Coming to Sqoop export, it's the same thing, the data will be reversed back to RDBMS. So here the Sqoop import tool will import each table of the RDBMS in Hadoop, and each row of the table will be considered as a record in the HDFS, and all the records are stored as text data in the text files or binary data in sequence files. On the other hand, the Sqoop export tool will export the Hadoop files back to the RDBMS tables. Again, the records in the HDFS files will be the rows of a table, and those are read and passed into a set of records and delimited with the user-specified delimiter. So this is all about the Sqoop architecture and its import and export. Now, let's execute some Sqoop commands and understand how it works. So at the first, we have Sqoop import. That is, it imports the data from RDBMS in Hadoop. The command goes very simple. Here, you have to just provide the connection for MySQL, your IP address, your database name, your table name, the username for MySQL user. If you have set privileges for password, you can specify the password or it is not required, and the target directory. Now, let's see how to execute. So I'll open my terminal and check whether all my Hadoop daemons are up and running or not. So I can see that all my Hadoop daemons are up and running. So now let's execute Sqoop help and see whether the Sqoop has been properly installed or not. So these are the available commands in Sqoop. Here I will show you the execution and explain you few of these commands. Now this is also properly been set. Now I will open another terminal and connect to MySQL database. The command goes like this. My user is Edureka, so I'm giving it as Edureka. You can give it as root if your user is root. Simple. So now I'm into MySQL database. If you want to create a database, you can create a database by giving this command, create database, database name, etc. As I have already created a database, so I'll just specify show databases command to list the database present in the MySQL database. So now these are the list of database present here. So now I want to use employees database. So I'll give use employees. Database got changed. Now I want to list the tables present in the employees database. So I'll give show tables. So these are the 11 tables present in the database employees. Now let's say I want to use employees table. So what will I do? I'll just give select star from employees. That is table name. So it's just a huge amount of data that is present in this database. So there are these many rows present in this table. Now open the other terminal where you have executed this command, and here I will show you how to import the data present in that table to HDFS. So how we are going to do that? By using Sqoop import command. The command goes like this. The IP here is localhost, and you know that employees is my database name, and the username will be Edureka, and the table that I have chosen is employees. So I have not set any privileges for password, so I'm not specifying the password over here. So it got executed, and you can see the number of job counters, the MapReduce framework, the input records, output records, etc. So what happens after executing this command? The map task will be executed at the backend. Now let's check the web UI of HDFS. That is, the web UI port for HDFS is localhost 50070. And let's see where the data got imported. One important thing to note, I have not specified target directory. So by default, the data will be imported to this folder, user, Edureka, and employees. So here you can see the 4 different part files where our data got imported. So you might be thinking, why 4? Correct? Here I have not specified the number of mappers. So by default, it takes the number of mappers to 3 and then gives the output in 4 different part files. So let's open the part file and see how the output will be. So here you can see the data is imported from RDBMS to HDFS. There's lots of data being present over here. I'm just scrolling down and it's not coming to an end. Similarly, the output will be same in the other part files as well. So this is all about the simple Sqoop import command without specifying the target directory and the number of mappers. Now let's see how to import the data from RDBMS to HDFS by specifying the target directory. This part remains out to be the same. Now I will do one thing. I'll specify the number of mappers as 1 so that your output will be in just one single part file, and then I will specify the target directory as well. And I will name the target directory as employee 10. Enter. Again, it takes a lot of time to execute because there is a lot of data present in the database. So it got executed and retrieved these many records. Again, you can see the MapReduce framework, the number of bytes written, number of read operations, write operations, etc. Now again, let's go to the HDFS browser and see the output. So I had specified the target directory name as employee 10. So you can see it here. And the output is just in one single part file because I have specified the number of mappers as 1. In this case, you can control the number of mappers independently from the number of files present in the directory. So the entire records will be present in one single part file. So this is the output. Now, let me tell you how to import the command using where clause. Here you can import a subset of the table using the where clause in Sqoop import tool. It executes a corresponding SQL query in the respective database server and stores the result in a target directory in HDFS. So this is how the command goes. The same command as before. I'll just change the name of the target directory. I'll specify employee 11 and I will increase the number of mappers to 3. And here I will specify the where clause. So let's give a condition like where the employee number will be greater than 49,000. It should display the output. Enter. So what you expect your output will be. So here it displays the output records of the employees whose employee number is greater than 49,000. So here it retrieved these many records which are above the employee number 49,000. Now let's check the output. So I have specified the target directory name as employee 11. So here you can see the output that it has retrieved the records of employee number which is more than 49,000. So I hope you understand how to do this. Next, let's see how to import all the tables from the RDBMS database server to the HDFS. Here, each table data is stored in a separate directory and the directory name is same as the table name. It is mandatory that every table in that database must have a primary key field. The command will be simple like simple import, but just that you have to remove the table name and you have to replace the import with import all tables. That's all. So it will retrieve all the tables present in the employees Okay, so it imported all the tables from RDBMS to HDFS. Now let's check the output. Again, I have not specified the target directory file. So by default, it will be in user Edureka, and you can see here it imported all the tables present in the database to HDFS. So these are the various tables present in RDBMS, and now it is present in HDFS. So this is how import all tables command works. So this was all about executing import command in various ways. Now let's move further and see how the Sqoop export works. It exports the data from HDFS to RDBMS, correct? Again, the command goes very simple. You have to specify the connection, your table name, username, and instead of the target directory, you have to specify the export directory path. So let's see how it works. One important thing to notify, the target table must exist in the target database. That is, the data is stored as records in HDFS, and these records are read and passed and delimited with the user-specified delimiter. The default operation is to insert all the records from the input files to the database using the insert statement. In update mode, Sqoop generates the update statement that replaces the existing record in the database. So first we are creating an empty table where we will export our data. I'm going to create a table called employee0. The primary key value should never be null, so I'm specifying it as not null. So here I created an empty table called employee0, and now I'll show you how the Sqoop export works. Here, instead of import, I'll make it as export. This is the database name, and I have created a table called employee0, and I'm going to specify the path for export directory. Simple, that's all. So you can see here it exported all these records into the RDBMS. So now let's cross-check. I'm going to give select count star from the table name that I have specified to export the tables. So you can see the entire records got exported to this table. So this is how the Sqoop export works. Now let's see how to list the database present in the relational database. Here, you need not even specify the database name because you're going to list the database that is present in the relational database system. So you're going to specify list databases and execute the command. So the databases present in the relational database system is test, JDBC test, employees and information schema. Again, let's cross-check. I'm going to give show databases. It retrieved the same database. So the result tallies. So we can also list the tables present in the database. Let's see how to list all the tables present in the database. Again, it's very simple. You have to just specify the database name, like here, and give list tables instead of import. So you can see that it listed all the tables present in the database, employees. So again, let's cross-check. Show tables. Same thing. And now let's see what is 𝐄𝐽. In object-oriented application, every database table has one data access object class that contains getter and setter methods to initialize the objects. And 𝐄𝐽 generates DAO class automatically. And it also generates the DAO class in Java based on the table schema structure. So this is a simple command. Let's see how to execute it. Here I will give Sqoop 𝐄𝐽 and give the connection and the database name as employees. And I'm going to specify the table name as well. So it is going to create an employee jar file in which the backend code will be generated. So I'll copy this path and jump into this directory. So you can see here that it created employees class, jar file and the Java object file as well. So now let's open the file system and check for the file. So what was the name of the file? It ends with 539D9. So here is the folder. So in this you can see the object file that is being generated. So this is the backend code that is being generated. So this is all about how the Sqoop 𝐄𝐽 works.
Now let's start with the basic level questions. The first question is, what is AWS? AWS is nothing but Amazon Web Services is a cloud computing platform offering over 200 services, including infrastructure as a service, platform as a service, and software as a service. It provides scalable, cost-effective solutions, computing power, database storage, and content delivery services. It helps businesses scale and manage their operations efficiently and affordably. Moving on to the next question. What is EC2? Amazon Elastic Compute Cloud is a web service that enables users to create and run virtual machines in the cloud. It aims to simplify web-scale cloud computing for developers by providing secure, resizable compute capacity. This allows developers to easily run applications and scale them as needed. The next question is, what is S3? Amazon Simple Storage Service is a cloud-based, scalable, and secure object storage service that enables users to store and retrieve data from anywhere. It offers industry-leading scalability, data availability, security, and performance. With S3, you can easily manage and scale your storage needs, making it perfect for backups, archives, and handling large amounts of data efficiently. The next question is, what is a VPC? A virtual private cloud is a secure, isolated private cloud hosted with a public cloud. It allows customers to run code, store data, and host websites. VPC roles define which peer devices process, bridge protocol data units, and respond to address resolution protocol requests, allowing for seamless integration with public cloud providers. In simpler terms, a VPC provides a private network within the cloud, giving you control over your resources, network configuration, and security settings, while still benefiting from the scalability and flexibility of the public cloud. Here is the next question. Explain AWS Lambda. AWS Lambda is a serverless computing service that allows users to build applications without managing servers. It's ideal for applications that need to scale up rapidly and scale down to zero when not in demand. It allows users to execute code in response to events like data changes. In other words, Lambda automatically handles the infrastructure for you. So, you can focus on writing code and responding to events without worrying about server management, making it cost-effective and flexible solution for modern applications. The next question we have is, what is autoscaling? Autoscaling is a cloud computing feature that automatically adjusts resource allocation based on a user demand, monitoring metrics like CPU usage and incoming traffic. It allows organizations to scale cloud services like server capacities or virtual machines up or down. In other words, autoscaling adjusts resources automatically to match your needs, ensuring efficient performance and cost savings. It helps handle changes in demand without manual intervention. Here is another question. What does ELB stands for? In other words, autoscaling adjusts resources automatically to match your needs, ensuring efficient performance and cost savings. It helps handle changes in demand without manual intervention. In simpler terms, ELB helps evenly distribute traffic to your servers, ensuring no single server gets overwhelmed. It automatically adjusts to handle traffic changes, keeping your applications running smoothly. Here is another question. Define CloudFront. Amazon CloudFront is a self-service, pay-per-use content delivery network service from AWS that securely transfers global content, including static and dynamic files, without long-term commitments or minimum fees, ensuring high performance and security. CloudFront speeds up the delivery of your website content to users worldwide and protects it with strong security measures, all while being cost-effective and easy to use. Moving on to the next question. What is RDS? Amazon Relational Database Service is a cost-effective web service that enables users to set up, operate, and scale relational databases in AWS Cloud. It enables efficient data storage, organization, and access for business purposes like modeling, reporting, and analysis. An easy way we can say, RDS makes it easy for you to manage your databases, handle your data efficiently, and focusing on using that data for your business without worrying about the underlying infrastructure. The other question we have here is, what is DynamoDB? Amazon DynamoDB is a serverless, key-value NoSQL database service optimized for high-performance applications. It delivers single-digit millisecond performance at any scale, improving relational database performance. Or in other words, DynamoDB allows you to quickly and easily manage your data, giving you fast access to information without the hassle of server management. So you can focus on building great applications. Moving on to the next question. Explain Route 53. Amazon Route 53 is a DNS web service that connects user requests to internet applications on AWS or on-premises. It translates domain names into IP addresses, allowing computers to communicate and verify reachability, availability, and functionality. Route 53 helps you ensure that when someone types your website's address, it gets directed to the right place quickly and reliably, making sure your site is accessible and working properly. The other question we have here is, what are security groups? A security group in AWS acts as a virtual firewall for EC2 instances, controlling incoming and outgoing traffic. It filters traffic based on rules, allowing users to specify protocols, ports, and IP addresses. These security features are crucial in cloud computing to ensure the security of resources and maintain a secure network environment. In easy way, security groups help you protect your EC2 instances by controlling what traffic is allowed in and out, keeping your resources safe and your network secure. Here is another question. Difference between public and private subnets in AWS. The key differences between public and private subnets in AWS are: in public subnet, resources can access the internet directly. But in private subnet, resources cannot access the internet directly. The public subnet is connected to an internet gateway, but the private subnet has no direct route to any internet gateway. Lastly, public subnet used for public-facing applications like web servers, but the private subnet used for sensitive data and internal applications. Let's move on to the next question. What is IAM? AWS Identity and Access Management is a web service that enables users to control access to AWS resources and services securely. It is a cybersecurity discipline that deals with user access to digital resources and their usage. IAM systems prevent hackers and ensure users have the necessary permissions to perform their tasks, ensuring that only authorized users can access AWS resources. Or in other words, IAM helps you manage who can access your AWS resources and what they can do, keeping your data safe and ensuring that only right people have the right permissions. Let's move on to the next question. Define EBS in Amazon. Amazon Elastic Block Store is a scalable, high-performance storage service from AWS that is designed for Amazon Elastic Compute Cloud instances. It allows users to create storage volumes and attach them to EC2 instances, enabling them to create file systems, run databases, or use them in various ways. EBS is easy to use and scalable. Or in other words, EBS provides you with flexible and reliable storage that you can easily connect to your EC2 instances, helping you store and manage your data efficiently as your needs grow. The next question here we have is, what is SQS? Amazon Simple Queue Service is a managed message queuing service in AWS that enables users to send, store, and receive messages between software components. Introduced in 2004, it decouples and scales distributed software systems and components, supporting programmatic message sending through web service applications over the internet. Or, in other words, SQS helps you manage communication between different parts of your application by queuing messages, making it easier to handle data flow and scale your system effectively. Let's see the next question. What is CloudFormation? AWS CloudFormation is a service by AWS that enables developers and businesses to create and manage AWS and third-party resources in an orderly and predictable manner. It provides templates for defining and setting up cloud infrastructure, allowing users to define and deploy applications and services as code, even without technical knowledge. It simplifies management, scaling, and updating of cloud resources. The next question is, explain Cloud Trial. Cloud Trial is a service by AWS that tracks user activity and API usage, aiding in auditing, security monitoring, and operational troubleshooting. It records all modifications and API calls in an AWS account, enabling the identification of potential security issues and compliance requirements. In simpler terms, Cloud Trial helps you keep track of everything happening in your AWS account, making it easier to monitor security, troubleshoot problems, and ensure you're meeting compliance standards. Let's see the next question. What is the shared responsibility model? The shared responsibility model is a framework that outlines the responsibilities of a cloud service provider and a customer in securing cloud services and data. It suggests that two or more parties play a role in ensuring security of distinct elements within the public cloud environment. AWS is responsible for protecting the infrastructure running all services offered in AWS Cloud. The last question in the basic level is, what is the well-architected framework? The AWS well-architected framework is a set of best practices designed by AWS to help businesses build and operate efficient, secure, and reliable cloud-based systems. It guides how well your architecture aligns with cloud best practices, covering aspects such as operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. In simpler terms, this framework helps you design and maintain your cloud systems by providing guidelines to ensure they are effective, secure, and cost efficient, covering all the key areas of the successful cloud setup. Now let's start with the intermediate AWS interview questions. The first question we have here is, what are EC2 Spot Instances? In AWS, EC2 Spot Instances is a virtual server that lets you use extra cloud capacity at a big discount, up to 90% cheaper than regular prices. You can place a bid to use it, and as long as your bid is higher than the current price, you can keep running your server. The next question here we have is, what is Elastic Beanstalk? Elastic Beanstalk is a service that helps you easily deploy and manage web applications on AWS. It supports different programming languages like Go, Java, .NET, Node.js, PHP, Python, Ruby, and even Docker. Elastic Beanstalk automatically handles the setup, such as creating a runtime environment, managing servers, and scaling the application as needed. Moving on to the next question, what is a NAT gateway? A NAT gateway is a service in AWS that allows your private servers to connect to the internet. For example, if your servers need to download updates or access external web services, they can do so through the NAT gateway. The next question we have is, what is an Elastic IP? An Elastic IP is a static, public IP address provided by AWS that you can assign to your resources, such as an EC2 instance, unlike a regular IP address that might change when you stop or restart your instance. An Elastic IP remains the same, making it easier to manage your connections and ensure your server is always accessible at a consistent address. Here is another question. What are S3 lifecycle policies? S3 lifecycle policies are rules that you configure in AWS to automate the management of your data stored in S3. These policies allow you to automatically transition objects between different storage classes based on their age or delete them when they are no longer needed. For example, you can set a policy to move files that haven't been accessed in 30 days to a cheaper storage tier like S3 Glacier, or to delete objects after 1 year. The next question we have is, what is RDS Multi-AZ? RDS Multi-AZ is a feature in AWS that enhances the availability and reliability of your relational database. When you enable Multi-AZ, AWS automatically replicates your database to a standby instance in a different availability zone with the same region. Let's move on to the next question. How does Lambda scale? AWS Lambda scales automatically based on the number of incoming requests. When your function is triggered, Lambda runs an instance of it. And as more requests comes in, Lambda creates additional instances to handle the load. This scaling happens in real time, without any need of manual configuration. Lambda can handle thousands of requests per second, and it scales up and down as needed, ensuring that your application remains responsive under varying loads without any extra infrastructure management. Now let's see the next question. What is a network ACL? A network ACL, that is access control list, is a layer of security that acts as a virtual firewall for controlling inbound and outbound traffic at a subnet level within your VPS. Each network ACL has a list of rules that either allow or deny traffic based on IP address, protocol, or port number. These rules are stateless, meaning both inbound and outbound rules must be explicitly defined. Network ACLs help you protect your AWS environment by filtering traffic before it reaches your instances, adding an additional layer of security. Here is another question. How do you secure S3 buckets? Securing S3 buckets involves several best practices. First, set proper permissions, that is, ensure that only authorized users and services can access the buckets by setting appropriate IAM roles and bucket policies. Then is use encryption. Enable server-side encryption to protect your data at rest and consider using SSL, TLS for data in transit. Then is enable logging. Set up S3 logging to track access requests, which can help you monitor and audit bucket activity. Let's see the last question of the intermediate level. What are CloudWatch alarms? CloudWatch alarms are monitoring tools within AWS that helps you keep track of your resources by sending notifications when specific metrics exceed defined thresholds. For example, you can set up an alarm to notify you if CPU usage on an EC2 instance goes above 80% for a certain period, or if the available disk space drops below a certain level. These alarms can trigger automated actions like scaling your application, rebooting an instance, or simply sending an alert to your email or SMS. Now let's move on to the advanced level, where we will discuss the scenario-based questions. So here we have the first question. How would you design a highly available, fault-tolerant architecture for a web application that requires minimal downtime during maintenance and unexpected failures? The answer here is, to design a highly available and fault-tolerant architecture, use multi-AZ deployments. Deploy your application across multi-availability zone to ensure high availability. For databases, use Amazon RDS with multi-AZ deployments to ensure automatic failover. Then, implement load balancing. Use an application load balancer to distribute traffic across multiple EC2 instances in different AZs. Then, auto-scaling. Set up auto-scaling groups to automatically adjust the number of instances based on demand and health checks. Next, health checks and monitoring. Use Amazon CloudWatch to monitor instance health and also set up alarms for automatic recovery actions. Lastly, we have blue or green deployments. Utilize AWS Core Deploy or Elastic Beanstalk's deployment policies for blue or green deployments to minimize downtime during updates. The next question is, your application requires low latency access to data stored in S3, but you have users distributed globally. How can you optimize the data access performance? The answer we have is, implement Amazon CloudFront as a content delivery network to cache and deliver S3 data from the edge locations closer to your users. Additionally, use S3 transfer acceleration to speed up uploads and downloads. Moving on to the next question. Describe how you would secure data in Amazon S3, ensuring that access is controlled and data is encrypted at rest and in transit. To secure data in Amazon S3, firstly, enable encryption. Use server-side encryption with AWS Key Management Service to encrypt data at rest. For in-transit encryption, ensure SSL TLS is used when accessing S3. Next is implement bucket policies. Set up bucket policies and IAM roles to restrict access based on user or service requirements. Then, use access control lists. Configure ACLs to grant or deny access to specific users or groups. Here is another scenario-based question. You need to ensure that a critical application can automatically recover from regional outage and continue to serve users with minimal decryption. How would you architect this solution? The answer is, deploy the application across multiple AWS regions using Amazon Route 53 for DNS failover and AWS Global Accelerator for global traffic management. Implement cross-region replication for databases and use auto-scaling groups across regions. Here we have the last scenario-based question. How would you architect a scalable, fault-tolerant data processing pipeline using AWS services? To architect a scalable, fault-tolerant data processing pipeline, first point is data ingestion. Use Amazon Kinesis data streams or AWS Glue to inject and process data in real time. Next is data storage. Store raw data in Amazon S3 for durability and cost-effective storage. Then we have the data processing. Use AWS Lambda for serverless processing or Amazon EMR for large-scale data processing tasks. Then we have the data transformation. Utilize AWS Glue for ETL operations to prepare data for analysis. Next, data analytics. Use Amazon Redshift or Amazon Athena for data acquiring and analysis. Last, we have the fault tolerance. Implement retries and error handling in Lambda functions and use S3 versioning to recover from data corruption. In summary, preparing for an AWS interview requires a solid understanding of core AWS services, architecture best practices, and hands-on experience with cloud solutions. As focused on key topics like EC2, S3, Lambda, IAM, and VPC, as well as concepts like scalability, security, and cost optimization. Practice explaining your real-world experiences and stay updated on new AWS features. With clear, concise answers and confidence in your knowledge, you'll be well equipped to tackle any AWS-related interview questions.
And with this, we have come to an end to this full course on AWS Data Engineering. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.